Oh, so, okay, yeah. Oops. Okay, had not enabled all the microphones. But yeah, so um,
Do we need to
yes,
do intros again?
yeah. I guess we need to introduce again. So yeah, I'm Dilhan. I'm currently at the University of Illinois, who is competing in the Mid Central Regional, which that's in an hour.
I'm Derek Isman. I'm currently in Calgary, and I'll be cheering for the University of Calgary, which is one of the Rocky Mountain sites. Um, and I've been a longtime competitor, and I'm also a judge for the finals.
Ah, and yeah, I competed at World Finals last year, and now that I've retired from ICPC, I'm doing this stream, and I helped a little bit with coaching. So yeah, so the Rocky Mountain contest started I think 3 minutes ago. So far, it seems there's no submissions, and then the other two, North Central and Mid Central, will start in an hour.
So, what is your team's strategy at the very beginning of the contest? What order do you look at the problems?
I think, I haven't talked to all of our teams, but I think it's usually you just like split into like first third, middle third, last third. Each person looks for some easy problem to start off with, and then like once they so it's like usually in these regional contests there's like uh, a few easy problems that you can just knock out at the beginning. You just like you can read it and pretty quickly see if you can solve it. Um, and yeah, I think the strategy is to try to find those easy problems, then take computer and solve them as quickly as possible.
For an easy problem set, I guess it matters a lot that you hone in on the easy problems as quickly as you possibly can, so you get a head start.
Yeah, I mean, to be honest, it doesn't matter too much in penalty, but the small, like a couple minutes in penalty, I don't know. It's pretty reasonable that the contest will be decided on penalty rather than problems for a regional contest.
Right.
Still no submissions from Rocky Mountain. Um,
We'll give them another 5 minutes.
yeah, it's yeah, pretty early. And like, ah, seems one, so submission on A has come in.
Ah,
Uh,
there we go.
Not sure why a different team popped up in the standings from the team that submitted.
Utah Valley U, our first submission.
Ah, and seems they have gotten the first AC of the contest. Uh, okay, I drifted. Oh yeah, so if you go to the RMC website, it seems the problems are live, so we can take a look
Okay,
at A.
sure.
Uh, are you going to? I think you should share your screen if that's possible.
Hmm. Uh, sure. Let me just find the contest.
Okay, yeah,
You said that the problem set is available.
yeah. I just clicked on the leaderboard. Uh, I'll send it again, but
Sure.
yeah, the problem should be available to see.
Cool.
And yeah, I think for anyone who's watching, if you, it should, yeah, you can see the link on the at the bottom of the screen right now for Rocky Mountain, and you can see the problems as well.
We have problem A, adrift at sea. Let me see if I can bring that up. Share my screen. Okay. We're still trying to figure things out, so bear with us.
Yeah,
Um, oh, I can't figure out how to do this. Share. All right. Um, that should work, hopefully.
I think I need to.
Actually, I might be sharing the wrong thing. All right, so we have problem A, adrift at sea. You're
I
developing a
think.
navigation.
Okay, wait. I think there's a
Yeah,
problem on my end. It's
okay.
showing the wrong. How to fix this?
Can you see it on Zoom?
I can see it on Zoom, but currently, I need to. It's. I need to fix my OBS to make it work.
Okay. Meanwhile, I guess I'll take a look at the.
Okay, yeah. This. Yeah, I think this is. This is not optimal, but it should work for now.
Okay. And so far, we still have no other submissions. So we have the one submission at 4 minutes, which is pretty impressive.
I can see. I think there's. Uh, there seems to be other submissions that I can see. But okay,
Really?
I'm just trying to figure out how to get both the scoreboard and the stream at the same time. But oh yeah, this is bad because when I talk, you can no longer see the problem. Oh no. Okay.
Yeah, I mean, you can pin in Zoom. You can pin my screen share, so that's always visible, I think.
I can currently I see. Sorry, 7 teams have solved a problem. Uh, and uh, I think a couple of others have submitted. Yeah, I see a wrong answer from Arizona State, one of the Arizona State teams, and yeah, 7 teams have solved A and 1 team has solved L. Okay, let me try and figure out how to. I don't understand why this isn't working.
Oh, we've got an hour to figure it out before the other contests go live. So this broadcast, in case you don't know, is going to be for 3 different contests that are all running at the same time. So the Rocky Mountain contest started an hour earlier, and then we have the Mid Central North America contest and the
North Central.
North Central. Okay.
And now I can switch back to here. Okay, yeah, so you can see the queue and you can see the problem.
Okay, great. All right, so adrift at sea. You're developing a navigation system for sailing boats, but the normal navigation systems do not work. Instructions like turn left are meaningless because you're out on sea. So such instructions must be followed by the amount to turn in degrees. In addition, you don't use left and right, you use port and starboard. So given the current heading and the desired heading of the sailing boat, your task is to provide an instruction to turn to the desired heading. So you're going in one of the 8 compass directions, and then you want to change your heading from say you're going north, you might want to change your heading from north to east. And then you figure out what instruction you have to give. Do you give port or starboard? In this case, you give starboard 90, I guess. And maybe I should have included the examples. But yeah, so you're supposed to output a line in one of 3 forms: keep going straight, U-turn, or turn a particular number of degrees in a particular direction. So, lots of ways to solve this.
Yeah,
I mean, it's
yeah. And
pretty
yeah, there's
straightforward.
many ways you can just like you assign each of the 8 directions to a number, and then like depending on the difference between the two numbers, there's just a couple of if statements.
Hmm. I think it's mainly going to be a check on the details. Like, can you get the details right without any
Yeah,
boundary
and it
pieces
seems
messing around?
seems I think 9 teams have currently solved it, and yeah, pretty quickly. 12 minutes, yeah, 12 minutes in the contest, and it's the first problem many people will read, uh, and then yeah, just figure out all the details, and seems that people are getting quite quickly.
I think what I might do is I might just take so first direction. So dire one would be like a number from 0 to 7, and then dire two would be a number from 0 to 7, and then your answer is just going to be a list of strings. In sorry, forgive my writing. um, it would have to be minus. So it would be dire two minus dire one, right? You'd want to change
Yes.
from dire two to dire one, and then you add 8 because C++ is weird when it comes to doing negative mods. And so you could just like encode the strings like that, and that would be the simplest way.
Oh yeah, yeah, that seems quite simple.
Lots of other ways.
Yeah. Uh,
Okay. What other problems are people solving?
yeah. So it seems that the other solved problem right now is problem L.
Okay, let's take a look. Am I going to be able to? I'll have to start a new screen share, but that's okay.
Mm-hmm.
Problem L.
Yeah. So User Valley has solved both A and L, and then most of the other teams have solved, or not most of the other teams, but a couple other teams have solved either A or L. Another submission on L from BYU, and they become the second team with 2 problems.
For problem L, video games. This is right up my alley. Let me just share my screen. And all right. Hopefully that works. So what do we have? Alice, Bob, and Charlie share a collection of video game cartridges. So this way, only one of them needs to own a game in order for them all to enjoy it. Oh, this is hailing back to the days when cartridges existed and you didn't just buy through an online store. So the popular video games right now are a fishing game, a golf game, and a hockey game. Initially, Alice has the fishing game, Bob has the golf game, and Charlie has the hockey game. Over time, the games get passed around between them, and it can be hard to keep track of who currently has each one. So, given a sequence of requests indicating that a particular friend wants to play a particular game, determine who they have to borrow that game from. Okay, so you're getting a bunch of requests in the form of person one wants to play game one, and then you are just you're going to maintain the state as it updates, as the games get transferred from person to person, and then you're just going to describe what happens to the state. So, for instance, in this example, Alice borrows. Alice does not have golf at the start, but Alice wants to play golf, so Alice will borrow the golf game from Bob, and then Alice now has the golf game from then on, and you have to track that, and so on and so forth. So you see in the second one, then Alice is the one with the golf game, so Bob has to borrow it from her. Okay, seems like seems easier than A, to be honest.
Yeah, I mean, it's a classic effect of. I mean, it's not a classic effect, but it's just. I mean, A is the first problem.
Yep.
Almost every team will have someone read A at the start of the contest. They'll see it's easy. Yeah, this problem seems more straightforward, less edge cases, um,
Yep.
and yeah, it seems the teams are figuring that out as well.
Do we have any submissions for any other problems?
No, and yeah, you really every team can look at the scoreboard, see that A and L are their first 2 problems to do, and
Yeah.
but
There's a lot of groupthink in these contests, right? Like people will look at the first problems that are solved, and those are the ones that they'll focus on, and sometimes they'll miss an easy problem that's elsewhere.
and also yeah, or if you can stop the screen share, or okay, I don't know, it's probably a good way to do this, but currently it'll be on the screen share if you're screen sharing something, I'll show that rather than our faces. Uh, oh yeah, seems that Saskatchewan has submitted to G. Uh,
G. All right.
so yeah, maybe we can look at that problem next if they get AC,
Sure.
which they do not. Uh, Wrong answer in G for submit to a
Uh-oh.
problem other than ARL.
Wrong answer. Okay. Problem G, genies. All right. We'll take a look at that. Hopefully the solution is working. All right. Aladdin has found a magical lamp, and after rubbing it a few times, the genie appears. Um, Aladdin told him, I have heard about genies. I can make 3 wishes, but cannot wish for more wishes, right? The genie responds with, there is a loophole for stronger genies like me. Oh, okay. It turns out there's a hierarchy of genies. A genie of rank K is allowed to grant K wishes, and all K wishes must be used. Each genie can grant at most 1 wish to conjure another genie who can then grant more wishes. However, you can only conjure a genie of lesser rank. In fact, it has to be less by C. So C is a given constant. So for instance, if C is 2, then a genie of rank 5 can conjure any other genie of rank 1, 2, or 3. Um, so Aladdin can always make a wish. So if Aladdin gets a rank 5 genie, then he'll get 5 wishes from that rank 5 genie, and each of those wishes can be of the form to conjure another genie of a lower rank. A real wish is any wish that does not conjure a new genie. Okay. And so the question is, can Aladdin make exactly W real wishes? So you're not trying to maximize the number of wishes. You are trying
Yeah,
to hit a specific target.
and it could be uh, a common pattern for this type of problem is you do figure out the maximum, and then sometimes it's possible that like anything between the minimum and the maximum is possible, but then sometimes it's not. Uh, so
So figuring out the maximum here seems fairly easy. You just want to always summon the maximum rank genie that you can.
yes, and yeah, um, so yeah, summoning any genie is will always give you like any genie will grant at least 1 wish. So you can't waste wishes by summoning a bad genie of rank 0. That's not an allowed move. So
Right.
yeah, you always have to make at least uh, you always have to make at least K real wishes, and yeah, the
And
maximum.
there's no point in using a real wish on a genie that's higher than that's C plus 1 or higher, because you might as well just summon a genie of rank 1 and it's the same thing.
Uh, yeah. So yeah, it basically becomes what's the maximum number of genies of rank. Well, it doesn't have to be 1 because like rank 2, for example, if C is 2, then rank 2 cannot summon
Correct.
rank 1. But
Correct.
yeah, so yeah. Oh, but yeah, the
But
maximum should.
if C is 2, then all of your wishes for rank 3 or above are just going to be summoning lower genies
Mhm.
of some sort. There's no point to not do that, because you can always just summon a genie of rank 1, and then that gives you a real wish anyway.
Uh huh. So yeah, I think for this problem, it seems like uh, I feel like you can just do some sort of DP of um, you're given so like because like W is almost 500, you can be like for each rank of genie, how many wishes can I make? And like, can I make 1 wish? Can I make 2 wishes? And all the way up to 500 wishes. So there's uh, because the rank is between 1 and 200, and the number of wishes we care about is between 1 and 500. That's 10 to the 4 states that we need to consider in this DP. Uh, and it just then we have to figure out how to do the transitions for this dynamic programming problem.
So the question is dynamic programming necessary? Do you think that you cannot actually hit some targets?
Um, it's hard to think about.
We could look at the samples. By the way, just for people who don't know, like we haven't seen these problems before. Anything we're discussing, we could be making mistakes on.
Yeah.
So don't take our word as gospel. But yeah, I see a sample input 3 that has a no output.
If you can scroll down on your screen share, or is it?
I can't, I can't actually,
Oh, okay.
but let's see. So the case 98. So rank, no, so you want to get 98 wishes. You are getting a rank 40 genie and C is 10. So that is interesting that you cannot make 98 wishes out of that.
Yeah, that seems. Yeah, because you can definitely get more than 98 wishes. You just summon 10 genies of
Sure,
rank 30.
sure. You can get many, many more. So you can get 40 wishes. That's the minimum. You have to use all your wishes. You can get
Yeah.
40 wishes at minimum. Um, and if you summon one rank 30 genie, then that would get you an extra 29 real wishes, right?
Yes.
So you can get any number between 0 and 29 extra wishes. Why can't you do it twice? I might be missing something about this problem. Why can't you just summon, say, a rank 30 genie and a rank whatever brings you to 98?
So rank 30,
Why can't you summon two rank 30 genies? That would,
and that you claim that would be so 30 plus 30 plus 38. Oh yeah,
yeah.
that is. Okay, yeah, maybe we've misread this problem.
Yeah, we might be missing something because it says the answer is no.
Oh,
And
each
sometimes
genie
reading the
can grant at
samples.
most one wish to conjure another genie who grants more wishes.
Ah, okay.
Yeah.
Thank you. I did miss that. Okay. So yeah, it sounds like your DP approach might be the best then, because the numbers are certainly small enough for DP, right?
Yes. So yeah, it's just you case on which. So either you summon no additional genies, or you summon one additional genie, which has and there's like 200 options uh, for which it do. There's some nuance there with. Um,
Well, I mean, you can always just yeah. Your current DP state is what genie have you summoned because you only have one genie summoned at a time.
yes.
What genie have you summoned, and then you can just summon another genie and then use all the rest as wishes.
Okay,
So
yeah, and yes,
yeah.
yes. Your states are, yeah. So as you said, number of genies, number of wishes you wish to make. So there's 500
Mhm.
times 200 states, and there's k options for what you can do. So for each state, there's 200 transitions, which is, allows you to solve the problem in w times k squared time. And it seems that uh, looking at the scoreboard, so yeah, University of Alberta has solved G with one wrong answer. Yeah, I think they were the
Okay.
team we saw submit a wrong answer before, and uh, Saskatchewan also has a wrong answer.
So yeah. So I think this is perfectly fine, and then each state you solve by trying all 200 things,
Mm-hmm. And
and
yeah,
then
there's like 201 because you can also just choose to
you
not
could
summon an
choose to do
additional
nothing.
genie, which is another
Yep.
option.
Oh, sorry. It's 0 to 500. Number of wishes up to 500.
Yes.
All right.
And yeah, for each DB state you have an answer which is either it's possible or it's not, and then that should work.
Yep. Seems reasonable, and it does look like DP is kind of required
And yeah,
because
this
you're going to have a certain set of states that are reachable, and then some states that are not reachable, and then more states that are reachable. And
yeah, I mean, yeah, potentially a greedy would work, but I think most teams would be trying a will eventually try a dynamic programming approach.
yeah, is greedy?
I
That's a
don't
good
think it's
question. If greedy works, because if the numbers were higher, could you get away with a greedy solution? I'm not actually sure.
And you can like metagame and like say, oh, if greedy worked, then maybe they would have set higher bounds. But
But
it's
I
an
think I agree
interesting
with you.
question.
It sort of seems like greedy would work, so maybe they just decided not to go with higher bounds.
Yeah.
Okay, so how are we doing on the scoreboard?
So yeah, currently, 9 teams solve 2 problems. Uh, or 9 teams with at least 2 problems. All of them having A and L. Then Arizona State and one team from Arizona State, one team from Alberta with 3. Arizona State with C and Alberta with G.
Do you want to take a look at C? Oh,
Yeah,
and
it
I just
seems
see a
like the
submission with,
only other solved problem right now.
although Arizona is trying E.
Yeah, so one
And
wrong submit for Arizona from E, one wrong submit on for Utah Valley on H. So
all right,
maybe after we look at C, we can look at those two.
sure. All right, let's look at C. Conveyor belt sushi. Gonna have to shrink this a bit to fit it in. Actually, it's gonna work. Sorry, 1 second. This is a longer problem statement, so yeah, I'm just gonna get the top in. I've always been impressed by like the ability of some of the commentators at the finals to actually like analyze the problems in real time because they're not easy problems at the finals. It's a difficult task being able to figure out the solutions while commentating.
Mm-hmm.
All right, conveyor belt sushi. After a successful contest, you've all come to a sushi shop to celebrate. At the sushi shop, you and your teammates sit around a long circular conveyor belt. So it's like one of those sushi boat places or conveyor belt places. Um, the chef also has a designated location on the conveyor belt. When they see you enter at time t equals 0, the chef begins putting sushi plates on the conveyor belt. Every second, the chef attempts to place a new plate onto the belt in front of them. And at the same time, a subset of the team members can take a sushi plate off of the belt in front of them. So at any time, the chef can put something onto the belt and the team members can take sushi off of the belt. After that, the conveyor belt will advance all plates clockwise 1 seat. If a plate passes everyone without being taken, it returns to the chef the next second and makes another pass around the circle. So I don't think I think the only way for sushi to get off is if it's taken by the team members. And there are exactly n+1 seats on the belt, one for each team member and one for the chef. All right. So the chef will keep placing menu items as long as there's nothing in front of them. And once they've placed all the menu plates, they will start back at the first menu plate. Um, so what's it actually asking? The sushi shop has developed a smart billing system that is meant to automatically track who takes which sushi and bill them properly. However, the system is down. Can you help them figure out how to split the bill? So I guess so there are up to 100 types of plates, and each of them has their own cost. And like the problem says, the chef is placing them down one after another as long as there's an opening in front of the chef. Um, and then the input just gives you a number of events, which are which team members which are at a particular time at which a team member takes the sushi plate off in front of them, and you don't have to worry about whether there is a sushi plate in front of them. You are guaranteed that the events are all valid. In other words, there's always a sushi plate in front of the person who's taking the sushi plate. Okay, so you just have to iterate over the events, I think, and then you have to maintain the state of the conveyor belt. which is not huge. I mean, the conveyor
Yeah,
belt.
it seems that you can just you can maintain the conveyor belt in O of n, just moving each sushi plate one to the right at every time step. Or yeah,
Yeah, because there are 100, well, 101 seats and 10,000 time steps, which is perfectly reasonable to simulate.
mhm.
If this were like up to times of t equals 10 to the 9 or t equals 10 to the 18, then you'd have to worry a lot more about compressing the time.
Mhm.
But in this case, I think simulation is just the right idea, right?
Yeah. It seems to me that uh, wait, how does this work? So when the chef runs out of sushi, what happens?
It says that he starts again from the beginning.
Okay. I mean, but yeah, it's still only one per time step. So should
Uh,
and because the time steps are most 10,000,
yeah.
yeah, it seems you can just do 10,000 times that.
So like what might happen is the chef places a dish that's worth 3 on the first time step, and then you go to the second time step, so you move this here, and then the chef might place a dish that's worth 4. Say the chef's queue is 3, 4, and 6. And then maybe this team member will take this one off, and then the next time step you'll get 4, and then the 3 is already consumed, and then that's the next time step, and so on and so forth. So you just keep on rotating the plates. Just don't screw up the rotation. Don't accidentally overwrite the beginning with the end or something like that, which you can
Yeah,
do when
don't
rotating.
rotate the right direction. Make
Mhm.
sure you do the rotation correctly, and I guess also make sure you implement the operation correctly, where the chef only places a new plate if there's a empty plate in front of them, or the
Right.
empty location in front of them.
Yep. And looking at the inputs, the inputs might actually be trivial. So you might actually have to do some testing on your own because I don't see large time values in the inputs. Uh, maybe they're okay. Maybe they test things like the chef having a plate in front of them.
Yeah, it seems. Yeah, you'd have to look at the samples carefully. It seems. I don't think. Yeah, the only submit so far has been the one accepted submit from uh, Arizona, if I remember correctly. Uh,
So yeah, the samples might be enough to test it, perhaps. We'll see. We'll see if people start getting it wrong.
yeah, it could be the case that the first team just did it correctly, or it could be the case that the samples caught any issues they had.
Yep. All right. Moving on.
Yes. So BYU is the second team to solve G. They become the third team with 3 problems, although quite far down in penalty. Although even though, say in the first 30 minutes of penalty is a large gap. But by the end of the contest, 30 minutes shouldn't be a big deal. But yeah, we shall see.
What matters more is getting those problems solved so that you can move on to other harder problems
Yeah,
because that piles up over the course of the contest.
yeah. If you're behind on problems early, then yeah, the like wrong answer. Yeah. So how penalty works here is uh if you submit a problem at 40 minutes in the contest, you get 40 minutes of penalty, which you can see in the penalty column. But also, if you get a wrong answer on a problem you later solve, that also adds 20 minutes per wrong answer. So if you look at BYU, they have 2 wrong answers, which is giving them 40 minutes of extra penalty on top of the 55 minutes they have from just the time they submitted the problems. Uh, and there's 20 minutes, like 20 minutes by itself isn't that much penalty, but if you if you have a wrong answer on all 10 problems you solve, that's 200 minutes of penalty, which can be quite a lot at the end. And one wrong answer per problem isn't even the upper limit of how bad it can get.
Right. But there's always this balance, right? Because the other side of it is if you spend time testing the early problems, that time counts against all the later problems that you solve. So the question is, do you submit when you're 70% sure that it's right? Do you submit when you're 90% sure? What was your team strategy?
Um, yeah, I think uh, at least in regionals, we I don't know. I think always the best strategy is to practice enough so that you just don't make mistakes, which is
Oh,
always
oh
what
yeah,
you want to
just be
do.
perfect. Yeah.
And then yeah, like we were pretty confident at regionals. So, yeah, we didn't do that much testing, and then, uh, although that like sort of bit us in the back, bit us. This sort of hurt us on later problems. There's a one hard problem on a regional that we had a lot of wrong submits to,
Uh-huh.
and that could have been fixed uh, if we'd done a bunch more testing before submitting. But yeah, I think for these early problems, they should be simple enough, and like the penalty, they'll like the time you lose on the early problems by testing can sometimes be uh, can sometimes add up. So yeah, usually you just want to test on samples, and if those work, you just submit at least for the early problems.
Sure. Yeah, it's a delicate balance. That's part of the strategy of the contest. All right, let's take a look at E, I guess.
Yeah, E and H both have submissions.
Sure.
Both are all. Oh, actually, H has been solved, but by some teams not at the top of the scoreboard. So
Oh,
yeah,
interesting. So it might be a more interesting type of problem.
yeah. In fact,
All right,
U
let's look
Calgary
at
has
H.
only solved H, and only has a wrong. Oh, one of the U Calgary teams has only got the first solve in H, but has yet to solve A or L. So
Interesting.
probably, yeah, probably seems like an interesting problem. We should take a look.
All right, let's take a look at H. Just so people know, these problems are going to be separate from the other two contests problems, which I believe are going to be the same set, right?
I don't think they're the same. I believe they're overlapping.
Oh, overlapping.
Um,
So we're going to be looking at a lot of problems today.
yeah.
All right. Hexadecimal confusion. Addison Hex is an aspiring athlete training for the next Mental Olympics. The event she wants to compete in is fast hexadecimal addition, but only the top 16 people will make it to the finals. Oh, makes sense. In fast hexadecimal addition, contestants are shown very quickly a sequence of hexadecimal numbers, 4 digits, up to 4 digits each, and they must correctly sum them all in hexadecimal. No numbers will have leading zeros, and the integer zero will be replaced by exactly 1 0. So if it's just zero, then that doesn't count as a leading zero. Um, Addison does not have any sponsorship deals, so she is stuck with an old LCD display that will flash the numbers quickly for her to add. Oh, but it's using the 7 segment LCD displays, so the digits 8 and B look the same. Also, the digits 0 and D look the same. And you can see this diagram here. So you can see that you can see that 0 and D look the same, and B and 8 look the same. So there's some confusion. Thankfully, all other digits are unambiguous. Instead of finding the exact sum, she will practice by finding both the maximum possible sum and the minimum possible sum based on what she sees. And Addison may see numbers with leading zeros. That actually seems like a very tricky case. So she may see numbers with leading zeros as she tries to record the numbers as quickly as she can, but she knows that the original numbers have no leading zeros and takes that into account.
So like in particular, I think this means that so it's like if it appears to be a zero, leading zero, it's actually a leading D. Um,
I'm not quite sure what they mean by she may see
so it's
numbers with
like
leading
so it's
zeros.
like the point is like when she sees a D, it could be a zero, and when she sees a zero, it could be a D, and then also the same for eight and B.
Yeah,
So
but she's not going to count cases where there is a leading zero. I
so
think that's
like
what that's saying.
if she sees a number and it looks like it has a leading zero, she writes down a leading zero, it could have been a D, and in particular because we know that there aren't any leading zeros, it must have been a D.
Yeah, I think I agree that that's what that's saying. Okay, so basically you're given up to 1,000 integers. Each of the next n lines um, contains up to a 4-digit non-negative integer in hexadecimal. And then let's just check what the output is.
So the output is the minimum possible sum. So it's like across all possibilities of what
Yeah,
the numbers could be, what's the minimum and what's the maximum.
and you're supposed to output it in hexadecimal, just like the rest of the problem. Okay, so I mean, the nice thing is the numbers are basically independent, I think.
Yes. So
You're just
yeah,
minimizing each individual number and you're maximizing each individual number. Otherwise, this problem would be a lot harder.
yeah. And yeah, it
Um,
seems like, yeah, seems like there's like a few like yeah, the
there are some
minimum for
cases.
every number, you should minimize each digit and then maximize each digit. And the only hard case is the leading zeros, where um, it's like usually you want to replace every d with a zero to find the minimum, but uh, if you replace a d with a zero, or even if there's already a zero at the beginning, that might not be always valid.
So is that simple enough to just special case, or should you do something a little more complicated?
Yeah, I believe, yeah. So it's like as long as the first digit isn't zero, that's like valid.
Yeah.
So yeah, it should be just like so yeah, you find the minimum. So for each minimum, you convert every b to an 8, every d to a 0. And then if the first digit is a 0, it's actually a d, so you just change that instead.
And
Um,
that's yeah, I think that's the only thing that you need to do for leading zeros, right? Because that's never
yes,
going to propagate. You never need to worry about the second digit. Um,
because we
because
already know the first digit will not be 0.
yeah. So it's just so if first digit is 0/d, then you set it to 0 or set it to d. I believe that's all you need to do. And then the rest are for, and then set all other digits to min or max, respectively.
And just another a slight nuance is so
Okay.
because leading zeros are allowed when the string is just 0, you just have to special case that as
Aha.
yeah.
That's a good point.
And yeah, that's included in the fourth sample. So hopefully teams should be
Is
able to
it?
figure that one out.
Okay, that's nice of them because sometimes they would not include something like that. Yeah, I see in the fourth sample they have a nice little zero there, and so for it's not going to matter for the maximum, but for the minimum, you can treat that as a zero.
I mean, there's always the issue like it's the last number in the last sample. You just
Yeah.
run it and just like you look the first number, it looks correct. You don't really look that close to the last number. Teams could have some issues with that, but
So
hopefully
I
they're
think I
making
would have
this
gotten
like
that wrong because I didn't specify that, right? So
yeah.
I
Or
missed
like
that.
I'm also just saying like even if you run the sample, you might overlook the fact that you got the wrong
Yeah, yeah,
second
that's true.
second like the second number, the second output in the last sample. Uh,
Yeah. And then the other part of the problem is, of course, you have to sum in hexadecimal, and you could use. I think most languages have some way of just doing this, but you might have to hard code it yourself.
Yeah, so like in Python, which is the language I would use, you
Sure.
can just convert all the integers to hexadecimal, and then convert it back at the end. And yeah, I'd assume uh, it's like not as like I wouldn't know how to do that in C++, but it shouldn't be too big of a deal
Yeah, I'm
to
not sure if there is
manipulate
a
yourself.
built-in. I'm not sure if there's a built-in language way to do that in C++. Not that it's hard to write yourself, but
Yeah, and yeah, just take some implementation time.
yep.
Just
So that's creative. That's definitely more creative, I think, than the other problems we've seen so far. Well,
yeah,
maybe
just like
actually the genie one was pretty creative too. I like that one too.
yeah, uh, yeah, just like it shouldn't be too hard for teams, but just like a lot of careful casework.
Yep. All right, so we've got 15 minutes till the next contest start, and we can talk about E.
Yeah, let me just go back to the scoreboard for a minute. Yeah, so Arizona State, second wind, four problems solved, and to solve an I, which is probably the problem we'll look at after. Actually, should we look at I or E? Because it seems that
Oh,
E still only has wrong answers, if I'm looking at this correctly.
okay. Yeah, we can look at I since somebody has solved it, since Arizona State has solved it. And
Yeah.
they're leading, they've got a very commanding lead, right? They've got very low penalty and for
Actually,
for
no. Two other teams have four problems because Arizona State has yet to solve G,
yeah,
both
you're
from
right. Sorry,
Alberta.
it's not a commanding lead. It's only because 20 penalty minutes could evaporate by the end.
And they already have a wrong answer in E, so that's already 20 penalty minutes.
Yeah,
Just
yeah.
banked in, assuming E is solved, which we have yet to see a solve in E, so maybe it will not be solved at the end. But
Okay, so it's a tight race so far.
yeah,
Good. All right, so we'll look at I then, since somebody has actually solved it. I is called Poetic Tournament, and it's an interactive problem.
ah, interactive for I. I know a lot of setters enjoy putting interactive problems at position I.
Oh, cute. um, Trying to figure out how to get this all onto one
Yeah,
page.
I'd assume with the interactive problems they usually have a long statement.
Yeah, there's a lot of mechanics. It's also the problem with interactive problems is they can also be very difficult to test.
It seems they've provided a testing tool. I can see.
But even
Um,
then, it's not as simple as just coming up with some test cases and then running them, right?
yeah. Although
All right.
yeah, it seems. Yeah. So yeah, only one submit to I and it was accepted. So maybe it won't be too bad.
Okay. Well, I'm sharing some part of the problem. Um, we have the iconic character poetry contest, ICPC, very familiar letters. A televised battle of wits and verse boasting the nation's best and brightest. Right, and there are hordes of new applicants wishing to test their mettle. The program has a limited number of slots to accept applicants, and Vaino, I don't know how to pronounce that, is tasked with ensuring that only the best applicants get said slots. So he's decided to host a qualifying tournament. In the tournament, 2 applicants at a time will compete with each other to assess which has the greater skill at poetry or rudeness. Okay. He is certain that no 2 applicants will have the same skill level. So it's not totally clear, but I guess it's deterministic who will win any particular matchup just based on skill level.
Yeah, it says
So you were
assess
given,
which has the greater skill. So I assume it's just gonna tell you which has the higher internal skill level.
yeah. So there's no randomness or anything like that.
Mm-hmm.
So okay, so you're given up to 15,000 applicants there, and um, you have between 1 and what does that mean? Between 1 and 30 will advance.
Yeah, so
And
advancing teams at most the total number of teams and at most 30 as well.
so what you're trying to do, you are simply trying to efficiently figure out the top K out of a large number of applicants by doing only comparisons. So it's the classic algorithmic thing of you can only do comparisons between two applicants, or you can only do, say you're sorting a list, you can only do binary comparisons between 2 elements of a list at a time. But of course, I assume that you do not have enough comparisons to sort the list. You have
Yes. So
12n plus 1,000 queries.
yeah, so a sorting algorithm would use about n log n queries, uh, but log n is bigger than 12 in this case. Oh, it would be log base 2. Because 2 to the 12 is only 4096 and n is 15,000, which is bigger than around 4,000.
It's very slightly bigger.
Yeah.
It's actually pretty close. So so you have to do better than sorting, but you don't have to do that much better than sorting, to be honest.
Yes. So I believe the algorithm we should use is like a variant on quick select. So you just or at least this is what I would do, is you can
Okay.
select a random number. You take, you, or you select a random element. Figure out which applicants are better, which applicants are worse. If more than, usually, there'll be more than 30 applicants which are better, and then you can just, so if there's more than 30 applicants who are better than the chosen applicant, and then we can ignore all the people who are worse than them. And if we chose a random applicant at the beginning, then on average, half of the applicants will be deleted by this process.
Okay, but that's still n log n, right?
No, because so it's on the first layer,
Oh, no,
you'll
you're
do
right.
n queries because you
Yeah, yeah.
compare everyone to the randomly chosen applicant. Then on average, so it's an average. So worst case, worse things will happen, but on average, half the applicants will be deleted, and then on the second level, we'll do n over 2 queries, and then so on and so forth until we've deleted all but 30 of the applicants. And in particular, like, if we choose someone who is in the top 30, then we can take them and all the people who are better than them, and they automatically qualify because they are better than less than k of all the other people, and then once we remove those however many people, we can try to solve the problem with a lower k on the remaining people.
Okay. And I would worry a little about the low n case, except that they've given us these extra 1,000 queries.
Yeah,
So
so it's like,
I think that's just there because you can get some boundary conditions on low n, which if you only had 12n, that might be actually a really difficult problem.
yeah,
So
it's just like basically you're doing a bunch of random. If you do a bunch of random queries, then like you might get a little unlucky. Uh, so like if you just get unlucky, like I don't know, like 5 times in a row, then um,
even then, you're still at 5n, right? So you're still well below 12n.
yeah, and yeah, I think the 1,000 is just like, yeah. So it's like when n is low, it just like there's like higher variance because you could just like
Right, right,
if n is like 15,000, you can't choose the worst person like 5 times in a row.
right.
But if n is like 10, maybe that could happen. So yeah, there's 1,000 queries are just like just give contestants like confidence that like low n, they won't get very unlucky in low n.
So my guess is that this number was sort of carefully selected so that it's not good enough for you to sort, but but if you do this sort of quick select type solution, then you can be pretty confident you're not going to get unlucky enough for it to fail. I mean, it could fail. It fails in the worst case, right?
Yes.
But that's fine. Like, so in the worst case, can you even solve this problem in the worst case?
Yeah.
Maybe you could
So
just get always screwed in the worst case.
um,
I'm not actually sure.
I
Oh,
mean,
actually,
you
no.
can do
You could
deterministic.
use the
Yeah.
there is the linear time median.
Yeah, there's a
Uh,
deterministic version of quick select.
yeah,
Yeah, like deterministic median, I know definitely exists. I believe
yeah.
deterministic quick select also exists, but it is guaranteed. So, you say about the worst case. Um, so if the so there's a in interactive problems, there's something called an adaptive checker, which is maybe like once you choose some random element, the interactor might not have already fixed the values
That
of
is a
all the
very
participants
that is a
beforehand,
very good point. So the
and
question is this adversarial?
yeah, it could force your solution to like once you've chosen two random people to check, it could force them to be the worst two. However, it's guaranteed in the problem statement. I don't know if it's on the screen right now, but lower down in the problem statement, it says the interactor is not adaptive,
Yep.
which means that the skill level of each applicant is predetermined at the start of the interaction and does not change depending on what you do. So this allows us to, when we choose a random participant, we know that their skill is actually completely random.
So that is a very good point. Like that changes the nature of the problem a lot, and
Yeah,
I
and
did
yeah,
not
yeah,
cover that. So yes, the fact that this is non-adaptive is very important. Cool.
and yeah, but yeah, it seems the problem sellers have made sure that like that nuance is not because yeah, like dealing with interactive, like understanding how interactive adapters will work is sometimes very complicated, and seems
Yep.
they have not forced teams to do anything too complicated this time around.
And believe me, sometimes it can be really hard to write a good adversarial judge.
Yeah, and yeah, if uh like yeah, it seems very like if someone just makes a bunch of random queries at the beginning, sometimes it's very hard to uh
Yeah, yeah.
like you have to like find some consistent uh like you have to pre-commit to some like random things, and then yeah, figuring out
Like you can
what to do in
defeat
the
the
end.
simple strategy that we outlined. You can specifically do something adversarial for that, but a more complex strategy,
Yeah,
it's harder.
sometimes the interactor isn't adapt, they make sure it's not adaptive for the contestants, and sometimes they make it not adaptive so that they don't have to predict what the contestants will do, and that makes it easier for the judges to write
Right.
a solution they know will fail. All solutions that should fail will fail. uh, Whereas if you allow an adaptive checker, sometimes it's hard to adapt to every single thing a contestant could do.
Yep. So the other contests are going to start shortly.
Ah, yes. So, yeah,
Um,
I'd say like we'll be able to see in the queue if once the first submits come for the other two contests. But I guess for now we'll stick on the Rocky Mountain because yeah, as we
sure.
saw with Rocky Mountain, there usually is a 5 to 10 minute gap before any submissions start coming in.
So people are having a little trouble with G, the genie problem. I see a number of wrong answers. Um,
Yeah, potentially they're trying some greedy solution that does not work.
right.
I think yeah, we discussed potentially a greedy solution would work, but yeah, like usually like maybe there's some greedy solution that works with enough casework, but if there's a simple dynamic probing solution, usually that's what teams should be opting for rather than trying to make the greedy solution work.
I could definitely imagine that with enough casework you could make one work.
Yeah, but
Yeah. And H, we're also seeing some wrong answers for H. H was
was H something
hexadecimal.
we looked at?
So yeah,
Oh,
I think there are
hexadecimal.
a fair number
Okay.
of things you could mess up with hexadecimal. Like for instance, you could just mess up the zero case, or you could mess up adding in hexadecimal.
Yeah, and you can also mess up the conversions. You might like miss one of the. You might make some mistake in one of the cases of converting eights to B's and B's to eights, and all four of them.
And actually, I noticed that in the sample inputs, everything except for that one lone zero is 4 digits. So you could mess up the case with fewer than 4 digits.
Ah, okay, yeah. It seems a bit mean from the samples, but
Yeah.
yes,
Well, I believe personally, I believe in like having mean samples. I think the contestants should take a little more testing into their own hands
mm-hmm.
because the difference between this contest and other contests like well the Google Code Jam that used to run or many or like Codeforce's contests is you have multiple attempts, right? You don't have to submit something and then that's your final submission and you have to
Mm-hmm.
hope that it's correct at the end. If you get something wrong, you can test,
And yeah,
which means that maybe the burden should be a little more on the contestants to actually test. But that's my personal
yeah,
view.
I think both views seem to be pretty reasonable. Yeah, I think one thing I like one problem I have is just like, because you don't know, like it's sort of just like I don't know. It's like sometimes you have to gamble on this on the samples being strong. Like sometimes if they make the sample strong, the optimal strategy is to just submit without like you just test on samples and then
Yep.
submit, and
Yep.
then it's sort of sometimes a guessing game of like will the judges make strong samples or will they make weak samples? But like yeah, I think ICPC has a mix, and because you know there's a mix, you know there's like because it's like knowing there'll be a mix, it's like always a risk to just test on samples. But like sometimes if you're like confident enough in your solution, the risk can pay off.
Yep. Okay, so have the other contests started? Can we check?
Uh,
And try showing the scoreboard for the other contest.
I don't think it'll show us anything until people actually.
We won't even see a blank scoreboard.
I know. So yeah, we can see the blank scoreboard, but we don't. We also saw that before the contest started.
Yep. We have a blank scoreboard.
Oh yeah, I can see. So yeah, if I navigate to the uh, if I navigate to MCPC, I can see the problems online.
Nice.
Although I also have a printed set
Oh, nice, nice.
because our coach printed the sets beforehand and made sure I got one.
Good.
Um, yeah,
This does not appear to have started yet.
I can see the problems online, so
The
hopefully it
ticker
started.
is the ticker is the ticker broken?
We shall
Maybe the ticker
see.
doesn't work. I guess we'll find out when people start submitting.
I guess so. Yeah, yeah. We might have to wait a couple of minutes for uh, the submissions to come in. Although I guess for now we can just look at Rocky Mountain.
Yeah.
Yeah, so it seems second team solved I, so it seems teams are getting that. Um, Yeah, it seems A, G, H, and L all seem to have quite a few submissions, and then C and I seem to be the next two teams are working on.
So it feels like we've looked at the easy problems
Yeah,
on this
we've
contest.
looked at all the easy problems, and then the like middle problems, C and I, uh, are probably the ones that teams will go for next.
Hmm.
Although I, it seems like because it's so similar to like quick select, like an algorithm that many people will have learned in an algorithms class, but also some people might not have. It might be a problem that's like easy for the people who know it and hard for the people who don't.
I think there's also sometimes a general aversion to interactive problems. So,
Yeah, I mean, I think people will see that two teams will solve it in under an hour,
yep,
um, and they'll at least take a look at it.
yep.
Also, I see Vanderbilt with two submissions on D. Are those two different teams with a wrong answer submission on D?
Oh, interesting. I'm not seeing that on the scoreboard. Is it further down?
Uh, just looking at the queue right now.
Okay. Oh, yeah.
I guess yeah, like should we look at problem D from Mid Central?
Sure. Sure. Oh, from Mid Central. Okay.
Yes. Oh
Yes.
yeah, I was talking about Mid Central with the Vanderbilt submissions.
Okay. Um, let's see if I can actually find it this time. I found the standings this time, but they do not appear to be live for me.
Sorry,
Do,
what is the issue?
um, I think I'm looking at the Mid Central. Well, for some reason, this is saying 2026. That would do it, wouldn't it?
Oh, what? Interesting.
It gave me a site for the 2026 standings. Maybe the link is broken. I don't know. No, that didn't work.
I can send you problem D.
Why is it so hard to find leaderboards for these contests?
So yeah, so it is yeah submissions to. So problem B on North Central is the same as problem D on Mid Central, and it seems
Okay.
that they those two problems or the same problem in both sets has gotten has been teams have solved it. I'll send you.
Yeah, I'll be happy to look at it when I can.
I sent you a link directly.
Cool. Oh no. It's a baby shark problem.
Yes.
All right. Let me just screen share. All right, I am not going to sing it, but they do give the lyrics to Baby Shark, such as they are. And additional verses refer to Mommy Shark, Daddy Shark, Grandpa Shark, Let's Go Hunt, Run Away, Safe at Last, and It's the End. Notice that the word do is repeated 6 times consecutively in lines 2, 3, and 4. We ignore case. Given a line of text, determine the maximum number of consecutive repetitions of a word. A word is defined as any sequence of characters separated by white space. By characters, I guess they mean any non-white space characters,
Yeah.
or by the start or end of the line.
And it seems all the words are it's guaranteed to be composed of lowercase letters, so not really any
Yeah.
edge cases
So,
there.
okay, so the input says lowercase letters. Yeah.
Yes.
Um,
And yeah, it seems like a pretty simple implementation problem. Uh although
so I think the one thing you could get wrong maybe is, well, there are two things I think you could get wrong. You could get tiebreakers wrong. So the output
yeah.
specify what the tiebreaker is. And I think the other thing is, I don't think the samples, it doesn't look like the samples catch it if you do the maximum number of repetitions total rather than the maximum number of consecutive repetitions.
Yeah, I also noticed that. And it also doesn't catch. So yeah, so on the tiebreaker, it says for the first such word in the input line. So first of all, there's an edge case of um, like if a word appears at the beginning, but then the large repeat happens at the end. I believe that would be the first. So it's like if you have like A B B B A A A, I believe the answer should be A and not B. Uh,
That is actually a very good question. I'm not, is the problem statement even clear on that point?
um, I mean, like, I don't
So
like.
the question is if you have A, B, 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 A, A, A. So now you have to tie break. You have to tie break, right?
Yeah,
So the
I would say
question
it's
is,
yeah. And the tiebreaker should be it's the wording is first such word in the input line. Um, and between A and B, A is the first of those two words in the input line. So I would say the answer is A. Although yeah, I think it is quite. I feel like they should have been more specific, or they should have
I
included
think
the
so.
samples.
Because does by such word, do they mean like the word that gets repeated, which would be like this would be that such word, right? Because that's the word that gets repeated. But yeah, so the fact that people are getting it actually suggests maybe that that's not the correct interpretation. That because I would expect people to do to return sorry to return B in this case in their first implementation.
Yeah, I mean, one thing
Maybe
I'll
they don't
say
even have
is
this test case.
so Vanderbilt, we were the first team to solve it in Mid Central, had two wrong answers.
Oh, okay.
So even though they solve it in, let's see how quick they solved it. Oh, it doesn't really show on this leaderboard, but and this is the wrong leaderboard, but uh, uh,
So
they
it's
solved
possible
it.
people are getting this wrong.
Yeah, like despite the fact that, and yeah, like this wording issue um might be the reason they're getting wrong, or they could be messing up one of the other tiebreakers. It's
Yeah. And like we said, like the test cases do not even cover if you just count the total number of
yeah, and
occurrences of
that's
the
the,
word.
also just like a reading mistake.
Yep.
Um,
Anyway, I don't think we need to cover the implementation because the implementation is easy. So it's just these special cases. You have to get the cases, the border cases correct.
yeah.
Yikes.
So yeah, so it's a Vanderbilt solved it in 4 minutes, only 4 minutes. First AC of the entire contest, but they had two wrong answers.
That's pretty impressive to actually get two wrong answers in 4 minutes.
And yeah, it could be just yeah, like um. So yeah,
So what else do we have? So let's go through the
so
leaderboards.
currently on the leaderboards, uh, four problems solved in North Central already. Uh, Although UW Madison is the only team with two solves,
Okay.
and then on the Mid Central side, also four problems solved, but one team from UIUC, Northwestern, and Vanderbilt have two problems solved.
Can we get the correct ticker? Let's see if that works.
Uh,
No, it appears we can't get a ticker for the. So people have to keep in mind that one of these contests is, or two of these contests are an hour behind the other contest. So that ticker is not accurate for all. Oh, there we go. Yeah.
Wait. Seems none of the tickers are on right now.
Right. Sorry, I turned off all the tickers.
Yeah, I'll turn
Um,
on the one for the earlier contest, but yeah,
Yeah.
So North Central and Mid Central are an hour behind this. So Rocky Mountain will be ending at the 5 hour mark, and North Central and Mid Central, which just began 12 minutes ago, will be ending at like effectively a 6 hour mark because they're an
Yep.
hour behind Rocky Mountain.
So D on Mid Central, this is the baby shark that we
Yeah.
looked at, right?
So yeah, B on North Central and D on Mid Central are both this baby shark problem.
So it looks like an easy problem, but I think it's got some
Yeah, I think it should be a tight
bad conditions.
should be a problem that almost all teams get by the end of the contest. But yeah, a bunch of mistakes you can make, and if you're not careful, you'll rack up some penalty points.
Well, let's look at another North Central one that's been solved.
I'd say a North Central.
Well, no, nobody solved anything on mid. Oh no, somebody.
No.
I see
So
somebody solved.
four problems on North Central and four problems on Mid Central.
Oh, there we go.
But we can look at the problems in detail later, but it could be the same for problems because the sets have some overlap, but not full overlap.
Yep. So we looked at D, and H, J, and K have also been solved. Let's take a look at K. I see zipline course. Oh no, this looks like geometry. How has this been solved so far? Is this one of those fake geometry problems that's actually trivial?
So K, no, so K on Mid Central has been solved.
I think I'm looking at the wrong contest. That's why.
Yes.
By the way, sometimes we do ask fake geometry problems that are actually trivial. Like I think there was one in the last finals. Walking in sunshine looked hard, but it was utterly trivial.
Yes. Or I didn't do that problem on the finals, but yeah. I heard from my teammates.
Okay, let's see if I can find.
So which problem are you opening? I think D seems to be the next easiest problem on North Central.
On North Central? Okay, we can look at D on North Central. So that's intervals. It's going to be a little confusing when we're talking about problems because the letters do not match up.
Yeah. So intervals is D on North Central is intervals, which is also H on Mid Central. And it also has a lot of solves on Mid Central as well. Oh no, that's there's a couple of solves on Mid Central.
Okay. So it's called intervals. A new streaming service, MyStream, has launched and wants to analyze user activity patterns. Every time a user logs on, it records the hour they started and the hour that they finished. So for instance, if a user started streaming at 3 a.m. and ended at 2 p.m., that sounds like normal streaming hours to me. This interval would be recorded as starting at time 3 and ending at time 14 for a total duration of 11 hours. So not 12 hours, there's no edge thing. It's just 14 minus 3. Given n user intervals, each represented as a pair of integers, AI, BI, which is a non-negative interval. Then you have to determine, and an integer k, you have to determine at which hours during the day there were at least k users streaming simultaneously.
Or how many such hours exist?
Oh, sorry. Yeah, how many such hours exist such that there were at least k users streaming simultaneously? So you've got basically you're given intervals that look like this. And if say k equals 3, then this is say the first hour at which at most 3 are or at least 3 are streaming. Then you have another hour, another hour, another hour, and so on until here. This is the last hour at which three intervals are all active at the same time, and you have to count all of these hours.
Yeah, and it seems because there's only at most 24 hours in a day, and yeah, it seems there's just 24 hours. So you just have an array of 24 numbers of how many users are streaming at the time. For each user, you go through the entire interval and mark all the hours as being used by one additional user. Then once you've done that for all 1,000 users, you have 24 numbers, count how many of them are at least k. Seems like a very simple problem.
Yep. Now, certainly, I, I there are versions of this problem where you could up all of the limits and then you have to use a more clever approach. There are definitely ways of using
Yeah,
a more
yeah.
clever.
But yeah, it seems that they've set the bounds for, yeah, it seems they wanted an easy problem, so they set the bounds
Yep.
pretty low just to,
Just
uh,
just implement it.
yeah.
That's pretty straightforward. Yep.
Yeah, it doesn't seem there's many edge cases. I guess just making sure that you're dealing with the boundary condition. So it's like for an interval, just like making sure you hit the correct hours uh, could be a mistake that teams could make. But I think that would, if you made such a mistake, you would fail the sample. Uh,
Yeah, I'm not sure I see a way that you could mess this problem up that would pass the sample input.
yeah. So, and as far as I can know, if I look at the standings, one wrong submission out of five accepted from North Central, and uh, on Mid Central, uh, yeah, it seems eight submits, eight accepted. So yeah, it seems that I don't know. Maybe one team didn't test on the samples. Maybe they made some other bug, but
Do you
uh,
have any thoughts on what bug you could make? This is a code forces skill, right? I never really competed on code forces, but like being able to know mistakes that people make is a skill, and
yeah.
I don't have it.
I mean, yeah, I think the only thing you could really mess up is just the boundaries on the interval. Maybe you just make your interval too small. Maybe like, maybe you like, I don't know. Yeah, I can't really see any other mistakes you could make. Um,
Maybe you one index and then you accidentally overflow your array of 24.
yeah, that's always a possibility. Yeah, just not making the array big enough. That's also something else you could do.
Yeah.
Um,
Although I usually just add 10 to the size of my arrays all the time anyway.
yeah, it's usually good practice to do that. Just uh, like as long as you're not right at the memory limit, yeah, it's
Yeah,
like
yeah.
pretty much no downside and should save you from any out of bounds.
Okay, so let's check in on Rocky Mountain to see if there's something changed there.
Yeah, let's look at the scoreboard. Uh, so yeah, I think currently the two teams from Alberta are uh, the top two, or at least last I checked. Yep,
Go Alberta.
as Azure and Green, and so yeah, like regionals are sometimes a very interesting contest in that like because the top, so how it works is usually the top 3 to 5 teams uh, from this regional contest will qualify, from each regional contest will qualify for the North America Championship. Um, but there's a special rule that at most one team from each school can qualify. So although this like Alberta Green team is in second place, which is well within the top 5, they're currently not qualifying because they're losing to another University of Alberta team.
Right.
Uh, so yeah, there's
I,
always
I
this.
remember I remember in our years, like our main contest was the other team from our university.
Yeah,
They were the ones we were mainly worried about.
and it's always sad if you come second in a contest, but you still don't qualify for the next round because the
Yes,
one team you
yes.
lost to is from your university.
So a good showing from University of Alberta, and it does look like there's not much else active at the moment. I guess,
Yeah, it seems 6 problems solved, and the one of the Alberta teams has solved all 6 of them. So
and, and they've tried J, and somebody's tried E.
yeah, and we talked about E earlier.
Yeah.
Someone tried it very early, and like maybe oh no, okay, that team has gone 3 wrong submits on E. So yeah, so it seems they are actively trying E, but it's not working out for them.
Yep. Okay, let's go back to North Central and Mid Central.
So yeah, North Central is now 5 problems solved total.
Okay.
Uh, with I think G was solved last time we looked, but E is the new problem. But we've yet to look at I, which seems to be the next easiest problem after B and D.
Okay. Let's take a look at that. First, here's Mid Central.
So I on North Central. Oh, you said okay. You're showing
Yeah,
the
yeah.
Mid Central scoreboard.
Now I'm showing Mid Central. Just just so we can take a look. Okay, yeah, let's take a look at okay, I on
North Central.
North Central. And this is, let's see,
Yeah, so
this is,
it's prime powers, which is
this is K on Mid Central.
yes, which also has solves.
Okay. I tend to like mathy problems, so this problem is called prime powers, which means I'll probably like it.
Yeah.
All right, I'll share my screen. Prime powers. Your friend Christian has been mentoring a group of high school students exploring the fascinating world of mathematics, particularly powers and exponents. Yay. As part of their studies, the students began experimenting with how numbers behave when raised to different powers, discovering many interesting patterns along the way. To challenge them further, Christian posed a problem involving powers and products of numbers. He would like your help writing a program to compute the correct answers so he can verify whether the student's solutions are right. Given an integer e and a range LR, compute the product of the eth power of all prime numbers between L and R inclusive. So you're given a range, you want to find all the primes within that range, and you want to raise them to the eth power and then figure out and then multiply them all together, modulo a particular number, modulo in this case, 1,000,000,007, because it's going to be a large answer.
Yeah, like just even if you take if e can be up to 1,000,000, so 2 to the 1,000,000 is already basically too big to, and like, I think 2 to the 1,000,000 by itself could be computed on a computer, but it requires quite large numbers.
Yep.
So yeah,
So this is a pattern that you never see at the finals. I don't think we have ever had a problem that has this mod thing.
Yeah, I think this is something we've noted.
But it's
something contestants have looked at.
Contestants have noticed that, I'm sure, yes. But it's common, for instance, on code forces. Like
Yeah.
you'll often see problems that are that have very large answers that are impractical to compute. But the point is to show that you have an algorithm that works in theory, and so thus you just output the correct modulus to show that in theory, if you were using big integers, you would get the right answer.
And yeah, I think this style of problem has also appeared at the North America Championships.
Okay. So what are our bounds? So obviously the bounds are going to matter a lot here. So we have,
yeah, so e can be up to 1,000,000, and then the left and right range for primes is also between 1 and 1,000,000.
so I feel like actually you might even be able to get away with just a naive prime test. You might not even need a sieve to get.
Yeah, it's pretty close to the border.
Yeah.
I would code up a sieve.
It's borderline.
But
so
yeah, I think if you do square root, so the time limit is only 1 second. I don't think that's shown, but it's only 1 second. So if you just do the square root prime testing, it is right on the borderline.
It's right on the borderline, yeah.
Which I feel, and like, if I was in contest, I would not take this risk, but it's always interesting to see when setters set a solution which would be right on the borderline.
But almost everybody is going to have Civ in their libraries,
yeah,
so
and
you can just type it in.
Like yeah. So teams can bring any printed code they want. I not like Civ might be something that like teams know how to code from scratch, may not necessarily be in their library, but
yep.
Yeah, like Aristosthenes Civ, if you want to look it up, is a way to pretty quickly generate all primes in a certain range. So in this case, it would be 1 to 1,000,000. You generate all the primes, figure out which ones are between L and R, and again, so you can use binary exponentiation to take the powers of all of them. There's a well-known binary exponentiation algorithm which takes on the order of log e multiplications. However, another solution you can do is you can just take the product of all the primes and then take that number to the eth power. And then you can just use naive exponentiation to solve the problem. But yeah, it seems they've set the limits low enough that like any of these solutions can work in terms of, yeah, it seems there's like multiple things you can do, like both on the prime finding step and on the exponentiation step.
Yep. So yeah, like binary exponentiation is probably another thing that they have in their book. But if you don't, yeah, all you have to notice is that you only have to do the exponentiation once at the end, and then then you could do it trivially.
I mean, if you use Python, it doesn't need to be in your book because it's a built-in. But yeah, I think most teams, yeah, many teams will be using C++, where yeah,
Yeah.
you'd have to write your own code for a binary explanation, or you can do the trick where you just do the explanation once.
Okay. So yeah, I mean, it's a math problem. You need to know a few basic math algorithm things, but it's not hard at all. So
Yeah, so for teams who already know the algorithms, it should be a pretty simple implementation check,
yep.
and yeah.
Cool. All right. So let's see. Go back to
Yeah, go back to the contest.
the contest. Go back to the scoreboard. So North Central.
North Central. So since the last time, A has been solved
Ah,
by Dakota. What is that? Dakota SU. Oh, Dakota State.
and we have two teams at 5 problems and two teams at 4 problems within spitting distance. Seems pretty competitive.
And then on
And
Mid Central, still only 4 problems solved. A lot of wrong submissions on E and one on A.
so I guess the question is, are all of the, so on North Central, we have A, B, D, E, G, and I solved. Are all of these on uh, Mid Central? That's a tough problem to answer.
Yeah. Oh yeah, and it seems yeah we discussed D earlier on Mid Central is the baby check problem. There's a
Yep.
team with 6 wrong submissions. Uh,
That problem is just, it's a trap. I feel
yeah,
like it's a
I
trap.
mean I don't know, like I don't see like yeah I think that problem is just badly worded.
I think
Uh,
so. Yeah.
but
We would not be able to see if people were asking clarifications. So if there had been a clarification, I don't think we would see it, right?
yeah, I don't think there's a way for us to see that. Um, but yeah, like I don't know, maybe we can look at take a look at maybe A from North Central.
Okay, that's not going to be an easy one though, right?
Yeah,
That's
it's been solved by one team in 22 minutes, so it should be relatively easy. But yeah, it's not. There's a
sure.
couple of. I
This,
think
this is
it is
probably more
difficult.
of a medium range problem,
Yeah.
so we'll take a look. Okay, artist who shall not be named. Oh boy, I'm not going to be able to
Okay.
fit this on screen.
Oh yeah, it seems to be quite long. Maybe we should.
I'm not going to draw on it. I'm just going to share the browser window then.
Okay. Yeah, this is
Um,
problem C on mid central.
okay. All right, so we have artist who shall not be named. You are visiting the beautiful country of Genovia, fake country. You find yourself in a bar. To your right is Dawn, and to your left is something. You have just returned from a Unicode convention and notice that each letter of Dawn's name takes 1 byte in UTF-8 since it consists entirely of ASCII characters. Each letter of something takes 2 bytes because they are non-ASCII characters. Unicode represents all characters of the world's writing systems by mapping them to numbers, i.e. code points, between 0 and just over 1 million. Since data is stored in bytes, UTF-8 encodes these code points efficiently. The high bits of the first byte indicate how many bytes are needed. If the top bit is 0, the code point is less than 128 and is a single byte. In other words, it's an ASCII character. For instance, D is encoded as the byte 0x44. Okay, if the top 2 bits are 1, 0, the byte is part of a multi-byte sequence. Or the byte is part of it. The character is part of. Oh no, sorry.
Yeah,
Sorry.
the
The
byte.
first byte is part of a multi-byte sequence. The lower 6 bits contribute to the code points. Otherwise, the leading bits start with 110, 1110, or 11110, indicating 2, 3, or 4 byte encoding, respectively. Does that mean 2, 3, or 4 additional bytes?
Oh no, it's 2, 3, or 4 total. If you look at the table below.
Why would you? Sorry, I'm missing something. Why would you encode something with 1, 0 to start?
Oh, nothing is coded with 1, 0 to start. So
Okay.
the later bytes. So in these multi-byte sequences, the later bytes start with 1, 0.
So it. Oh, yeah, yeah. Okay, got it. So 1, 0, 1, 0 is for the later bytes in the sequence.
Mm-hmm.
Got it. Okay. You would not want to start a sequence with 1, 0 because if it only takes 1 byte, you might as well just use ASCII. Okay. So for instance, you can see the table, you can see the range. So 3 has the binary represent, or sorry, that's not 3. That is a Cyrillic character. I'm not even sure which. That has the binary representation of something which requires 2 bytes. And you can see that the first 5 bits, so that is an 11-bit sequence, and the first 5 bits are in the first byte because after 110 you have 5 bytes left over, and then the next six bits are on the second byte. Okay, bit of a UTF-8 refresher there.
Yeah.
You proudly demonstrate your UTF-8 expertise to the 2 people, and then ask the bartender for her name. She writes a name using the byte sequence, so it's an invalid byte sequence. Okay. So now names are, this is quite a problem. So nibbles are recorded, nibbles are 4-bit sequences. So nibbles are recorded in your notebook using nibble encoding, where each byte is split into 2 4-bit nibbles and written as hexadecimal. Okay. You decide to survey all the names in the bar and categorize them as follows. Boring. So a name is boring if all of the characters in the name are ASCII. Cool if it's valid UTF-8 with at least one multi-byte character. And artistic, which means that it's not valid UTF and includes but is not limited to, my goodness, a byte sequence with an odd number of nibbles.
Oh, okay. Your
A
audio is
multi-byte
cutting
start.
out.
Oh, is it?
Or it's like, I don't know how to
Testing,
describe
testing.
it. I'm not sure
Actually,
if the issue's
yeah,
on my end or your
our
end.
connection might be having a few issues. Okay, can you hear me now? Testing, testing.
Like I can hear you, but you sound like I don't know. You sound like a robot, sort of.
Okay, I'm not sure how to fix this. Um,
Yeah. For
I
now,
can
I'll
try
just
again.
talk about the problem a little. Yeah. It seems to be
Yeah,
mostly an
why
implementation
don't you
problem.
describe the problem?
Yeah.
Yep.
Yeah. It seems like the main thing about the problem is just given this encoding in nibble encoding, determine if it's valid or not. If it's not valid, it's artistic, and then if it is valid, you just check if all of the bytes are ASCII only, which is so that yeah, distinguishing between boring and cool is mostly um, is
Distinguishing
pretty
between
simple.
boring and not boring is,
Yeah,
yeah.
yeah, it's quite easy. You just check does every byte start with a leading 0? If so, it's boring. Otherwise, it's not. And then the hard part is distinguishing between cool and artistic. Whereas, given this UTF-8 with at least one multi-byte character, is it valid or is it not? And it seems like it's basically yeah. There's like 5 cases listed in this artistic section, which is 5 different reasons that uh, a byte sequence could be invalid.
But here's the problem. It says it includes but is not limited to. So what are they not including here?
Okay. Let's think about this.
That's a very worrying statement.
Okay. Very interesting. Okay. So, oh yeah, code points that are non-characters. Uh, Although it seems that they've listed. Okay, they have not. Yeah. So I guess the main thing to check is yeah, this code points that are non-characters. So on the table, if you scroll up a bit, it seems the first three ranges, uh, how does this work? Yeah, seems the first three ranges. Wait, are you still connected?
I'm still connected. Yeah.
Okay, yeah, yeah. It seems the first three ranges have like full range, but then the last range is missing quite a few characters at the end because you'd expect it to be able to go up to seven FFF or maybe all FFFF, but you have to check that the value is less than 0x10 FFFF. Uh, but yeah, yeah, I'd say yeah. I can't think. I feel like they've listed all the edge cases.
Yeah, I'm trying to figure out. Yeah, it does feel like that, doesn't it?
But like,
So why?
maybe what they're referring to is the fact that like in point five, it is they have not listed all of the non characters. Uh,
But you have to know what the non-characters are. Like
but it says the range. Uh, so
says the
in the
range.
table, it has different ranges. So if the value is outside of that range, then like scroll up. Like you see the table, right?
Well, I see this table.
Yes, that is the table I'm referring to.
Oh, got it. Yeah. Okay. These things on the left. Okay. So presumably, I mean, they don't explicitly say this, but presumably everything within these ranges, except the exceptions that they have listed, are valid.
Yes. Oh, like the only exception is the code point in the target range.
Though there are two exceptions.
No, so the code points that are non-characters are things that are not in the range.
No, they're in the range.
Oh, what?
That's what the range is 0x800 to 0x FFFF. So they haven't explicitly said this, but presumably, if they are not covered by these last 2 points, they are a valid character.
Okay, yeah, that is very. I don't know. I disagree with this style of problem setting, but
Yeah.
seems to be what has been said.
But I think I agree that this does feel like a fairly comprehensive list. So maybe we're missing something, but this,
Yeah, so I'd say the other thing is the stuff that's not in the range listed. Uh, so it's like if something is like uh the like so for the four character byte encoding, if you have all ones and for the X, Y's, and Z's, I believe that is not within the range. So and that is not an issue um uh that is listed on the in the bullet points.
why in the world would they list these exceptions without introducing them before or telling you that there are some code points that are non-characters before? That- Okay, this problem. I'm impressed that somebody got this problem because honestly, this seems like a mess to me.
Yeah, seems I don't know who is it.
But you're right, yeah. So something that's too large, something that's beyond this limit, right? Um, that is also an invalid uh, byte sequence that is not covered by this list.
Mhm. Yeah, so it
Okay.
seems in North Central um, Madison. Wait, what? Okay, I assume Madison would be from the University of Madison, Wisconsin Madison, but it's from Minnesota.
Oh,
I believe they're trolling. And
right.
then also a team from Dakota State has solved it.
Okay. Well, and that is a problem.
Yeah, and this
That is
yeah,
a
so
problem of all time.
yeah, it's a bunch of details. I don't know, teams seem to be getting it. Like so, it's one team solved it in one submit, one team solved it in two submits. So uh,
I'm pretty impressed because there's a lot of implementation details there.
yeah,
You have to decode the UTF-8. You have to get all those special conditions right. You have to, yeah, you have to do all your checks. hopefully, well, and there was only the one sample input. There was the sample input with just one example of each each stream. So you have to do your own testing or get it all perfectly in the first try, which is the ideal solution, right? Just get it all perfect.
Yeah.
Okay, so how are we doing? Uh, we can check in on Rocky Mountain again.
Oh yeah. So Rocky Mountain. Um. So Alberta has solved J, I believe, was not solved before, as well as
Nice.
U Calgary has solved it. But still, yeah, only seven problems solved. Alberta has solved. Alberta Azure has solved all seven of them. Um, I guess we can take a look at J if you want.
Sure. So we're coming up on the for that contest, we are coming up on the 2 hour mark.
Yeah, so we're past the 90-minute mark.
Yep.
Um, with seven problems solved, all seven of them solved by the top team.
Okay, well, J is the seventh problem that anybody has solved, and we will take a look if I can find it. Sorry, 1 second. Um, Problem J, spies versus spies. This is, I think, a reference to an old Mad Magazine cartoon, which I'm old enough to remember, but none of the contestants would be. I believe Mad Magazine has gone out of business. So
Yeah, I would not be familiar with that.
all right, Spies versus Spies is a large group game. Every team consists of exactly 2 players, a spy and a handler. So there are four players, no, a bunch of different teams. Each team consists of 2 people. The spies are placed at integer points, x, y, in the playing field, which we can view as a Cartesian plane. So this is geometry somehow. A turn consists of a team's handler telling their team's spy to look in one of the 4 cardinal directions, north, south, east, or west. So north is in the direction of the positive y-axis. The team spy will look carefully in that direction. Any spy that they can see in that direction are eliminated. To be precise, when a spy at location XY looks in one of the 4 directions, they only see other spies that lie exactly on the straight line or originating from XY and drawn in that direction. For instance, if you're at 5, 7 and you look north, you see coordinates 5y where y is greater than 7. Well, pretty straightforward, I think. The spies are eliminated in order from closest to farthest from spy I's position. So you're reviewing the transcript and you're given a sequence of instructions and you want to determine which spies were eliminated in each turn. And this isn't explicitly spelled out, but I assume that a spy, once it's eliminated, it no longer participates in the game from then on.
Yeah, I mean it's you're like told which team, like which spy is performing each action. So I would assume that yeah, it'll never tell you that a team does an action after they've already been eliminated. Oh no, sorry. In fact, in the output section it says if a team is, or if an instruction is
Oh,
given
yeah,
to a
yeah.
spy that's already eliminated,
Yeah, okay.
you output ignore instead of
Right.
doing the action.
So it will give you spies that have been eliminated, but you are supposed to recognize that and ignore.
Yes.
Okay. Um, and of course, don't be stupid and use that spy to eliminate others even after you ignore it.
Yeah.
um, okay, this actually seems quite easy. I'm actually a little surprised that it hasn't been solved
Um,
earlier. Am I missing something that's hard about this? So
I
you
mean, it's
have up
just
to
like a lot of
300,000.
implementation. Like the coordinates can be up to 10 to the 9, negative 10 to
Okay,
the 9
so
to
you
10 to the
cannot
9.
just lay out a grid. So
Yes.
you have to okay.
But um, so yeah, what I would do is you just the easiest way that I see it is, so for each x and for each y that actually appear in the input, you create like a linked list of all the spies that are in that line, and so both horizontally and vertically, and then whenever if an instruction is given to a spy that's not eliminated, you either delete all the things before in the linked list or all the things after in the linked list.
So yeah, and I think you have to be careful. You have to actually delete them because there's this, I think there's this tricky case where say this is the first spy that moves, and then this is the second spy that moves. This is the third spy that moves, and so on, down to 300,000.
Yes.
And so if you are not actually eliminating the spies from consideration, if you are running over all the spies, even the eliminated ones, this will go n squared and it will time out.
Yeah. And yeah, that is a tricky case. Yeah, so you have
Um,
to. Um, I think you can either use a linked list or you can use a double-ended queue. That's also an option. Because the deleted elements will either be all the will either be like the top uh either like all the people at the top of the line or the bottom of the line for a vertical line. Um, so yeah,
as
double-ended
long
queue.
as long as you eliminate the people from the data structure as you go, um, it's fine because you'll only consider a spy once. So whatever data structure you use, you just have to be sure um, you eliminate them as you go.
Yeah,
And I think you could use a map as well. You can just you can you can look up the spy in the map and then go forwards or backwards using an iterator. I think in C++.
yeah, and it depends on like it depends on the details. Like if you're using a linked list, then yeah, you'd have a pointer to the spy you're currently looking at. But for example, if uh, if you're like using a double-ended queue, you just have to like search in the correct direction for the spy that you're currently doing, and then delete all the people to like the left or right of them, for example. And that can also work. And one
Yeah,
thing,
you'd have to be a little careful for using a double-ended queue. You have to be a little careful in that you're eliminating them in the wrong order, right?
uh, oh yeah, but then yeah, you just keep track of all the people you've eliminated, and you reverse the list if you're doing it
You
in
have to
that
you have to
way.
reverse it after that operation. Yeah,
Yeah. Uh, and then
but
another,
like a deck is probably the simplest and fastest if you can get the implementation details right.
yeah, yeah. And another thing to consider is so like when you delete people, so if you're doing the double-ended queue solution, um, if you delete anyone from a horizontal queue, you have to keep in mind that like they'll
Yes.
still be in the vertical queue even though they're eliminated. So then if you eliminate them later from the vertical queue, you have to like keep track that they were already eliminated, and even though you're deleting them now from the vertical queue, you don't output them in the current query because they were already previously eliminated from the horizontal queue in some previous turn.
Right, and that's a very good point because you cannot just eliminate something from the middle of the deck, which you would have to do if you were eliminating them at the time that they were eliminated. Or sorry, if you were removing them at the time that they were eliminated. Whereas if you're using a map, or possibly the linked list as well, you could eliminate them from both data structures at the time that you eliminate them.
Yeah, and yeah, just a bunch of implementation details that yeah you have to be sure to get correct.
Yep. So just yeah, don't go n squared.
Yeah,
That's the most important thing. Don't go n squared.
figure out a way to do it and without doing something that's n squared.
Yep. Cool. Okay, so that definitely is a level up from the first six problems.
Mm-hmm.
Okay,
So Rocky Hour basically at the 2 hour mark, still 7 problems solved. I guess we can look at North Central and Mid Central.
sure.
So yeah, North Central still the 6 problems we had before, and for Mid Central, Mid Central in yellow. I think I has been newly solved. But yeah, 6 problems there as well.
And possibly the same six problems as North Central.
Yeah, no, because A has
We'd have
been
to check.
so C A on North Central is C on Mid Central. So yeah, the problem we went over with all the UTF-8 code points has not been
Yep.
solved on mid-central.
Oh, okay. So there's something on mid-central that has been solved that is not, or that has not been solved or is not on north central.
Yes.
Okay.
I believe permanent, or I don't know which one do you want. Do you want to look at that problem to see if it's interesting? It's called
Sorry,
permanent.
which one?
Uh, or so problem J on mid central is called permanent, and I believe it's not been solved on north central.
All right. Problem J on mid-central, permanent.
Oh
It's
yeah, the
another
problem
map.
isn't even on north central.
Okay. So this one's unique to mid-central.
Yes.
And it looks like another math problem. Okay, sharing my screen. All right, the permanent of a square matrix is similar to the determinant, except that it does not alternate signs. Instead of subtracting terms, all terms in the expansion are added. Formally, for a square matrix A with n rows and n columns, let aij denote the entry in row I, column j. The minor of row I and column j denoted aij is the smaller matrix that you get by removing row I and column j from A. So then you define the permanent recursively as the sum for some, you pick some row, and it's not going to matter which. You pick some row, and then you just sum it recursively as that the element in that row multiplied by the permanent of the smaller matrix that you get from deleting a row and column. Sort of like one way of computing the determinant, but without the sign consideration. Okay. So you are given, so it's up to a 10 by 10 matrix.
Yes, I believe you can just compute this naively.
Yeah.
Because so it's like,
So it's 10 factorial if you do it naively.
yeah, which should easily fit in time. 4 seconds. I think it would even fit in within 1 second.
Yeah. What is that? That's like 3 million or something?
Yeah, 3628800. I think it's 36 million. Wait, I don't know.
Let's look it up. Really, contestants should know this by heart, but I don't.
Yeah, it's 3 million, just over 3 million.
3 million.
So,
Oh,
yeah.
okay.
So yeah, what you do is, you like, so for your 10 by 10 matrix, you go through the first row, then you need to solve 10 copies of the problem for a 9 by 9 matrix, and then again for each 9 by 9 matrix, you need to solve 9 copies for an 8 by 8 matrix, and so on. So yeah, so the total complexity is 10 factorial, and should be quite doable.
Should be quite doable.
Depending on how you do the recursion, there might be details of like, do you just keep the indices of, do you like keep the indices of what you tried, or do you keep the,
Yeah, it feels like you could TLE maybe if you're creating a new matrix each time.
yeah, but if you're creating a new matrix, you could TLE, but if you're just keeping track of indices and then indexing into the original matrix, it should work out quite well.
Yeah, I think I agree. Also, it's not immediately obvious to me, but it feels like maybe you could just iterate over permutations.
Yeah. So yeah, permanent is also just it's a well-known math object, and it is just sum over all the permutations of you take a permutation of a column, and then take like, I don't know, like second element of the first row, first element of the second row, and third element of the third row that corresponds to the permutation 2, 1, 3, and then you sum so for each permutation you find the product of all the elements, and then you sum all of those up.
Yeah, just sum over all permutations of this, right?
Yeah, so that's like slightly slower. It's like n times n factorial, but this should still quite easily fit within the limit. Yep. I guess one mistake you could make, because this size of the matrix is 10 by 10, and each value is has absolute value in most 10, the answer can be quite large. So if you're using a C++ signed overflow, or just overflow in general is always a issue if you choose a data type that's too low. If you just choose a standard 32-bit integer, your answer will overflow.
Yes, and do the inputs cover that case, the sample inputs?
Yeah, the sample inputs are all quite small, so they do not cover that case.
Okay, so yeah, if you accidentally use 32-bit integers instead of 64-bit integers, you will get the sample inputs correct, but you will get wrong answer. So overflow. Don't overflow.
Yeah.
Okay.
Yeah, it seems like a rather simple problem, although like you reading through the math, like reading a math problem is always quite scary. So maybe that is why
Right.
it's taken a while for teams to solve it.
Right. Okay. There are probably a couple of other north central or mid central problems we could look at.
Yeah. So for
So
mid
H,
central,
let's see, H in mid central has been solved a lot. Oh, that we did that one, intervals.
intervals with some other problem. Yeah, there's a problem on north central that we went over. Seems 10 kinds of people is a problem we could go over. Or I Pascal magic.
Sure. Let's look at 10 kinds of people. Oh, this is the old joke
Yes.
about binary. Again, this is a little too large for me to fit on the screen, so I'll just share the browser. Okay. So there's a joke about 10 kinds of people in the world. There are 10 kinds of people in the world. Those who don't understand binary, those who think there are only binary and decimal, and those who realize there are other bases. It's actually ternary. This joke is about numbers in different bases or radices. The notation for a number represented by digits d in base b is written as d with the subscript b. For instance, 10 with subscript 2 is the binary number 10, which equals 2 in decimal, and 10 with a subscript of 3 is the number 3 in decimal represented in base 3. All right. In this problem, we dig a little deeper into that idea. You're given two numbers without specified bases. Your task is to determine whether there exist bases for each number such that their decimal values are equal. So you are given digits that are up to 61 in value, basically. And of course, if you're given, for instance, if you're given the digit 7, you know the base has to be at least 8. The base has to be at least as large as any of the digits that you're given. It has to be larger than any of the digits that you're given. So you can consider bases. So that's nice that they actually limit the bases you have to consider. You only have to consider the bases from 2 up to 7,500. Otherwise, it could be a little bit tricky to figure out what the upper bound of what you need to consider is. But no, they explicitly say you only have to consider up to 7,500. You are given up to 500 pairs of numbers.
Yes. So the example is in the statement is pretty simple. It's like you have 10 and 4,000, and they can be equal if 10 is actually a number in base 4,000, and 4,000 is just a number in base 10.
Yep.
And yeah, it's in general given two strings of digits, determine if there's two bases such that the two numbers are equal.
And you have to output the bases. You have to output the actual value. You have to output the bases
in decimal, and then the two bases that would make it work.
But you do not have to tiebreak. So
yeah, so any output is accepted.
Yep.
So yeah, the simplest solution, so this would work for one test case, is you just test all pairs of bases. There's at most 75,000 squared, about 50 million. So the general accepted amount of operations you can do in 1 second is 10 to the 8, which is about 100 million. So if
Yep.
there's just one test case, you could just test all bases A and B, convert the first number to base A, second number to base B, check if they're equal.
Yep. But you're not going to get away with that with 500 test cases. So
Yeah, so but with 500 test cases, yeah, that's about 50 million times 500, not going to pass in time.
and
However,
so all you're actually doing is you're considering all the possibilities for the left side. You're considering all the possibilities for the right side. There is no interaction between them.
yeah,
So
so
in fact, you are just intersecting two sets.
yes, I see. So yeah, you just compute. You just check all 7,500 bases for the left, all 7,500 bases for the right. Then you have two sets of numbers that it could be, and just using a set in. Well, I guess the easiest way is just sort two lists, or it could also be easy just use a C++ set.
Sure. Yeah.
And
You
yeah,
could cheat using data structures. Yeah.
yeah, anything you want to do can just like you have to figure out some subquadratic way to, given two sets of 7,500 numbers, see if there's any overlap between them.
And another thing to check, you have up to 5 characters and the base can be up to 7,500. Is that going to overflow in int 64?
And int 64.
Let's find out.
I'd assume they're nice enough that it wouldn't.
I would hope so. I would be pretty annoyed
So
if
it's
that was not the case.
so it's only uh
It
so
looks
the
like
largest uh the leftmost digit has only value up to 7,500 to the fourth, and that the value of that digit is the most 60.
that's a good point.
So even if you bound it up by 10 to the fourth, that's only 60 times 10 to the 16, which fits inside a 64-bit integer.
7,500 to the fifth does not fit inside a 64-bit integer,
Yes,
but
but
you're right.
the maximum number is only 60 times 7,500 to the fourth, which
Yeah.
does fit.
So you do not need to go to Python and use big integers for this
Yeah.
problem. Okay. So yeah, I don't think there's anything else complicated about this problem, right? Like you just
Yeah.
have to get the base arithmetic correct. You have to do some sort of efficient intersection.
I guess the most complicated thing is like if you have the number 1z, making sure that like because you could just or like even the number 17 as you said before, if you do it naively, you might like be like, oh, that's fine in base 6, it can be 6 plus 7, even though it's not
Right.
actually fine.
Right. So I wonder if the samples are enough to catch it if you don't lower bound the base.
Um, I it
I'm not
seems
sure.
hard for it to catch it 'cause, like even if uh even if you do something that's invalid, your code might still um like it could output even if it does something that's even if there's an invalid solution, your code might still produce a valid solution, a different valid solution.
Oh, that yeah.
Although I guess the cannot make equal cases could catch that, depending if they're nice or not.
Yeah. I mean I can't eyeball these sample inputs and tell whether they're testing that case or
Yeah,
not. So
it's
who
quite
knows?
yeah. Those last two samples are quite large.
Yeah. Okay. Cool. The other problem we wanted to look at from Mid Central was, oh shoot, I closed the window.
Mid Central. So since we last looked, C has been solved. That is artist who shall not be named. The problem we looked at before. I believe Pascal Magic problem I was the last problem.
Yep. Pascal Magic. And that one is not on North Central.
Pascal Magic. Yeah, it's not on North Central.
Okay, let's take a look at Pascal Magic, which is problem I on Mid Central. More math, yay!
Yeah, seems to be quite a few math problems. I think
Yep.
all three we looked at were from Mid Central. Yes.
And I'm sure teams have noticed, competitors have noticed that pure math problems are just not all that common on the finals.
Yeah.
But they're quite common on code forces, or especially like some of the other like at coder. They're all math problems, right?
Yeah. And yeah, just say low implementation. Not necessarily math, but
Okay.
yeah, and it's pretty commonly math.
Yeah. All right. Pascal magic. Pascal's triangle has many fascinating properties. Yes, it does. Formally, row n of Pascal's triangle contains n plus 1. Okay, we know the definition of Pascal's triangle. Oh, well, maybe, okay, maybe we don't know the definition of Pascal's triangle. Pascal's triangle is just, it's just this thing where every number is the sum of the two numbers above it. And then another way that you can define it is by using combinatorials like this. Okay. Your friend has invented a magic trick. Given a row number n and a prime number p, determine how many entries in the nth row of Pascal's triangle are divisible by p. I feel like I've seen this problem before, actually. Unfortunately, your friend doesn't actually know how to perform the trick. Help them by writing a program that computes the answer so they can amuse audiences everywhere. Um, and so you have a very large n, which is the row of Pascal's triangle,
Hmm.
and you have a very large p. So you are not going to be able to just iterate over the row.
Yeah. So it's guaranteed that p is prime, and there's also a very interesting guarantee that n over p is at most 10 to the 6.
Yeah, that is interesting, isn't it?
So, uh, okay, I'm not even going to mention Lucas's theorem, and I guess I just did mention it, but there is, yeah, so there is a way to solve it without this n over p constraint, but I think that, like, Lucas's theorem falls into, uh, it would be kind of a bad problem to require use of that because, it's like either a theorem that people know or they don't know, and it's like hard to discover. But I think the condition n over p less than or equal to 10 to the 6 makes the problem a lot simpler. Because so if you look at the factorial definition, um, basically whether this factorial is divisible by p means is asking the question: are there more powers of p in the numerator or the denominator?
Yep.
And one thing you can note is that given uh, if you take x and x plus 1, the numbers of factors of p you usually will not change. It'll only change if either k is a multiple of p or n minus k is a multiple of p for like one of the two sides.
Yep. So if this is a multiple of p, then that changes. And if this is a multiple of p, then that changes.
To be more explicit, like every move from n choose k to n choose k plus 1, uh, so the k factorial increases from k factorial to k plus 1 factorial. So we divide by a factor of k plus 1, and then the n minus k uh, removes the factor of goes to n minus k minus 1 factorial. So then we're essentially multiplying by a factor of n minus k because we're removing a factor of n minus k from the denominator. So yeah, basically there's just like a bunch of integrals where like k factorial has the same number of factors of p, or n minus k factorial has a number of factors of p, and the total number of differences, the total number of changes in the number of factors of p is at most n over p for each of the two cases.
Right. So you consider only cases where k factorial or n minus k factorial changes. Now, if I were coding this, I would actually just not even worry about the details, and I would just do like this minus one, and then this plus one, just to make sure I got all the cases, something like
Yeah.
that.
Um,
But
and
you know, you could do more analysis to figure out exactly which number is the one where it changes.
and yeah, to be clear, changes here refers to the number of factors of p. Uh, So yeah, like basically, like when we're determining if this number is divisible by p, we count how many factors of p is in the numerator, how many factors of p are in the denominator, and then because p is prime, this is all we need to care about in terms of whether the total value is divisible by p.
And you do need to know how to count factors of p in, say, k factorial. And so
Ah,
that's going to
yes.
be p, or sorry, k over p plus k over p squared plus k over p cubed plus, and so on. It's
Yeah,
this accounts for all the multiples of p. This accounts for all the multiples of p squared. This accounts for all the multiples of p cubed, and so on. And eventually, of course, this is going to go to zero. So it's
yeah,
not
it'll go
an
to zero quite quickly.
yeah.
Yeah, worst case, if P is 2, that'll take around 60 steps for n around 10 to the 18.
Yep.
Yeah, so should be pretty efficient to compute that number.
So I think I agree that that's the intended solution. So you consider only certain parts. You consider certain intervals as all being the same, and then you just implement the efficient way to count, so you don't have to go 1 times 2 times 3 times 4 up to n, and then I think that solves the problem.
Mm-hmm.
Cool. Um, do you do you want to describe the Lucas theorem solution? Because I'm not fresh on Lucas theorem. All I remember is that there is a theorem about this, but
Yeah, I think describing it, yeah, you can look it up if anyone watching wants to look it up, you can see
yeah.
it, and I think it basically, uh, it ends up being pretty similar to the solution we currently have, where, and like
There's some sort of test of like digits in base b,
yeah,
right? Or base p.
yeah, you just like you write n in base in. Oh yeah, I'll just tell you the condition that
Yep.
Lucas theorem will give you is if
Yep.
you write out n in base p, and then you write out k in base p, if all the numbers, how does this work exactly? If like for every pair of digits, so like all the ones digit, then the p's digit, then the p squares digit,
Yep.
if for any of them, the lower number is higher than if the value in k is bigger than the value in n, then the result will be divisible by p.
Okay. That doesn't actually help you solve this problem better, does it?
Um, I
Because
think with like some complicated DP, it would allow you to solve it for uh
oh,
even
okay,
if
yeah,
you
yeah.
didn't have the condition that n over p is low.
Oh, okay, yeah. DP over digits, clever. Yeah,
Yeah,
that would be neat.
but yeah, for this problem, just doing it directly seems to be a lot simpler,
Yeah,
due to the n over p condition.
yeah. Nice. All right. We haven't checked in on Rocky Mountain in a bit.
Yeah, let's look at Rocky Mountain. Seems yeah, L has been solved on Mid Central, but yeah, let's look at Rocky Mountain for a second. Oh, a lot of problems have been solved.
Oh boy.
12. Every problem but M has been solved in Rocky Mountain.
Wow, that's impressive. So after those first 6 easy problems, people just branched out.
Yeah, it seems that and Alberta Azure has to be doing very well. They've solved all but F, K, and M, but then the second and third place teams have respectively solved K and F, uh, leading leading to almost every problem being solved before the contest is halfway done.
Wow. Well, I mean, it is a good result if every problem ends up getting solved, but
And yeah, the concern is just like because everyone can see the leaderboard, they can see that everything but M has been solved. Although two teams are attempting M right now, they
yeah.
might just go on to the problems that have actually been solved rather than attempting M.
So that's actually neat. If M is solved, then every problem will have been solved. That's
Yeah.
that's pretty good. I mean, it may be a bit earlier than the judges would like, but that's still pretty good.
Um, I don't know what problem. So which problems in Rocky Mountain have we not gone over?
Well, I think we went over the initial 6 and then we went over J, and I think that was it.
Okay, so that's B, D, and K are what we need to look at. Do any of those problems stand out to you?
B, D, yeah, and K and M, which has not been solved yet.
Oh yeah, I assume we'd go over the problems that have been solved, but if you
Sure,
want to go to M, we can look at it.
sure. I mean, yeah, we could. Well, which one's been solved the most? So B has only been solved by one
I
team.
think they've all been solved by one team.
Actually, let's bring up the statistics. We can see that. B and D have been solved only by U over Alberta, as far as I can tell. And
Yeah, B, D, and K. Oh, and also E. We don't think we looked at that either. All
oh, you're right. We haven't talked about E yet. Draft lottery.
Oh yeah, so B, D, F, and K have all been solved by one team, and D has been solved by two teams. So I guess we should look at E.
Sure.
Seems to be the next easiest problem.
although not by much.
Yeah.
All of these problems are kind of
Could
stuff
just
into.
be a random luck basically, but
Yeah. University of Alberta and Arizona State U are the ones who are trailblazing. And U Calgary, go U Calgary. They got problem J. Okay, so let's discuss problem E on Rocky Mountain. Draft lottery. Sharing. All right. So in professional sports, there's a draft each year after the end of the season. It allows the teams to select new players from among the available prospects. The order of selection is often determined using a lottery. A team's odds of getting a draft pick are based on how the team finished during the regular season. The worse your record in the regular season, the higher your chance of landing a top pick in the lottery, thus strengthening your team before the next season. So it's not a case of the winner, the rich get richer. It's a case of the poorer getting richer. Here we describe a novel draft lottery process. Each of the bottom end teams will have their team's logo placed on a certain number of lottery balls. Each ball has exactly one logo. The ith worst ranked team receives BI ping pong balls in the lottery. So you're given a list of BI numbers, and or you're given the list of B's, and if the team I has a worse record than team J, then BI is greater than or equal to BJ. All ping pong balls are placed in the mixing container, and then the balls are drawn sequentially. The team whose logo is on the first ping pong ball drawn gets the first draft pick. Um, and the ball is discarded, so there's no replacement. The second ball is drawn, and so forth. When a ball is drawn for a team that has already received a pick, it is ignored and another ball is drawn in its place. There are a lot of rules here. The first
yeah.
three picks are assigned by this lottery drawing. After the top three picks have been assigned, the remaining teams are assigned picks in order from worst record to best. Okay, so it's random only up until three, and at that point they go with just the bottom to the top.
Yes.
All right. You've been hired as a consultant. Oh, by the way, are all the B's positive?
Yes. So it's B is between 1 and 50.
B is between 1 and 50. All right. You've been hired as a consultant, blah, blah, blah. You want to assess the values of potential training situations. So given the counts, you must calculate the answers to queries of the form TK, which means what is the probability that team T receives one of the first K draft picks? Okay.
And I think an important thing to note is N is at most 50, which is rather small.
Right. So there aren't very many teams. There are at most 2,500 balls.
Mm-hmm.
Um,
I mean, so with N at most 50, you can be like, okay, there's 50, uh, there's 50
yeah.
teams that can get the
You
first
just do 50
draft
cubed,
pick.
right?
Yeah, 50
Yeah.
cubed.
Yeah.
And then I'd say the easiest way to implement it is once you have all these 50 cubed ways the draft could go, by the draft I mean the lottery balls. You then generate the order of the remaining 50 teams, uh, or the remaining however many teams, and then just like, uh, you so like there's 50 cubed ways for the balls to be drawn. For each of them, you compute the probability that the balls get drawn that way, and for each team, you like add the probability to like which place they got.
Yeah. You're ending up computing this for all T and pause, right?
Yes.
Or you're actually computing counts, but for the probabilities, you just divide
By the
by the
total
two.
number.
Yep. That seems reasonable.
Or I would say this is a bit. Um, or what do you mean by divide by the total number? Because it's not each possibility is equally likely.
Well, but what you would be doing is you'd be multiplying by the number of balls, right? So, uh,
But the thing is, so it's like, I guess one thing we can say is like once, um,
Oh, wait,
Like,
actually,
because
no,
once, yeah,
hold on. There's a problem. When you pick the first one, right?
yeah,
The remaining balls for the first team remain in the lottery.
but they just ignored. So it's yeah. So I guess one thing to note is, uh, because the balls
But
get
it matters.
ignored.
It matters how many of them are picked before the second team gets one.
Why does this
You can't
matter?
totally ignore them, right?
No, it says it is ignored. So
Yes,
this,
but aren't they all, oh no, sorry. No, you could just pretend they're all gone. Okay, never
yeah.
mind. Yeah,
So
yeah,
yeah,
okay.
one thing to note is yeah, because when a ball is drawn for a team that's already received it, it's ignored. This means that it's a like the fact that the balls remain in the lottery it doesn't matter. It's
Yeah, you're right.
equivalent to uh, what am I trying to say? Or it's like yeah, like you can just assume it's picked from all the balls from teams that have not been that have not already been picked because it's equivalent because if you draw any of the dead balls, then they're just ignored.
But so you're saying you're claiming that this is not just a count. So isn't this just a count of the number of ball like B I1 times B I2 times B I3
Uh,
for your three picks?
yeah. So
Isn't
the
that the number?
but yeah, so that's a number of ways for it to happen. But
Yeah.
if B1 is very high, if BI1 is very high, that means BI2 has a much higher chance of being picked uh, in the next draw, because the denominator is different.
Yeah, you're right. The denominator is different. So you actually do have to work with probabilities, not
Yes.
with counts. Okay, I agree. So instead, you just figure out, okay, after this team has been picked, this many balls remains. That's the denominator, and then yeah, you move forward. Okay. Um,
I guess one thing to be careful about when working with decimals is the error. Although it allows a relative error of 10 to the negative 6, so I believe this shouldn't really be an issue for any implementation.
you are summing up to, I guess, 50 cubed numbers, but
Yeah,
that's not very many, honestly.
yeah. And they're all positive, which is
Yeah, yeah.
usually when dealing with large issues in relative error, if all the numbers are positive, if all the like if you're using like floating point numbers, if you're adding a bunch of positive numbers, you usually don't need to worry too much about relative error.
Yep.
The issue is usually like if you're adding one and negative 1.000001, then like that's when you can have errors creep up on you.
Yeah, that's known as catastrophic cancellation, and it's a big problem with floating point numbers.
Yeah,
But that
but
doesn't happen.
yeah, because all the numbers are positive, shouldn't really be an issue.
Yeah. Okay. Seems fairly straightforward. Um, I'm not even sure. Is there really a way to get this wrong?
I mean, you were trying to do stuff with counts, which was wrong.
But then you get the samples wrong.
I guess so. Yeah.
But you're right.
Um,
Yeah. You would notice that the counts are not working. So yeah.
yeah. I think if you try to do each query independently, so there's 200 queries. If you try to do them all independently, you could have trouble with the time limit. Um, but yeah, it seems like if you just pre-compute all the numbers, uh, using one pass, it shouldn't really be an issue. And from what I've seen, no team has a wrong submission for this problem.
Yeah. It seems fairly hard to screw up, but there's there are implementation details because of the top three, the whole setup of the problem. There are implementation details, but it doesn't seem it seems like if you get the sample inputs right, you're probably correct.
And yeah, currently, yeah. So since we've last looked at it, yeah, it seems three teams have solved it, and all three of them in one try.
Nice. Okay. Um, so we also wanted to cover
And yeah, there's three more problems. I think B,
B,
D, and
D,
F.
and F and K.
That sounds correct.
Yeah. B, D, F, and K we have not covered yet. How are we doing on time? It is 2.5 hours past the start of the first contest, and 1.5 hours past the start of the other two contests.
Yeah, so yeah, halfway through the first contest, and then uh, 90-minute mark for the other two contests.
There's a big gap between second and third. So first and second have 10 problems.
This on Rocky Mountain.
On Rocky Mountain, yeah. So they're looking pretty solid.
Oh
Although
yeah, wait.
this does look like it's a potentially all killable contest, right?
Yeah, and depending on M, right? M has also been solved. So
Has
yeah,
it? Ah,
yes. In fact, it's been solved twice in Rocky Mountain.
by whom?
Arizona State's Second Wind and University of Calgary.
Nice. Nice. Okay, so all problems have been solved now.
All problems have been solved. Yeah, we'll see. Seems a bit early, but
Yeah,
it
yeah,
might just be teams branching out in their special areas and solving the problem they have most experience with, and they'll have trouble with the other problems.
could be. But
I'd
I
also
will not be
take.
surprised if a team solves all problems.
I'd like to take a look at the Mid Central scoreboard.
Sure.
It's very interesting right now. So first place, University of Chicago, Pock Pock Pock. Behind them, four teams from University of Illinois Urbana-Champaign, which will be competing. So yeah, top five is very interesting.
Okay. You said that five people from this region, five teams will be going.
So it's I don't think it's been decided yet. I think it's
Oh,
guaranteed at least three, and
okay. And but no duplicate teams from
yeah,
a
so
year.
no duplicate teams from any university. And then usually, in the past 2 years, I believe. So it's like how it works is there's three teams that are guaranteed to qualify, and then uh, after all those teams qualify, the ICPC organizers decide some wildcard teams. And
Right.
I think historically, Mid Central has gotten around two wildcards.
But it looks like uh, Urbana Champaign, their main competition is each other.
Yeah, and yeah, this was pretty expected, but yeah, very interesting to see four teams all right next to each other in the standings. Oh yeah, and just looking at the bottom of the scoreboard, just so many wrong submissions to D.
Yeah, I remain by my stance that that's a trap. D is a trap.
Yeah, and like so for example, University so limit testing currently in third place, uh, three wrong submissions on D, and also they took 70 minutes to solve it. Uh, so yeah, that's why they have almost double the penalty of the second place team.
How about North Central? Is B killing people on North Central? Let's take a look.
Yeah, bunch of wrong submissions on B. I mean, like, yeah, I think, um, so like all of the like the tricky parts of the problem, I think are fair game. It's like okay to have a problem that's tricky to implement, but yeah, I think the wording of that problem was just like not
Yeah,
completely specified, and that
I,
does not
I,
seem like a fun way to distinguish contestants on whether they guessed the correct interpretation.
yeah. Especially since it seems almost everybody got the wrong interpretation on their first try, which is a bad sign, right?
I mean, like just because a team got a wrong submission doesn't mean they have the wrong interpretation. There's other edge cases we discussed that, although
True.
like, um, yeah, I guess the other edge cases we discussed were also just due to misreading the problem, which is like somewhat acceptable. Like, yeah, teams need to learn how to read problems correctly and just like take their time with
Sure.
problems. But
Yeah, yeah. If that were the only issue, then like if the issue were weak sample inputs, I wouldn't have as much of a problem with it.
yeah, I definitely agree with that.
Cool. Do we want to discuss another problem from, let's see, what have we discussed from North Central or Mid
North
Central?
Central. Uh, we've discussed ABD. We could discuss E. Seems to be a relatively easy problem. Uh,
Oh yeah, lots of solves on E.
Also G. G seems to be around. I think slightly easier than E from the standings.
Yeah. Okay.
Yeah, either of those two.
All right. Let's look at G merging items,
Merging items.
is which is not on Mid Central. So this one's
Okay.
only
Only
on
on North Central.
North Central. right. Recently, Sam was playing the game ICPC. In this game, you merge two identical items to make a more valuable item. Sounds like a lot of mobile games. Items will be referred to by their value in the hierarchy. So two value one items, when merged, will become a single value two item. Similarly, two value five items, when merged, will become a single value six item. A player can choose when to merge pairs of items with identical value. A player may also request and receive an additional three value zero items. Okay, while playing, Sam decides he wants to create a value 10 item and wonders how to proceed, starting with the items he has available. Sam thinks it would be nice to have a program that would tell him what values of items he will have remaining after requesting additional items and merging all possible pairs. So we're not actually coming up with a strategy. All we're doing is what are we given? We're given the state of the board initially. So how many items there are on the board? Up to 10 items on the board initially.
And then you can request up to 300 times more items, which gives you up to 900 extra level 0 items.
And then yeah, so there's no like there are n requests, but there's no actual details of the requests because every request is the same. It's just you get three
Yes.
more level 0 items. Okay. Um, this seems like it's just simulate.
Yeah, I think you can simulate. I think one thing that could be interesting about this problem is, like, if you view the values of the problems in binary, uh, it's basically like merging two level 5 items to a level 6 item. It's just like when you add uh 1000 and 1000 in binary, you'll get one with one extra zero at the end. But I don't think this observation is needed to solve the problem.
No, I think if you just track you just track an
Yeah,
array of like n items,
and yeah, you can just have a count of like
you can just
11
have the count.
numbers of how many like the count of how many items of each value you have,
Yeah.
and then just if any of these numbers are at least two, you merge.
But
Um,
I like your observation is that all you really need to track is like you track B, which is the sum of value of all items.
or it's like two to the value. Um,
That's sort of what I mean. Yeah,
yeah,
yeah, like two
and
to
yeah,
the. You're right, two to the value. Yeah, two to the value for all items, and then you end up with a binary string. If you write it in binary, you end up with something that looks like this, and this will be the number of value 0 items. This will be the number of value 4 items, and so on.
yeah, it's
And so
a
you don't even need to do the merging.
yeah. If you do it that way, it's just adding numbers and then add three times the number of requested items or number of requests. But like yeah,
But
so
that's not needed. Not needed at all.
yeah, you can also just do the simulation and that will also work.
Yeah. All right. Well, I can see why a lot of teams have solved this because I don't even really see any traps.
Yeah, and it seems um
Especially they don't even say, or they explicitly say that it'll never go above
yeah
10. So there's not even a trap there.
yeah seems quite simple uh and people are getting wrong answers. It's like
People are getting wrong answer. Okay.
20, so it's only 28 accepted out of 47 total submissions. Um, and maybe just people dealing with the requested items incorrectly in some way. Uh, or maybe it's, I guess, one thing you have to keep track of is if you're just merging items naively, uh, you might have the items in the wrong order. And the output specifically requests that the outputs must be increasing order. So maybe people are having issues with that.
Yeah, I guess I could see that. Just yeah, you sort the output incorrectly. Although it would be weird if you got that wrong on the sample input. I don't know.
Yeah, I don't know. Seems yeah. I'm not sure exactly what people are getting wrong, but
Yeah. I'm a little suspicious I might be missing something.
um,
But I don't see where this seems so straightforward. I just don't see where I'm what
and
I'm
yeah,
missing.
like because of the value observation, I guess it doesn't really even need that observation. But like, yeah, it says
Yeah.
after everything possible has been merged. Like, and I guess one thing you could do incorrectly is if you just have a list of all the current items that are available, you might um you might miss some merges. And like in particular, if you have like maybe like after merge, a new merge might become possible, and but because of like how you're checking each possible merge, you might miss a certain case.
Yeah, maybe. I don't know. All right, we can move on.
Yeah, I guess we can look at um I think yeah, the other easy problem was E from North Central. That's or
Sure.
maybe not easy, but a lot of teams have been solving it.
Yeah, we see a lot of solves. So this is Jack and Jill, and it is not on Mid Central.
Mm-hmm. And yeah, I'd say 10 solves by the 90-minute mark. I'd say yeah, we're firmly in the middle of the set territory.
Okay. Share. Uh, okay, so it's called Jack and Jill. And they have the poem Jack and Jill, which Americans would know, North Americans, but
Oh,
maybe
is
maybe
this not
not.
a thing in elsewhere?
Well, I presume that this is sort of a cultural thing that people from Europe or somewhere else might not know.
Sure.
Um, oh, actually, no, wait, this is not the standard one.
I feel like the standard one is only one verse, right?
Yeah, so they've added a few verses.
Or I'm not sure if they added it or if it's just something that most people just don't.
Yeah, well, I didn't know the other verses. So,
Yeah.
okay. So tumbling down a hill can be a bit risky. How risky may depend on whether the tumbling is rolling on one side like a log or somersaulting head over heels and breaking your crown. Regardless, this problem is concerned with a possible combination of side rolls and somersaulting. Given a hill of a certain length and the effective circumferences of the tumbler, your task is to compute the combined number of rolls of each variety that most closely results in an integral number of rolls taken to reach the bottom of the hill. Okay. So what I'm reading is that to simplify a little, you've got two different numbers and you just want to figure out how close you can get um, how close you can get to a target number just by adding those numbers together.
Mm-hmm. And
Um,
yeah, in particular, it seems. Uh, okay, never mind. All the numbers in the
how does
sample
the rounding
have.
work? Oh, sorry. Yeah.
All the numbers in the sample have at most one decimal place, but it seems that's not guaranteed in the problem statement. So yeah,
Interesting.
they could be many decimal places in the actual problem.
No, it does say that all measurements are to the nearest zero point 0.1 meters,
Ah, okay, yeah, okay, that makes it
which
a
is
bit
important because
simpler. Yeah,
otherwise I think you get like or you get like big number effects and stuff like that.
yeah, yeah. Nearest 0.1 meters means that effectively you can just multiply all the numbers by 10 and then round them, and that'll just be an integer number, and you don't have to deal with decimals.
But here's the question: if you have a partial roll at the end,
So
if you have more than half of a partial roll at the end, does that count?
So how it works is you have to choose a whole number, and you want to get the distance, like the whole, like given the whole number of rolls for the log rolls and the head first rolls, you want to get the distance to be as close to the actual distance as possible.
But
So it's
is that
not like you're
without
doing
going
a
over?
partial roll. You're not
Is
doing
that
any partial rolls.
yeah? But so is that without going over, or is that just distance on either side?
I believe it should just be distance on either side.
That is how I'm reading this.
Yeah, it's like choose any number of rolls, and you want to be as close to the input length as possible.
Okay.
So yeah,
So the numbers are up to 2000 and there's only one case. So you could even do 2000 squared. I mean,
yeah.
that's silly.
So one thing
You
you can
could.
do is yeah. So this you're gonna choose 1 to 2000, or I guess 0 to 2000 log rolls, 0 to 2000 head first rolls, and then yeah, you can just try all of them, see which one's closest, break ties as the problem states, and that should work. Uh, I believe, yeah. So like if you're working with floating point numbers, there might be some rounding issues that you might deal with, and yeah.
Actually, yeah, 'cause that sounds because so the problem is uh, point one is not representable
Mm-hmm.
exactly. I could very much see that if that you could have, for instance, a case where like you can get 99.9 and 100.1, but because of edge effects, you pick these are not considered equal, and so you pick the wrong tiebreaker.
Mm-hmm. Yeah, and yeah, the easiest way, like, yeah, I think a common. It's not always possible, but if you can, just like working in, just like rounding these, like multiplying by 10 and rounding to an integer, uh, in this case gives you exact results and does not carry the risk of floating point error.
Yeah. Or if you don't do that, then you have to make sure that you do you do like fuzzy arithmetic, right? Fuzzy.
Um, and yeah, there's always like,
Because
uh,
these numbers are always either equal or zero point 0.1 apart. So
yeah,
as long as your epsilon is less than zero point 0.1, you're not going to get it wrong if you use
yes.
fuzzy.
Yeah, that's like, it's always possible and it's usually pretty complicated. Sometimes it's necessary. So like,
Yeah.
yeah, here I definitely recommend trying to convert to integers, but
Yeah.
yeah, I think yeah, just comparing the distance. Like if you compare these distances, like uh, 99.9 is zero point 0.1 away um, from 100, and uh, like you might have some small error in that number, but if you just round to the nearest zero point 0.1, it'll give you the correct answer. Because like yeah, the error can is will be very small.
Yeah.
But yeah,
Okay.
as long as like yeah, there's many ways to deal with this floating point imprecision. Uh,
So
and
this problem is straightforward, but it's almost like just a little bit of a quiz on do you understand floating point issues?
mm-hmm. And yeah, just like any any strategy you can to avoid them will work here, but you
Yeah.
just have to be very careful. And
You have to know that the problem exists. That's
oh
the key
yeah,
thing.
yeah, that's yeah, I think that that's often the main issue.
Yeah.
Yeah, like in the first contest I did, like I think around 10 years ago at this point, our team lost due to a floating point error, and
Right.
we were very sad, and
Oh
we
no.
never experienced that problem before, and I've always been very careful about floating points ever since then.
I have a tale from the finals. There was a problem that I posed that involved floating point numbers. It was probabilities, but the probabilities could get really, really small.
Ah,
And it turned out that what are called denormals entered the picture and caused some teams to time out. So what denormals are is that the floating point specification allows for extremely small numbers that are so small they can't properly be represented with bit patterns, with the normal floating point bit patterns. But for some reason, the standard still forces you to support them. And a lot of processors will go into a very slow mode when working with these numbers. Like they can take thousands of times longer to work with these numbers. So, so what confused us was we saw this team's submission, and it had no ifs or anything like that. So it would be the same iteration of operation, the same order of operations, the same operations done, no matter what the input was. But they timed out on certain inputs and not others. And that was because of denormals, because sometimes they had these denormals.
that issue. Yeah, I think I was watching the live stream at the time, and yeah, they were talking about it as well. The World
Oh yeah.
Finals live stream.
Okay.
Um,
So anyway, hopefully you don't ever get into a situation where you have to worry about denormals. But uh, floating point numbers are just horrible. That is the big lesson.
yeah.
Okay, so I see Wisconsin Madison has 7 problems, but there are a couple of teams that are pretty close behind.
Yeah, I
Minnesota,
guess yeah, we should go through all of the scoreboards.
sure.
Also,
So for North America, yeah, we've got one team with 7 problems, 2 teams with 6 problems. So it seems fairly close. We have a lot of wrong answers on. So it looks like there are 7 easy problems, and then there are a lot of wrong answers on the others.
Mm-hmm. Yeah, every problem has been attempted. North Central, every problem has been attempted,
Mm-hmm.
and many of them multiple times, but 4 problems still without a solve. So why is... Hmm.
So yeah, people are having a lot of trouble with the remaining 4 problems. So I don't think we've discussed F, but aside from F, looks like the other problems all have issues. And what about Mid Central? We are almost 2 hours into these contests. Or sorry, is that right?
Okay, yeah, it should be fixed.
So I see in both North Central and Mid Central, teams seem to be struggling with the rest of these problems.
Um, yeah, do we want to look at any... I have something interesting to say about one of the problems.
Oh yeah. Okay, which
So
one?
problem F on Mid Central, it's called Cascade Centrality.
We're getting told to check audio. Is our audio good?
Uh, is I don't know how to check this.
Me neither. I'm gonna. Oh, okay. Apparently, it's good now. Okay. Sorry, you were saying F on North Central?
Yes. Oh, on Mid Central.
Mid Central. Okay. So that has not been solved.
Yeah. Okay. Yeah. We can. Yeah. We might. It might take a while to solve. Um, but one thing I'd like to say is, or
Yeah.
I don't know if you want to bring it up or not.
Sure. We'll bring it up. It's this problem has not been solved. One person has attempted it and got it wrong. Um, it's called Cascade Centrality, and I'll just grab it. And I see there's a note on it as well, which I didn't actually capture the note, but it might be important. Okay. All right, so we are given an undirected graph with vertices and edges, and the cascade centrality of a node is defined as, okay, what is this?
or like we, yeah. Sorry for the issues, but we've had no audio for a little bit.
Okay.
Yeah, we were
Hopefully
discussing this problem.
hopefully
It
that
was
hasn't applied for the other problems we discussed.
yeah,
Hopefully
no,
there
no,
was
it was
audio.
because I had to change something, and then because I switched scenes. I don't know. It doesn't matter.
Okay, so
But
we need to restart this problem. Is that right?
yes.
Okay. Yeah. So to restart the problem, you are for a given node I in a graph, you have to basically sum this equation that we got here over all possible simple paths from I, and there are a lot of possible simple paths from I. You have up to 100 nodes and up to 150 edges, and what was discussed before is that last year there was a problem also called this apparently.
Yeah, there's a problem also. Oh wait, this is okay. I should probably put it on. Oh wait, let me fix this. I should probably full screen the problem.
Okay.
Uh, okay. Yeah, and
Sounds
yeah,
good.
there's a problem. There's a problem with the same name last year with the same formula, and it was the only difference is that the graph was guaranteed to be a tree. And then
Right.
if the graph is guaranteed to be a tree, then like between any two nodes, there's only one simple path. So you can just find that simple path and compute the number. But yeah,
Yeah, and in fact, even with a given starting node, there's like a linear number of paths.
yeah,
There's almost n paths. So yeah, yeah. But obviously, like here, so our speculation, or my speculation at least, is that there are like on the order of n factorial possible paths.
hmm
Maybe you can divide that by 1,000 or something, but I think there are a huge number of possible paths. There is no hope of iterating over all possible simple paths.
yeah, like or like as I said, like yeah, complete graph on like I don't know, 15 vertices usually fits within the limits.
Yeah,
The edge limit is the critical number here, but yeah, easily fits. And
that
15
would just be
factorial,
15 factorial. Yeah.
way too big, way too big.
Yeah. And so the question is, can you ignore some paths? Can you say that a path has gotten like this value is a quotient, right? So can you
Mm-hmm.
say this path has gotten long enough, this product here has gotten large enough that we don't need to continue. It's not going to be a huge factor in the resulting sum. And of course, the counterbalancing thing is that there could be a whole lot of those paths that have small values that all sum to a value that is not trivial.
Yeah, and I think so one thing you consider again on the complete graph case,
Yep.
let's say paths of length 14. Uh so paths of length 14, 14 edges.
Yep.
Maybe just go the full paths of 15 vertices. There's like n factorial of them, and the total each of them. So in a complete graph, every vertex will have degree n minus one. So the value of each path, the product of degrees, will be n minus one to the n. So 14 to so if n is 15, that'll be 14 to the 15. Uh, and then I don't know. We can do like some quick computation to see like
You know, I think maybe the key is that this value grows in direct proportion to how many paths there are. So
um,
if you've already got a small value, you can sort of stop there because even if there are a whole bunch of paths branching out, that also means that this value is going to be divided by just as much, right?
and yeah,
Does
I
that make
think yeah.
sense?
Oh yeah, that's like so the issue is like so it's like of all paths. Okay, yeah, I think this is so if all paths of length 15, right?
Yeah.
The total number of paths of length 15 will be um like if you're not considering simple paths, the total number of paths like the sum of the value for all paths of length 15 will just be 1. Like if you just uh or it's like I think it's like 1 divided by like the last node in the path. Do you see what I'm saying?
No.
So it's like um so it's like you start from degree I. So you start from vertex I, then
Yep.
you like spread out with degree like you send 1 over degree I to all of your neighbors.
Yeah.
And then each of your neighbors sends 1 over degree j to all of their neighbors. Like, so it's like there's some weight of the current path to that vertex. And then you send 1 over degree j to all your neighbors.
Yeah, I think I see what you're saying.
So this is in the case where there's just all paths, not necessarily simple paths.
So if we had say just a star,
Mm-hmm.
this would end up being, well, the problem is it includes the end node and excludes the start node. So actually we have to ignore I. So we have to pretend that I doesn't exist for this. But this would just be 1 plus 1 plus 1 plus 1. So this would be 4.
Mm-hmm.
Or actually it'd be 5 because there's a, I'm not sure why there's a 1 here. But anyway, so, but yeah, like I sort of see what you mean. Like beyond I, once we have moved beyond I, then all of these are contributing sort of the same amount. Like, does this just end up being a sum of 1 here?
So, but the issue is like there's the non-simple paths. So the paths go back to I.
Yeah.
So like, yeah, like the sum of all the paths will be 1 of a given length, but a lot of the paths will be invalid because they're not simple.
But I'm just trying to consider the case, like say a tree where all the paths are simple. So what you're,
But even that, like, so it's like, it's because you're doing 1/2, right? But it's actually 1/3 because the degree of that node is 3.
right.
So like even on a tree, there's the path like you go along a vertex and then you go back along the same vertex, same edge. You go along an edge, you go back along the same edge, and so there's still non-simple paths on the tree.
Am I getting the numbers wrong, or is the answer just like is each of these always contributing 1 no matter what?
So it's like if you include the non-simple paths, then they're each contributing 1.
Well, there are no non-simple paths.
No, there's the
This
path
is a
from
tree.
I. There's the path from I to j to I plus 1.
I've just drawn a tree here. This is just a
Oh
tree.
yes.
So there are no non-simple paths. What I'm asking is the answer always just degree I plus 1, no matter what the tree looks like?
No.
Okay.
Like just like what am I trying to say? Like oh wait, let me
Okay.
think about this.
It doesn't matter. So
Yeah.
I just had a hypothesis and it's wrong. Okay. Anyway, regardless, I think my point is that you can start with small partial paths, right? You can start counting up. You can recursively like start.
Wait no, you might be right. Let me think of like
You
just
can start counting up partial paths, and then the point is that this is not going to grow significant. It can't grow.
mhm.
Even when summed, once you've gotten to this point, you go from I and then to K, right? And then you consider all possible J's off of this K. Even summed, I think the sum of all of these is not going to be too much larger than the current product, the current quotient. That's my claim. Because
um
because as it branches out, it gets divided by just as much as it's branching out.
uh and and like if you just are you talking about the tree? Like I think in the complete graph case, this
Mhm.
the fact that there's so many paths means it's like kind of I don't know. It seems hard to think about.
Yeah, the complete. You're right because the problem is that this quotient is not going to be particularly small. It's going to stay roughly the same. It's going to stay 1, or sorry, not 1. No, yeah, it's going to get small. Yeah, I think this is fine. Like you just recursively iterate partial paths. Sorry, you recursively iterate the partial paths, right? And then stop when your quotient is too small.
Um
and so my claim is that this works, but
Oh, like so what do you
I
mean by
could be
too
wrong.
like it's always very hard to think about these things because like
Yeah,
so like what does too small mean?
I mean, you pick an epsilon. You pick say epsilon.
Oh, like
I don't.
I like the point I'm trying to make is like it's very hard. Like I'm not sure an epsilon exists where like you're always gonna terminate very quickly, and but you're not gonna throw out too much stuff.
But okay, if there are too many paths, if you're considering too many paths, then epsilon is shrinking the more the paths that you consider. Like
Mm-hmm.
I'm not sure that my claim is that actually most epsilons will work, but I don't know. I could be wrong.
Yeah, it's like it seems like a problem where you'd have to like try a bunch of stuff to like
I
just
mean,
check
yeah, that
if
is
epsilon works.
sometimes you just have to like grab a keyboard and try a few things, and then
Mm-hmm.
which is a problem when the keyboard is shared, of course. But
And it's also a problem when we're just talking about the problems as opposed to actually like implementing them.
yes, yes.
So, yeah.
So actually, I have another question. If this doesn't work, how in the world could you solve this problem?
Okay, that is a good point.
This is like the only approach I could see that even seems reasonable.
Um.
Because like dynamic programming isn't going to work because your state
Mm-hmm.
requires all previous nodes, right? Um, I mean, I could be missing something. Maybe there's a way of turning it into like a linear programming problem or something like that. But
And yeah, like I don't know, every idea, like yeah, it seems like yeah, there's just like too much state for you to do anything else other than just like try stuff. And like I guess like one thing you could try to do is like there are some states that can be combined. Like if you're going
yeah,
1, 2, 3, if you go like 1, 2, 3, 4, is your vertex path. It's like you're in the same state as if you went 1, 3, 2, 4. But
yeah.
yeah, even then it's just
Like I agree. There
yeah.
could be some magic in this exact formula which somehow makes something work, something clever work. My claim is that the magic is just that it shrinks at the same time as it branches out. That's
Mm-hmm.
my claim that the magic is there. But there could be some math reason why this turns into something fancier.
Yeah.
Anyway,
Yeah, it
all right.
seems. Yeah, I think I think some epsilon would work, but yeah, you have to be pretty careful.
Okay, that was a fun little rabbit hole.
Yeah.
Let's go back to the scoreboards.
Oops, that's the wrong. Okay, yeah, we can go to. So what are we currently? So yeah, we're at the
It's hard to solve these problems live on stream.
yeah. So we're at mid central. Uh,
Okay.
8 solves, and a bunch of teams on 7. Then I guess we should look at North Central and Rocky.
Sure. So Rocky Mountain has passed 3 hours.
Okay, yeah. So for North Central, so UW Madison on 8 solves, Minnesota on 7, and then various teams on 6. Another UW Madison B Tree, UW Madison Minnesota. Okay, seems like those two teams have collaborated to troll some people who are reading out the results. And then Drake U also on 6 solves.
Okay,
And then
so if there are three spots, then if there are three spots, but there might be more, then it seems like a still somewhat competitive for
yeah,
the third
so
spot.
like UW Madison and then oh sorry, Drake. So yeah, UW Madison, Minnesota, uh, get the top 2 spots, and then Drake U, the only team remaining university on 6 solves, but a bunch of other universities on 5 solves.
Yep. Okay. Now Rocky Mountain.
So yeah, Rocky Mountain. So over 3 hours into the contest,
Yep.
U Alberta, 1 problem away. Just need to solve problem K.
So they
And
might solve everything before the freeze.
yeah, and yeah, I think some other regionals would freeze the. I know there's like some contests which have a rule that like if a team solves all but 1 problems, they'll freeze the contest just
Ah,
then. But I don't think that's something that's happening right now.
Yeah, I mean, we can still see the queue.
Yeah, it seems, yeah, we can still see everything right now. So it seems
Yeah,
that they're not doing any early freezes.
yeah.
Uh, Arizona State second wind at 11 problems, well ahead of third place. Uh, so yeah, one team on 12, one team on 9, one team on 11, and then a few teams on 9.
So first and third are both U of Alberta. So right now, U of Calgary has that third spot.
Okay.
Go Calgary. But it's yeah, I think for like the third spots on these contests, it's still there's still wide open.
Mm-hmm.
Cool.
Yeah. So do you think we should look at K from this contest from Rocky Mountain? See what University of Alberta is trying to
Okay.
finish.
So this is going to be a tough one.
Yeah. Two wrong
So,
submits from Arizona State are the only submissions.
but they
Or
did get
sorry,
it.
two wrong submissions and a correct submission.
So it is solvable. Always good to know. All right. So this is called team practice. Um, have to cut it off slightly, but that's okay. All right, sharing. Make sure we get audio. Okay, so we have a problem. So this is problem K, team practice. Just write down K for Rocky Mountain. So professor wants all of his students to get experience practicing together so they can share knowledge and avoid the situation where the whole team graduates at once and leaves no one for next year. In other words, he wants some continuity between ICPC teams from one year to the next. To facilitate this practice, he has booked a bifurcated room where students can practice in two separate teams, Team A and Team B. This allows them to monitor both of them, and he can direct the students to switch teams so they can get experience working with different people. The practice will be held in hour-long sessions, and between sessions, he can direct a small number of students to switch teams. However, he wants everyone to be together in Team A for both. Okay, so all the students start in Team A at both the beginning and they end up there at the end. Okay, each student can be classified as either a problem solver or a problem coder, but not both. All right. To minimize foot traffic, at most one student of each type will switch teams during a break between sessions. So basically up to two students could ever switch. Um, there are a small number of challenge problems that he plans to present to specific teams at various points. Since the problems have various difficulties, he's predetermined the number of problem solvers and problem coders that are needed to solve the problem during a session. So, okay. Wow. Okay. So there are various minimums in order to solve the problem. There's the minimum number of problem solvers, there's the minimum number of problem coders, and then there's just the minimum number of students required to solve a problem. And he wants to structure the teams so that all the challenge problems are solved. And even the same session can have multiple challenge problems. Like so, in other words, even at the same moment, you could be given multiple challenge problems at the same time. For example, a team with 6 solvers and 5 coders could solve some sample input problems. And then the question is how many ways you can do this. So it's not just figure out a way that it can be done. It's how many ways can you do this to meet the constraints. So it is a combinatorial problem. You have to output an answer modulo 1,000,007. Um,
Yeah.
and
So
what are the numbers? The numbers are up to 10 to the 18 sessions, but only 5 challenge problems.
mm-hmm. And then
And then
35.
35 coders.
Yeah.
Oh, sorry, up to 70 students. So
Yeah,
35
but
problem
35
solvers.
of each type. And I think one thing you can notice is like
Okay.
the the problem solvers and the problem coders are just independent because they move independently, and then for each problem you need both.
Not quite. because
Why not?
there's also a minimum number of students required.
Uh,
They're
oh,
almost independent, but not entirely.
okay, it's not independent. I see.
Yeah. I agree. If it weren't for that third constraint,
Yeah, I didn't see that third constraint, but
you
yeah,
could solve them independently.
but it is not independent.
Yeah.
But yeah, like I'd say like so it's like there's 36 possible states for each for the problem solvers, and there's 36 possible states for the problem coders.
Yep.
Like the number of students in each uh contest room,
Yep.
and so the total number of states that's around 1,000 if you multiply those two numbers, 36 times 36.
Because the key thing that you're observing is that there's no distinction between a particular problem
Yeah,
solver or problem coder. So you pretend that they are a giant mass, and then if you move one student from one to the other, then there are just like if there are 30 problem coders, there are just 30 ways of moving one
mm-hmm.
from the first room to the second, and you don't need to worry about it beyond that.
Yeah, you don't need to worry about which specific problem coder is in each room. You just need to know how many are in each room, and then like yeah, like when transferring, there's like multiple options, but all the options are have the same effect.
So if n were small, then you could just store all of those thousand possibilities. You could
Mm-hmm.
store the number of ways of reaching all of those thousand possibilities, and then you can just update it for every session, right?
Yeah, yeah. So if n was uh, if n
And
like
then I think what's going on here is that the transition that you are doing is a matrix on the
um
it's a transformation from a thousand possibilities to another thousand possibilities, and
mm-hmm.
what you're doing is you're multiplying it by a matrix.
Yeah, and that's one way to look at it. And yeah, so it's like basically we have these I'd say like seven critical times, the beginning, the end, where
Yep.
we know the state, and then the four problems where like only some valid like we need a certain amount of people of each type to be in the room at that specific time. So basically that means like you just have some of the states are valid, some of the states are invalid. Uh, so it's
Yeah.
like at the beginning you know the state, then like if we had this 1,000 by 1,000 matrix, 1,000 by 1,000 matrix, we can take a power of that matrix in order um, to figure out all of the number of valid, the number of valids, the number of ways for each of the states to be reached at the time of the first problem, and then at that time we just for every state that's valid we like keep those because they're fine. For every state that's invalid we set them to 0 because we know that that situation couldn't have actually happened during the practice session, and then we can take a power of the matrix um, to transition to the next set of states and so on.
Yep.
However, so taking the power of a matrix, if a matrix is 1,000 by 1,000,
Yep.
this will be too slow because
It will. It's not obvious that it's too slow.
I mean, so why is it? I mean, like it's 1,000 by 1,000 matrix. To
Yep.
multiply two matrices, it takes n cubed time.
Yep.
Uh, so yeah, that's like 10 to the 9 operations.
Yep.
That if you're lucky, that can fit within a second. Uh, and
And you're also multiplying by the log n for the exponent.
yeah, and then but yeah, to like calculate up an exponent of a matrix, and the exponent is up to 10 to the 18. You need to do like 60 multiplications, and so yeah, 60 times 10 to the 9. The time limit's only 6 seconds. So yeah, that will not be fast enough.
It's not obvious to me that this isn't fast enough.
Uh, why not? So how? I would like if you do it naively, I'd say it takes 60 times 10 to the 9 operations. Uh, are you?
But I mean, they're okay. I guess they're not really vectorized operations because you're taking
Yeah,
products
you have to
modulo.
take a mod 10 to the 9, which would be
I guess the mod is the problem because mods can be kind of slow.
yeah, and like yeah, you have to
Okay, so just exponentiating M is too slow. Um,
Yeah, exponentiating M once would be probably too slow.
so what else could we do? I mean, certainly the solution that we're outlining is within an order of magnitude of passing.
Mm-hmm.
Um,
But the thing is, we also have to do this like so it's like it's we have to do this exponentiation 5 times. So it's like I don't know. I'd say it's like at least like an order and a half away from passing. Okay, one thing I can think of is
okay.
so it's like so like once okay so after we've done the first after we solved the first problem, there's like at most 1,000 valid states. Now now like so like now that we have 1,000 valid states for each of these states, like we're starting with some number of problem solvers and some number of problem coders, and then as we transition to the next problem to solve, those number of solvers and number of coders are two independent values.
Right. So actually you can treat it as a matrix of size 36 by 36.
Yes.
Right, because the only time that they are not independent is when you are doing the actual check on a challenge problem.
Yes. And like like when I said like there's 1,000 states you could start from, but even then like uh you only for each like state you only need to compute the exponent uh for like this for the specific starting number of problem solvers and the ending number of problem solvers. We can compute the transition like we can do the matrix exponentiation to get like this 36 by 36 table of how many ways can we go from X problem solvers at the beginning to X problem solvers to Y problem solvers at the end. And then once we've done this matrix exponentiation once, then we can like compute, okay, how many ways do they get from state X to state Y?
Okay. All right, so that's the trick, I guess. That would
Yeah.
solve it. So yeah, so you have to notice that it's almost an independent problem.
Mm-hmm. And yeah, the only times it's not independent are these 7 critical times, the beginning, the
Yeah.
end, and the 5 problems.
And
And
it's
then if
fine,
we,
it's fine at that point to just consider all the 1,000 states. That's fine.
yeah. And then at those points, we consider the 1,000 states. We consider, like, once we've done this matrix exponentiation, we can compute the number of ways to transition to each of the 1,000 states at the next point in time.
Yep.
And then, like, so, like, once we've pre-computed these matrix exponentiations, each of these transitions is O of 1.
Yep.
Um, and yeah.
Okay. Interesting. So like I feel like the first step of matrix exponentiation is something that experienced competitors would get pretty quickly.
Mm-hmm.
But the maybe the noticing that the independence is a trickier step that they might not see right away.
Yeah. And yeah, just like, I mean, it's like the fact that, like, because, like, I don't know, I noticed the independence pretty quickly, but then, like, the fact that it's not independent makes it
Yes.
harder, but then you have to notice, like, okay, it's almost independent, which means
Yeah.
you can do certain things using the independent uh, quickly, and then, like, only only when you like combine the states at the critical times does the non-independence matter, and then everything works out.
So it's a clever problem. I like it.
Mm-hmm. Yeah, and we'll see if oh, okay, I guess we won't see because they already have.
Ah, yes. Okay. So
University of Alberta
they
has
have
full
all killed the
self-defense
contest.
with
Um,
over 90 minutes left.
and there is no way for any other team to catch up to them, so they are the winners. U of
I don't know.
Alberta.
Let's. Are you looking directly at the penalties?
I'm looking at the penalties.
Okay, yeah,
There's no way for anybody else to catch them. So
yeah.
they won. University of Alberta.
Congratulations to University of Alberta.
Yep.
Uh,
Good job.
Arizona State are in good position to take position 2, and even if they don't, the team that would likely pass them is the second University of Alberta team, who will not stop them from qualifying for the North America Championship.
Exciting.
Yep. I
It seems
guess.
like a good contest. Maybe slightly too easy, although there is a question of like, do you want to scale the contest to the top team or do you want to scale the contest to the average team?
Hmm.
Right.
And yeah, I think, um, and the issue is the like because the contest is easy, like you're like still like you're still distinguishing like Alberta Azure from Alberta Green, and like
Sure.
in this contest it turns out fine because yeah they won by over three problems, but um like if it was slightly closer it'd be kind of sad for the contest to be decided with like well over an hour left.
Yeah.
Uh, I don't know. We can, yeah. I guess we can look at the scoreboards for a couple other for the other two regionals.
Sure.
Uh, so yeah, currently, U Chicago Puck 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 8 solves, uh, beating University of Illinois limit testing by penalty, and then those two teams with 8 solves are ahead of uh, 4 teams on 7 solves. 3 of them from University of Illinois and one from Vanderbilt. And then for North Central, we're still
Pretty close contest. Mid Central seems like a
yeah. Mid Central seems pretty close, especially the four. Yeah, they're
the four Urbana Champagne
yeah,
teams.
and it's like pretty well known. So like on our team tryouts, so me and one of my ICPC teammates from last year, who's also no longer eligible, we wrote the um or we didn't write the we chose problems for the team tryout. Um, and yeah, like so there's 2 teams which are tied on problems, and then below that there was one team who only had 2 people for the individual tryout, who was 1 problem behind. So yeah, it's like all 3 other teams were like very likely to do well, and it was unclear before the contest, and it's still pretty unclear which team will come out on top. And then yeah,
Okay.
so North
So
Central,
North Central.
I think, but last time we checked, Wisconsin Madison had 8 solves, and they still have 8 solves. Uh,
Minnesota also has eight
Minnesota
solves.
Madison has also has is tied on 8 solves. Uh, Minnesota from UW Madison is on 7 solves, and then many teams on 6 solves.
So this is a little sharper a distribution.
Mm-hmm.
Top two teams are pretty well ahead.
Yeah, top 2 teams, like top 3 teams, like yeah, top 2 teams have a 2 problem gap to
Yeah.
all but the top 3.
Yeah.
Uh,
And I see people have finally managed to solve some of these problems that they were struggling with.
I don't remember exactly which problems it was, but I think it's yeah, K and H probably.
H has now been solved.
It's very interesting. Yeah, C and J have a bunch of wrong submissions from
Yeah.
teams all down from the top to the bottom.
H and K also had a bunch of wrong submissions, but now teams have actually solved them. So
Yeah, every team that's attempted them, at least within the top, whatever the top 30 or so that I can see on the scoreboard,
yeah.
has ended up solving them. Are there any there's so many problems we could check out.
There are too many problems to
Yeah,
cover. Yeah. I mean, it's fun to cover the hard ones because we can sort of like
yeah, we can
brainstorm a
think through
solution.
them. Do you want to try H or K from this North Central?
Sure. So H has three solutions, although the top two teams have not solved it. So
Mm-hmm.
let's take a look at H.
K also just got a third solved right as we were talking, but yeah, I think
Oh, okay.
let's go to H.
Okay. So
Palindromic paths.
and is this on mid central? This is this is not on mid central. So this is North American or sorry, North Central only. Palindromic paths. Okay, sharing. Right. In this problem, you're presented with a rectangular grid containing a number of palindromic sentences, 1 character per cell. So they're laid out in like two.
Okay, okay? I think the audio should be working now.
Okay.
Uh,
um,
so okay, yeah, there's
Starting
this.
again. So we're
Yeah,
given a rectangular grid of characters, including space, which is a bit evil because normally in ICPC problems, white space is not relevant. But in this case, you do need to manage white space. And you're basically just given a list of strings. It's kind of irrelevant that they're palindromes. You're given a list of strings, and you just need to determine whether you can walk through this grid and find that string. And the worst part is you can't repeat a character. So it has to be a simple path that does not intersect itself. If it weren't a simple path, then this would be doable, right? This would just be like a
yeah,
dynamic.
it would just be a dynamic programming problem
But the
of
fact that you're not allowed to repeat a character makes this actually a complex pathing problem in the worst case. Now, our theory is that these worst cases don't show up in the input, which is not great.
because like not because like oh these like inputs are like cannot actually exist, but just because they do not generate these inputs.
Right. So like for instance, this is an example of say a case that might be more difficult, right? And you just want to search for a bunch of A's, right? And then maybe you have to find this path or something like this, right?
Mm-hmm.
You have lots of choices. and then you can make this more complicated. You can make it a larger grid, and you can have like dead ends and stuff. So this is, I mean, it feels like this can almost be reduced from traveling salesman or
Or
something.
like I think Hamiltonian path is the
Hamiltonian, yeah, yeah. This could you could almost turn a Hamiltonian path into this almost. I mean, it is planar, but
a planar Hamiltonian path is still NP hard.
right. Yeah, I would not be surprised if this problem is NP hard.
Which yeah, I don't know. It seems like that type of problem should not be on a regional
Yeah,
set where
yeah.
you just code something and hope it's fast. Uh,
But my guess is that they give you a bunch of grids that are full of different characters, and so just normal recursion
yeah, and also
can
like
work.
the palindromes, and at least in the sample, it seemed to be like normal words as opposed to a,
Yes,
which also makes it hard for there to be a pathologic case, which takes a while.
yes. So yeah, that's my verdict on this problem is that it is actually unsolvable, but the data is trivial.
Test data, like usually, yeah, like in a regional, in a ICPC like competitive coding contest, you want like the strongest test data possible to actually exist,
Yes,
and but like
as much as possible.
sometimes on these regional contests, they just set problems where you just like I don't know, guess that no strong test data exists, and
Yeah.
I don't know,
There are other programming contests which are a little more like that style. Like for instance, Advent of Code, right?
mm-hmm.
Often they'll ask something that is technically unsolvable, but they give you the data.
Yeah,
And
and because you can see the data, you know, okay, my code will be fast. Like
yes,
as opposed to just like hoping, just like I don't know, just like guessing that the problem setter is like. There's some problems where you can like prove that like okay, given the constraints, my code will run fast because certain bad things that could happen with arbitrary data, they've given guarantees that such that that will not happen.
right.
But then, um,
But yeah, I agree. In a proper ICPC contest, the judge data should test the worst cases that the worst cases that exist in the problem, as much as possible. So okay, that's unfortunate. Do you want to look at K?
sure, yeah, we can look at K.
Hopefully K is better.
Yeah, it's more interesting as opposed to
Okay, so K is zipline course, and this one is also not in mid central. So this is North American, or sorry, North Central only. Problem K zipline course. And this one, I opened this earlier and it looks like geometry. All right. Geometry is always scary. I think you can generally divide teams, or you can generally divide competitors into people who can do geometry and can't do geometry. All right, a park is being planned. Hopefully, is the audio good? Are we good on audio? Oh, I can't hear you.
oh yeah, the audio should be correct this time.
Okay, now
I
I
can
can.
see the green bars.
Okay, good.
Yeah, the issue is like on like I don't know. It's not relevant what the issue is.
It's an OBS issue, right? OBS can be confusing sometimes.
or it's oh yeah, it's mostly an OBS issue.
Yeah. Okay. A park is being planned for zipline enthusiasts. Coordinates have been suggested for places such as cliffs, trees, towers, and buildings where you can attach zip lines. But you do not want to have any pair of lines come within 6 feet vertically of each other because of the danger of collisions. Multiple zip lines may be tied to the same support, and as long as they head off in different directions, or are attached at least 6 feet apart vertically. So there can be actual intersections between these zip lines, but only at the supports. Your task is to identify the crossing points where the lines would be too close. Okay, so basically you've just got a bunch of line segments in a plane. Sorry, not in a plane. You've got a bunch of line segments that have heights as well. So they're 3D line segments. And you want to determine the points in the vertical projection at which they have the same XY coordinate, but they're too close together. Um, and you have, why do you have 26 supports but only 20 lines? Oh,
Well,
because
this
like,
can be 2 sports per line,
yeah,
right?
yeah, okay, right, right. Yeah, so you have up to 20 lines. So you don't need to worry about efficiency in this problem at all.
I'm not so sure.
Oh, really?
I feel okay. Let's think about. Let's read through the entire problem. Or like I'm concerned you might need to do some exponential stuff
Why?
because you have to determine the maximum number of zip lines that can be placed.
Oh, I missed that. Sorry, you're right. I thought you were just identifying crossing points, but no, you have to determine the maximum number of proposed zip lines. Okay, but that's still just
Yeah, like okay.
you determine which lines are incompatible, and then you can just try 2 to the 20,
Okay,
right?
yeah. Okay, I was concerned about. Wait, how does this work?
So for line I, J, determine compatibility, right? And then run over 2 to the 20 possible line configurations. So that's my proposal for the solution. And then of course there's geometry involved in determining compatibility.
So, yeah, you do the geometry to determine the compatibility. Um, and the geometry seems quite. Okay, actually, it doesn't seem that bad. You just find the intersection,
Yep.
find the distance. But the issue is the intersection might not be an integer point.
Um, do they have any guarantees in here that hmm,
Oh yeah, there is a
that,
guarantee. Okay, so if you're just working in floats, it says if the lines cross such that the vertical distance between them is less than 10 to the negative 9, consider the crossing to be safe.
okay, so they give you the epsilon that works. That's fine.
Yes.
I think you could just solve this. I mean, you could solve this with rationals, right? But um,
But it seems
or no, sorry, not rationals, because
I think rational should work
no,
for it.
yeah, it is rationals. Yeah, you could solve this with rationals, but fortunately, you don't have to. You can use floating point because they give you the epsilon.
I mean, okay, the wording is like kind of weird because like what if the two, what if they cross by a distance of like 6
That
minus 10 to the negative 9? Or like
that is
I like
bad.
it is unclear, but like I'm pretty sure it means that like if something between like just like
Yeah,
if
so the
you
problem
work with
is
an
this
epsilon
is
of
this
10 to the
is
negative 9.
formatted to look like a guarantee that you don't have to worry about 10 to the minus 9. But that's not what it actually says.
Yes. So I don't know.
Yes.
Like I would believe that it means that if something's within 10 to the negative 9, then like whatever you do is fine. But uh, I don't like. Hopefully there's like no test data that's like exactly 6 minus 10 to the negative 9.
Yeah, but
Although
yeah, the strict reading of this problem is that you have to use exact arithmetic and you have to determine you have to allow for 6.00000001. That's exactly what it says.
but yeah, I don't know. I trust the judges not to do that, but if they've done that, then that's very misleading wording
I trust the judges to not, yeah,
to not
to
want
to
people to do
to
that.
have. I trust that the judges messed up the wording. Rather than being tricky.
Yeah.
Okay, yeah, I think I agree. Um, so that's what this problem comes down to. So you have to do some geometry. It's not terribly hard geometry, but you have to do some geometry to determine for two line segments, do they come within 6 feet of each other? And then I think it's just run over the 2 to the 20 possibilities, right? That's just
I
I can't I
just
can't I can't hear you.
Once you've determined the edges, it should be fine.
Yeah. So, I mean, aside from that quibbling with the problem statement, this doesn't seem very hard.
I mean, I don't know. You have to like type out your geometry template, make sure that you compute the intersections correctly. But yeah, like it's
You
like
have to make sure you have to handle the special cases of like the intersection is not on one of the line segments or something like that. And
mm-hmm.
yep, yeah,
Yeah, like yeah, but like line segment intersection. If you have that in your book code, it should be fine. Otherwise, you have
yeah.
to code it up yourself, which is always tricky when you're dealing
Yeah.
with geometry.
Okay.
All right.
Well, so three teams still have solved that one.
That was K. Yeah, 3 teams have solved it, and I don't know. We could look at F, I guess,
From North Central.
from North Central. Sure.
Is this the last one? No, there's also J. So there's F, C, F, and J that we haven't looked at from North Central. And have they solved? So has anybody? Nobody has solved C or J, but a number of teams have solved F. So okay, yeah, I agree. Let's look at F. Jumping spiders.
Yeah, and jumping. This is another problem which is only on North Central.
Okay. So there actually isn't that much overlap between the two. They're like some
Uh,
easy problems,
yeah, I
but
think yeah, mostly it seems to be the easy problems.
yeah. That's interesting because I would actually expect the opposite. I would expect the harder problems to be the overlap.
Yeah, I think I don't know. Yeah, usually you have trouble coming up with the harder problems, and then
Yeah.
uh, you like share those. But
Oh, well.
interesting decision.
All right. Jumping spiders. Jumping spiders are so named because of their propensity to jump at prey. Makes sense? In this problem, you're presented with the prints of what may be a jumping spider. If each print in a trail of prints is within 3 lengths Manhattan distance of 7 additional prints, um, they they could be those of a jumping spider because that would be consistent with the spider with all 8 feet on the ground. This is the main criterion. When walking, not jumping, the spider is able to pick up a foot and reach an additional 3 lengths before putting it down. So we might also have a jumping spider if a print is within 3 lengths of another print that meets the first criteria. This is the alternate criteria. This is very confusing. Okay, there may be gaps of greater than 3 lengths between separate trails of prints that may result if the spider was walking and then jumped. If there are any prints that do not conform to these criteria, there may be something other than a jumping spider in the area and you can remove them from consideration. Uh, so what you're trying to figure out is if all the prints can be accounted for as belonging to a jumping spider, and then compute the minimum number of jumps the spider had to have made. So in the sample figure, we have this orange area that has 8 prints. What do they mean by 4 of them are within distance 3 of the other 7?
Um,
Okay, so 4 of them are sort of central prints in that they can reach the other 7
mm-hmm.
steps of at most 3, of Manhattan distance at most 3. Okay, the other 4 are just 1 length away from at least one of the 4, so they meet the alternate criteria, which is okay. So either you are a central print and you can reach and you can reach the 7 other prints,
Mm-hmm.
or you are 1 step away from a central print that can reach 7 other prints. That's what I'm reading.
Wait, we do know one away. Like, oh, it's like It says three greater. Wait, what does it say?
I think basically for an individual print, what you do is you consider is there a central I'll call it a central print if
Mm-hmm.
it's if it can reach seven other prints within distance three. And then any print that's within three of a central print is considered um, a valid uh, jumping spider print that doesn't involve a jump.
Oh, okay, I see.
And so I think the point is that the orange every print in the orange set in this diagram right here
Mm-hmm.
has this property of being one step away from one of these four central prints.
But
So
it's one step away, but it could be at least up to three steps away.
it could be up to, yeah. So suppose this were actually here. Um, well, actually, that would change which ones were central.
Mm-hmm.
Okay, ignore what I said.
But it seems to be just like for each print, look at the area like within three of it, and that
Yeah,
determines whether it's a central print.
yeah.
Then once you have the central print, determine which other ones could be like could meet the alternative criteria. Um,
But here's okay. Here's my question. You could have the alternate criteria work in different directions for different central prints.
I think this doesn't really matter.
Okay. I need to figure out exactly what it's asking. So
Yeah, yeah.
what exactly is it asking? It's asking,
So it's asking like basically how many connected components of central prints are there, which is like so like if there's like if there's so like in the example there's three connected components of central prints, which means to have done all of them, you must have done two jumps. So like from the first to the second, and then from the second to the third.
got it. You really don't care about that alternative scenario. All you care about is like because you have to have a central print in order for the
Yes.
spider to have stood somewhere. So you just look for a central print. You hmm. And if you have central prints that are like three away from each other, then those count as the same segment,
Um.
I think.
Oh, it's like if they're definitely within. If they're within three of each other, they must be within. They must be in the same central print. But then
And if
like,
they're further than three apart, then I think they have to be part of a jump.
uh, yes. But then like, is it okay for, like, if you have two central prints, but there's like a path between them that you could have walked along?
Oh,
Like, should we consider those the same print or a different print? And I think they should be the same print, if I'm reading this correctly, because you can just like walk from one place to the other.
I'm afraid I'm a little confused by this. I'm not
Yes.
sure.
I I, I don't know. It's like, yeah.
So the question is, you have like a central print,
Mm-hmm.
and then like we'll call it a peripheral print, and then a central print, and these are
Yes.
distance three.
Yeah, and this must be like, yeah, it's definitely like you can just walk from one place to the other place. Like this is what it's saying, right? It's like,
But the thing is, like, you're not really, if you think about what the problem's asking, like it couldn't really walk like that, right? Because it could move one of its feet to there, but it can't get from this position to this position just by making steps. You know what I'm saying? It can't just move one foot at a time to get from one position to the other position.
okay, yeah, I think you're right. But yeah, if each print in a trail of prints is within seven additional, yeah, three lengths of seven additional prints, they could be uh there was a jumping spider.
Uh, yeah, I'm pretty confused by this problem, but I think your initial impression was right. Like I think you're
Hmm.
just look for components of central prints. Um, they're in a component if they're within three of each other.
Yeah. And then, okay, there's also a second number you need to output, which is the number of prints that cannot be made by the jumping spider. So that's like, once you have
Okay.
these central prints,
Yeah.
you
Yeah.
find all the alternate criterias, and then anything which is not in either of those two is an alternate print, or
Like
is a print
basically
in this
anything that's
case.
that's a distance of more than three away from any central print
Hmm.
is it can't be made by the spider.
Yeah.
That's my theory, but I have to admit, like I'm not totally sure.
Yeah, like the wording seems rather unclear on like okay, I think that we have the wording correct because it specifically says we could have a print within three prints of another print that meets the first criteria and not between like yeah, I don't know.
I don't know, but what we have outlined seems like a reasonable problem. So hopefully that's the intended problem.
Yes.
Okay, so I think that covers all of the problems that have had a solution in North Central.
Um is this true?
So we're still missing C and J, but those have not been solved yet.
Oh, let me just look at yeah. Let's just look at all the problems and see if we've covered all of them.
Yep.
Um yeah. Yeah, we've read every problem other than C and J, and then those are the problems it solves.
Let's look at
Mid Central or Rocky?
actually let's check up on both.
Okay.
Rocky's just about at the freeze, so
Oh, okay. Yeah, let's cover that.
let's cover that. Okay, so we're switching to Rocky, and this we're coming up on the freeze in like 1 minute, 2 minutes. I mean, we already know who won.
Yeah, but there's still a lot to be decided.
There's a lot to be
Yeah,
decided.
like the third team, well, the third team might not matter, but it's guaranteed promotion to NAC. Uh, the,
Right.
usually the fourth team will also qualify, but we shall see. Yeah, that third team is pretty hotly contested between Calgary and Colorado Mines, and then a few other teams on seven. So yeah,
Cool.
so yeah, before the freeze, B and K have B has only one solve from Alberta Azure. K is solved by Azure and Second Wind from Arizona State.
Yep. So have we looked at any of these problems? Yeah, we looked at team practice, which was K, which was the matrix problem that had an
Mm-hmm.
interesting twist.
Yeah, seems the
Mhm.
next easiest problem we have yet to look at is what time is it, Mr. Fox? Has four
Okay.
solves ahead of a bunch of all the other hard problems, even though it was the last problem to be solved in the contest.
Uh-huh.
But it is
So
since being solved by more teams than buying jerseys B, D, and F, despite those three problems being solved before M.
okay. And we are at the freeze, so
That's all we shall see until the end of the contest.
yep, no more scoreboard updates, but of course, we will see what
Submissions.
what people submit. Yeah. We just won't see whether they get it right. Although you can often tell if they've gotten it right because they'll stop submitting.
I mean, I don't
So,
know. So
or
yeah,
they,
and you can also just work in a different problem, or there's many things that can happen. Yeah, because the teams themselves, they see whether they got the problem right.
yes,
Just on the scoreboard, the other teams will not see it, and also we watching will not see it.
yep. And then they do the resolver thing for these contests, right?
Mm-hmm.
There will be a resolver presentation after the contest where they run through all of the submissions in the last hour and they figure out how it affects the scoreboard.
Mm-hmm. So should we look at? Do we want to look at Rocky Mountain M, or should we look at something else?
Sure. Yeah, let's do something else on Rocky Mountain since it's now hit the freeze.
Mm-hmm.
You said M.
So M is the of the problems we have not gone over. It's the one with the most solves.
Okay. So this is called What Time Is It, Mr. Fox? It's a long problem, so I think I'm just gonna
Mm-hmm.
share the browser window. Okay. Make sure we have audio.
Yeah.
Okay, good. The game What Time Is It, Mr. Fox is a popular children's game. One child is the fox, the rest are the sheep. The game is played on a field that is much longer than it's wide, so we assume it's played on a line that is L micrometers long. Goes from position 0 on the left side to position L on the right side. The sheep are initially located at position 0, and the fox is initially at L over 2. The sheep call out, What time is it, Mr. Fox? The fox announces the hour, which is either X o'clock, where X is from 1 to 11, or lunchtime. If the fox says X o'clock, then all sheep take X steps to the right. If the fox announces lunchtime, the sheep run to the side of the field they're closest to. If they're exactly halfway across the field, they run to the right side. That's to position L. So the fox chooses at most one of the sheep to chase. If they catch the sheep before the sheep reaches the side it's running to, the sheep is out for the rest of the game. And then anybody else is safe. Oh, anybody who makes it to the right side of the field is safe for the rest of the game and no longer plays. So you've won if you reach position L. And then, but you might have run back to the start, position 0, in which case you are still in the game. So you can be removed from the game if you're either eaten by the fox or you make it to the right side at L. Okay, and then all the positions reset. So the fox returns to the center of the field and the game resumes. So each sheep has a different step size SIX. So, okay, each sheep I has 11 possible different step sizes. So when the fox says, say it's 1 o'clock, then each sheep I moves a particular number of micrometers towards the right side of the field, which is different for each sheep. These step distances might not be increasing, so they could be any numbers. And the sheep run at the same speed, and the fox runs at exactly twice the speed of the sheep. And what are the ties? So I guess if the sheep makes it to 0 or L at exactly the same time that the fox catches them, I think they're safe,
Yeah,
according to
it gives the exact condition if L is
yeah,
less than 40. So yeah.
yeah. Okay. Um, every lunchtime, the fox has a deterministic way of picking the sheep to chase. So if the fox knows which sheep it can catch, if it can catch a sheep that's running to the right side, the fox chooses the one with the smallest index. Otherwise, it'll choose a sheep running to the left side with the smallest index. Otherwise, it doesn't even bother, but that doesn't matter because, like, I mean, it could choose to chase the sheep and then just not catch it. Like, that doesn't matter. Um, all right, so you're given the sequence of calls made by the fox. Is this just simulation?
No, it's the numbers are quite large.
Um, so there are up to 200,000 calls.
And there's 200,000 sheep.
Okay, yeah, so you cannot simulate every sheep for every call.
Mm-hmm.
Interesting.
Oh, but there are at most 20 lunchtime calls. So it is just simulation, but you just have to do
So
it
yeah,
slowly.
so okay, so for every sheep, you just count the number of exoclocks there were for each X,
And
and
yeah,
that
until the first. So yeah, keep track of all the calls until the first lunchtime.
yeah,
Keep track of how many of each type there were,
yeah.
and then for each sheep, you can compute how fast how far they've gone.
So that tells you exactly where each sheep is at the time that lunchtime is called,
Mhm.
and then you can just since there are only a few times that lunchtime is called, you can just do a linear search for which sheep the fox will chase,
Yes.
and which sheep are out of the game because they reached the right side.
Hmm.
Okay,
Yeah.
so it's mostly simulation.
Yeah. There's like one step of like you can chunk all the all the calls into like before the first lunchtime and then like between the second two lunchtimes,
Yeah.
um, and so on. And then once you've done that, you just simulate.
And other than that, the main thing about the problem is that it's a long problem statement with a lot of rules. So
Yeah,
you have to get it
just like
right.
you really have to read the entire problem statement and then like yeah, I assume it makes sense for like yeah, it took a while for anyone to solve it, but then once they solved it, yeah, once once it's solved, like a bunch of other teams seem to be getting it rather quickly.
Makes sense. You're also guaranteed that L is an even number. Does that even matter?
L isn't even number. I mean it.
With the condition they give you, like it doesn't even
Yeah,
matter,
if you're
right?
tracking like yeah, if you're trying to like if you're trying to just do uh
I mean, okay, fine. That
yeah
puts the fox on an integral location.
yeah, and like it doesn't matter. Like if you just use the condition L less than 4D, it doesn't matter if it's in it or not. But if you're actually comparing distances, then it could matter.
Okay, yeah,
But you should probably just use the condition it tells you because there's no edge cases in that.
yeah, yeah. It seems like, yeah, it seems like they've covered a lot of the edge cases.
Mm-hmm. Although there do seem to be a few wrong submissions.
Okay,
For example, the first team to solve, I think that's is that -1 or -4. I think it's just a -1. Okay. But yeah, seems like not seems like a problem that hopefully if enough teams read it, they'll be able to solve.
yep. All right. Yeah, looks reasonable. I think this is the sort of problem that takes a fair amount of keyboard time. So
Yeah, that's also an issue.
you do it while other people are thinking about other problems.
Mm-hmm.
All right. Uh, so is there anything else left in Rocky Mountain?
Uh,
There is. Did we cover energy usage and buying
yeah,
jerseys?
I do not think we covered either of those, as well as
So those are
uh,
the ones that only the top teams solve, right?
so uh, buying jerseys only the top team solved.
Yeah.
Then corporate retreat and energy usage was solved by each of the top three teams before the freeze.
Oh, we didn't do corporate retreat either, right?
Yes.
So these are all problems for the top teams.
Mm-hmm.
Okay. Um, any other comments about the frozen scoreboard?
Um, yeah, like both of the teams, yeah, the teams fighting for third place, uh, third place university. So Calgary Diplodocus and Mine Sapphire both have a submit. One on F, one on M. I guess we can look at F if we want to see what Calgary is submitting to.
Yeah, and they only submitted once, so
I think it was not that long ago, so maybe
okay.
could be right, could be wrong.
Can't tell yet.
Yeah, if you don't resubmit in the next 5 to 10 minutes, then hopefully they're correct.
Yeah. So yeah, I mean, I think it's still going to be an exciting race for third place.
Mm-hmm. And yeah, like all the other positions matter, just in terms of potentially getting a wild card.
Sorry, I mean fourth place. Third place, not counting the fact that
Yeah,
you
third
with
place
Alberta.
university matters a lot, just
Yeah,
because they're guaranteed, and then but even fourth place can matter a lot because there's a potential wildcard there.
Yep. Let's check up on the other two.
Ah, yes.
North Central. What's happening there? They are past 3 hours into the contest. Teams were having trouble with C and J.
One team solved it. Madison Beatree has gone the first accepted on J.
Okay.
Whereas the top Madison team has eight wrong submissions on J.
Wow. And C, there are a lot of wrong submissions, and nobody's getting it.
Yeah, and let's just look at the statistics, right? J. Oh, this is the number. Okay, this is the number of teams, not the number of submissions. If we look at the standings page, though, we can see. What can we see? Oh, I'm just trying to see the total number of submissions on C and J.
Right. Isn't that what the nine is? No, that's the number of teams.
That's the number of teams which have tried it.
Yeah.
So yeah, 9 teams have tried it, with none of them getting it right. So C 0 correct out of 23. J 1 correct out of 24 submissions.
Yikes.
So yeah, very, very, very hard problems, it seems.
And that correct submission was after 5 wrongs.
Yeah.
And how about Mid Central?
Mid Central. Yeah. So U Chicago Pop Up Clock still in first. Following them, all 5 University of Illinois teams.
That's quite the dominance there.
Then Vanderbilt in 7th and 8th.
I guess you can tell which universities have a strong ICPC club. Yeah. And so no submissions for M.
No submissions for M or F. Okay, 6 submissions for F, but none of them by teams in the top 10.
Huh.
And no
so maybe it's a trick problem.
Yeah. We can look at, I don't know, maybe.
Oh, F is Cascade Centrality.
Yeah, F is the problem we discussed earlier. Yeah, and it's like, yeah, we had some solutions that could work, but yeah, it's like unclear whether they work or not.
But that suggests to me that maybe they don't work. Maybe my proposed solution of just like considering partial paths up until the quotient is small doesn't work.
And maybe they just they could have set their like epsilon to be too big or too small or something.
Maybe.
But yeah, we shall see as time goes on.
Yeah.
We can take a look at maybe L has a few submissions.
Sure.
Oh yeah. Also, the M you said had no. That has no submissions is an interactive problem.
Oh no.
Yeah, let's look at L for now.
Okay. Mid Central L. This is Road to Rome.
Road to Rome.
Okay, short problem statement. Okay. Sharing. Archaeologists have recently discovered a site believed to be part of the Roman road system dating back to 450 BCE. They unearthed a scattered set of rectangular blocks of rock and seek your help to predict the direction of the road. The most likely direction of the road is determined by identifying 2 parallel lines that enclose all the discovered rocks. I wish there was an image for this.
Yeah.
Among all such pairs of parallel lines, your goal is to find the pair with the minimum perpendicular distance. So I think what's going on here is you're given points.
Mm-hmm.
You're given up to 1 million points, and then figure out two parallel lines. Figure out the angle of parallel lines such that the width of the road is minimized.
Mm-hmm.
Okay, that is indeed a geometry problem.
Um, yeah, it seems to be like some sort of like moving calipers type. Wait, how does this work? Is this just moving calipers?
I'm not familiar with that phrase, but
Um, it's like you like start at like a certain angle, and then so like let's say we start. Okay, so I guess one thing to note is that only the convex hull of the points matters. Uh,
that is a good point. Yeah. Actually, that might be the solution then.
mm-hmm.
Take the convex hull, and then the answer is going to be along and let me draw something. Is the answer going to be along an edge of the convex hull always?
Not necessarily.
Not necessarily.
Uh, wait, maybe it is.
There's always going to be one edge that it's
Yeah, okay, I think yeah, you might be right. It might always be along an edge of the convex hull.
I'm not totally sure.
Or like, consider like, uh, consider a situation where there's a unique top point and a unique bottom point, and like where like the
Yeah.
lines are like rotate the polygons such that the lines are are horizontal. If there's a unique top point and a unique bottom point, then you can rotate slightly more such that the vertical distance is smaller.
Okay. I'll try draw a diagram that doesn't mislead you too much. That's always the problem with a geometry problem is you try to draw a
Yeah.
diagram that's not too generic and like or sorry, that is generic. It's not
Yes.
like pairs of equal size or of equal size edges or something like that. Okay, so you're saying if you have, say, these are the 2 points that you're considering,
Mm-hmm.
and that's the line. So
But
no,
then,
this is yeah, right. Then you could always find a shorter distance by going to one of the edges.
mm-hmm.
So this is always going to be shorter than the distance to between these two vertices. So vertex. So I think the answer might always just be a vertex to an edge.
Yes. But the issue is like even if you know that the line like one line will be parallel to one of the edges of the convex hull,
Yep.
uh, finding the like extreme other point, basically the point that is like furthest away from from this uh from this edge is like you have to use some sort of binary search or I think two pointers with
I think 2 pointers works because
okay yeah
what you do is you're walking the edge around, right?
mm-hmm.
You're rotating the edge and you're keeping track of what the opposite point. Well, first you brute force the first one, so you keep track of what the opposite
Mm-hmm.
point is, and then when you move, say from this edge to this edge, this point is just going to move in this direction. And you can just walk
Yes
in that direction. I think
oh yeah I think that sounds correct but yeah you have to be careful um
because if you from the perspective of this line, it is a concave function, and you are just trying to find the maximum on it. And so
yeah
you'll just go in the direction, you'll go along the slope, right? Which will always be, I think it'll always be in one direction. Um, anyway, I claim that this is correct. So,
yeah and just
but even if this isn't correct, yeah, you could ternary search, right?
yes you can turn it like for each side of the polygon you can turn your search for
Yeah,
which of the other vertices of the polygon is furthest away from it
yeah,
um yeah
and of course,
I think
convex
the
hull.
like the two pointers like moving like if you move the line clockwise along the hull then like the opposite point should also move clockwise around the hall. But there's like always with these geometry problems, there's like edge cases you don't think of. So,
That
but I
that
think
certainly
in this
sounds
case it
reasonable.
works. Yeah.
Yeah. Okay. And of course, convex hull is something that people, certainly the top teams are going to have them in their library.
Yep.
So you just type it in.
Yeah, you type it in, and then you just make sure you like implement the details correctly on getting this furthest point.
Yeah, and you don't have to worry about tiebreakers. So they do.
Yeah, because all you care about is the distance. So
Just care about the distance.
yep.
Yep. Okay, that seems reasonable. It's not too bad as geometry problems go.
Mm-hmm.
Cool. So that was L. We have 40 minutes to go in Rocky Mountain.
Yeah. And yeah, let's take a look at that Calgary submission and see if they resubmitted.
Yes.
Let's catch up on that. So it seems that see both Calgary Diplodocus and Mine Sapphire on their respective problems have not resubmitted. So it seems like both of them have solved their problem.
Seems promising, yeah.
Yeah. In which case they'll still be tied on problems going into his last 40 minutes.
And Calgary also has a wrong submission on E that they have not retried yet. So maybe they have an idea on E. E was, let me check. E was breaking maze, which we haven't looked at yet.
Do you want to check out that problem or?
Sure. Right. So this is breaking maze.
Wait, sorry, which?
Oh, no, sorry. I'm looking at the wrong contest. My bad. Oh, it's draft lottery, which we did look at.
Which is something we looked at.
Yeah. So that's the combinatorial problem. And I guess, I don't know. I guess if you get the wrong answer to, or if you get the wrong approach to the combinatorial problem, you might not be able to fix that.
So should we look at a problem from? We can look at a problem from Rockies, or we can look at the other regionals. We can continue doing Mid Central.
Sure. So Mid Central. What have we not covered yet?
Okay, so one team has solved Cascade Centrality.
Oh, nice.
It is Pock.
So it is solvable.
Yes.
I don't know how to solve it, but it is solvable.
I think your solution might work. It's definitely at least close to working.
Maybe.
Yeah, we can talk to the. I can talk to the teams after the contest and see.
Yes, sure.
Currently, we can look at. I don't know, problem G, easiest CAB.
All right.
Seems has 9 solves right now.
Okay.
Seems like a medium problem.
Not too bad. All right. This is fairly long statement. I'll just open it up in a browser. Okay, we know how to alphabetize a list of distinct words when the alphabet is known. If one word is a prefix of another, the shortest word always comes first, of course, and for any other pair of words, you just find the first position where the letters differ. Okay, so the reverse problem is you're given an ordered list of words, figure out the lexicographic order of the alphabet. And then they give a list of Unicode words. So some lists may contain inconsistencies. So here's where the complexity comes in, I think, making any alphabet ordering impossible. And some lists may not provide enough information to derive a unique alphabet order. So what are you actually asked for?
You asked for if there's a unique alphabet order, I'll put it. Otherwise, if there's no ordering, I'll put impossible. And then if there's multiple possibilities, I'll put ambiguous.
Okay. So I think this is just every there's up to 1,000 words. I think every pair of words potentially gives you a directed thing from one letter to another. Either
Yes.
either that uniquely so you just look at this directed graph, either it uniquely specifies the position of all letters,
Hmm.
or it's got a loop, or it's ambiguous.
Yes. And yeah, I think what you're saying. So it's like, I guess one thing we need to say is that like between every pair of strings,
Yep.
uh, the only character that matters is the first digit, first character that differs between them.
Yes.
And in particular, we get no information about any of the other characters.
Correct.
Like, yeah.
So, so basically, we're getting a whole bunch of pieces of information, which is this letter comes before this letter.
Mhm. And
And that's what it boils down to.
yes. So yeah, I think
And
your solution works is that in that like, um, actually, so one thing that's like ambiguous, it's like there's like n squared pairs of strings, right? But then we have to figure out what is the first character that differs between them. And if you
so
do this naively, it would be rather
yeah.
slow.
Okay. I mean, it's not really that slow, but you're right. I guess it's possible.
Yeah.
Can you see what the time limit is?
The time limit is um 1 second.
So that's 2 billion very simple operations.
Okay, yeah. So
I'm not
one thing
totally
I
sure.
noticed is so like if we have the information that string one beats string two and string two beats string three, we don't need to add the information that string one beats string three.
So
Like,
really, we could sort the strings in advance and then
we
only
don't need to
consider
sort. Like they're
the
already
casing pairs.
sorted, right?
Are they? Oh, sorry. No,
Like
sorry.
they're given in the alphabetical order in the language.
So wait, we don't need to consider all million pairs. We just need to consider all 1,000 consecutive pairs. Is that right?
Yes.
I think that's right. I think you can't get like if there was information that you could get between this word and this word, you would also get that information from like between an intermediate word and this word.
Yes.
I agree with that statement. Uh, okay, so I mean it's pretty close, right? Like it's possible that
Yeah.
it could actually work if you do all 1,000 pairs.
And yeah, there's also other ways to like quickly compute the longest common prefix uh,
Sure.
of two
There's some
strings.
pretty advanced string
Yeah,
things like prefix trees and stuff like that. But those are super overkill.
yeah, but yeah, for this one, it seems that you only need to check the n minus one.
Yeah, okay, I
Yeah.
agree. So you check each consecutive pair of strings, then they give you implications. Then you just have to do whatever. I mean, it's going to be like, for instance, you can just run a naive topological sort on 26 things.
Oh yes. Oh, it's
And
not necessarily 26, right? Because it's not characters, but
oh, oh no, it's UTF-8. Oh, geez, so you have to actually work with UTF-8
I mean, you
in
don't need
the,
to work with anything. Like,
you do, because the input is in UTF-8.
oh sure, but like it doesn't matter. Like you just have a graph on like some number of
It matters for C++ because how are you going to handle the UTF-8 strings?
uh
You have to handle the code points. Just see, I mean, I guess C++ does have.
well, like UTF-8, like if you're just reading a string, it should work, right?
Does it? So a C++ string, does that handle code points? I've never seen this in a
But when you
ICC,
make code,
ICPC
isn't
code.
UTF-8 like only like 1 through 255?
No. Uh, so remember we saw in the previous problem, like UTF-8
Wait, isn't
code
that?
points can be.
I thought that was like an extension to UTF-8.
Oh,
Oh no, you may be right.
yeah, I think these are multi-byte code strings, code points. Um, so you actually need, so okay, so I didn't even realize that. You actually need to support UTF-8 in your language. And I don't think C++ strings are natively UTF-8, are they? Or well, I don't think they're natively code
Yeah,
point.
they're just natively like
They're natively
only
just
allow
bytes.
unsigned cars or so yeah.
I
I don't
actually
know.
don't know how to handle UTF-8
I
properly
think
in C++.
Python. Oh yeah, yeah. I would just use Python, and
Yeah.
it seems this is what most teams are doing.
Okay.
Uh,
I haven't actually seen this before. I've never seen non-ASCII input before.
yeah, it seems rather suspicious, but
Yeah.
uh,
Interesting.
hmm.
Is this the same contest that had the UTF-8 description?
um, so this problem.
No, it's not.
No, no, no. So the UTF-8 was on both Mid Central and North Central. It was an artist who shall not be named.
Oh, okay. So they did at least give you the definition of UTF-8,
And
which is funny.
technically, yeah, but
Okay. Well, I'm not sure I totally approve of that, but whatever. The rest of the problem, I think we're agreed on how to solve the rest
yeah,
of the
yeah.
problem.
Just how to read the input is the hard part.
But anyway, you have so your point was you could have up to 1 million characters, 1 million different characters.
Um. Oh wait. Okay, this is true. But like only because
But you only
you
have a
only have
thousand
n minus one
implications.
implications.
Yeah, yeah.
So
So
if
if,
you have
if you if you got more than 1,000 characters, then there's no way they can be uniquely constrained.
yeah.
Okay. Um, so yeah. So then you could just do. You don't even have to optimize your topological sort. You can just do an n squared topological sort, and if it all works out, if everything is unique, then like if there's a guaranteed maximum that's greater than all other characters, then you're good. Otherwise, you're not good,
Yeah,
and
yeah.
then you continue on. Um, and then the ambiguous case is just testing for loop,
Or the
or
none case is testing for loop.
in the invalid case. Yeah.
Yeah.
Yeah. Okay.
Um. Okay, yeah. So there's other problems we could try looking at. Uh,
I hope not too many teams are getting flustered because they don't know how to handle UTF-8 input.
yeah, it's hard. It's hard to tell. Like,
Yeah.
it seems most of the top teams have solved G. So yeah, which is the problem we just discussed. So it seems they're not really having too much issues.
I mean, it's kind of funny because all modern programming languages handle UTF-8, or, well, handle Unicode just fine, but
Hmm.
C++ is not a modern programming language.
Yeah.
So, yeah. Okay. Uh, what should we look at next?
So okay, so on North Central, so C and J were the two problems that we previously had not seen, or previously not seen solved.
Okay.
Uh, so shredded bowling, so problem J has been solved by two teams. But
Nice.
breaking maze still has not it has not been solved in North Central, although it has been solved 7 times on Mid Central.
Oh, really? That's weird.
Yeah, hopefully there's not like some clarification that's only gone out to Mid Central.
Oh boy, yeah.
I
I mean, it might be a
think
follow the leader type thing, right? Where
yeah,
people see it getting solved.
yeah, that's always very possible.
Well, let's take a look since that's interesting.
Breaking maze. Okay.
Yeah. So this is problem C on NC, and it is E on Mid Central.
Hmm.
Okay. Bringing it up. Sharing. Okay, so Christian starts at the top left corner of a maze, and Grace starts at the bottom right corner. It's represented. Sorry. It's represented as a 2D grid. Each cell has a non-negative cost, and 0 is an open space. Christian wants to move from top left to bottom right with the minimum number of steps. Which means that the sum of the costs of all cells along the path cannot exceed the total strength S. Okay. So it's not like it's not the sort of problem where you can only move right or down to get to the bottom right. You can move up, down, left, or right.
Mm-hmm.
The only constraint is that the cumulative cost has a limit. And you want to find the shortest path. So you're not counting paths, you're just finding the shortest path. All right. S is up to 10,000. Do you just do a BFS where your state is your position and your strength remaining?
So that would be, oh yeah, that's like very borderline. 10 to the
It's
8.
like 100 million states. But most of them are probably not. Well, actually, you probably could make mazes so that most of them are reachable.
It is a 6-second time limit, so that does seem rather doable.
Yeah. This seems pretty simple, to be honest.
Mm-hmm. And yeah.
Am I missing something?
So the issue is like, because there's 10 to the 8 states, like how do you keep track of which states you've already visited?
I guess, yeah, if you're just keeping a queue, if you're doing a BFS with a queue, you could have a very large queue.
Mm-hmm.
And you have to not add states that have already been seen, but you could just do that with an array. Um, hmm.
Or like in particular, like
I think in particular you can't have the log n factor, right?
yeah. But yeah, like yeah, I think what you so instead of like keeping like a set of all the states you visited,
Yeah.
you can like compress each state into an index that's like between 0 and 10 to the 8, and then yeah,
Well, it's not even compressing. It's just 100 by 100 by 10,000.
yeah, sure.
Yeah.
And then yeah, once you have that, then you just have an array of 10 to the 8 bits. And it's slightly over 10 to the 8, but yeah, around 10 to the 8 bits. And
Yeah, that seems like it works to me. I think as long as you don't use a fancy data structure that adds a log n
mm-hmm.
requirement, I think you're okay. And so the BFS, you're not using a priority queue or anything for the BFS. I think you're just doing one step at a time using queues or using like these are the current sets of states, these are the next sets of states.
Mm-hmm.
And then there's no log n factor.
Yeah.
So
Yeah, seems like a relatively straightforward problem, although it does require like a little consideration to make sure you don't just to avoid the log factor.
yeah. So it's borderline TLE question mark avoid log factor. Don't track states with sets or something like that.
Mm-hmm.
Yeah, I think that covers it. There aren't really any other like there's not really any way to get this problem wrong as long as you don't TLE, right? Like it's pretty straightforward.
Yeah, I like there's also, and I think this is in the sample, but you have to make sure you do all 4 directions.
Oh, sure, yeah.
And that it could be something you get. It's like very easy to get wrong, and then like if the samples are weak, then you might miss it. But seems
Right.
the samples look pretty strong just on the eye test.
Okay. All right. Well, I'm a little surprised that nobody has solved that. Wait, everybody's getting that wrong on North Central.
And it could be a time limit. We should so did you like it could also be 2 problems with the same name.
Okay. Let's make sure.
Yeah, let's make sure. But yeah, like we can't really tell if it's wrong answer or a time limit.
Yeah. No, I think it's the same problem.
Looks to be the same. Yeah,
Yeah.
I assume it's just teams just running into time limit. Um,
So so maybe our approach isn't no, okay. Maybe teams it's just very common for teams to try using a set or a priority queue or something
mhm,
that's just a little too slow.
yeah, and that's I guess check the time limit as well. Yeah, same time limit, same everything.
Okay. I'm a little confused, but oh well. So 20 minutes left in Rocky Mountain.
Should we just look at what teams are submitted?
Sure.
Yeah, Arizona State still yet to submit on their last problem. Uh, Across the board, uh,
I mean, they almost don't need to, right?
I mean, yeah, it's but like I assume that no one would hold the problem. They're probably still mid solve.
Right.
And okay, I guess there's the other thing of uh because of the penalty situation, you might just want to be 100 like do all the testing you can. Like just like there's no reason not to wait, or there's no reason to wait. Oh, sorry, what am I saying? There's no reason to submit where you can just test more and wait.
Yeah,
Which
I
is
mean, yeah, with the balance being you don't want to spend 20 minutes making sure that a correct solution is well, I don't know. It's a balance. But yeah, the balance definitely shifts more towards getting it correct towards the end of the contest.
mhm.
Whereas in the beginning of the contest, the balance is more like shotgun submitting because any time that you waste testing on the early problems is something that costs you on every later problem.
Mhm.
Strategy.
Do you want to look at buying jerseys, the problem they're trying, or maybe we can look at F, the problem that uh,
All right, let's look at
Calgary and CS School of Mines have submitted?
uh yeah, let's look at buying jerseys.
Buying jerseys? Okay.
Problem, excuse me, problem B from Rocky Mountain.
Yes.
So
It's
this
currently
is
only solved by the first place team, uh,
and
Alberta
this is
Institute.
presumably what the second place team is madly working on at the moment.
And yeah,
So,
they have nothing else to be working on unless they're just given up and feels comfortable in second,
yep.
which is theoretically possible. But I assume they'd be there's nothing else for them to do.
They might as well, right?
Yeah.
All right. You found a job managing a soccer league in rural Saskatchewan. It's located several hundred kilometers from any major city, so has capacity for only two teams. Not much of a league. There's little else to do in rural Saskatchewan, so many players have developed bitter personal rivalries with other players. These players will refuse to be put on a team with any of their rivals. Last season, your predecessor found a way to assign players to teams that respects their preferences. Since it's a new season, you now have to purchase new jerseys for the league. After looking into the cost of buying jerseys, you've realized that the teams from last year, which did support the rivalries, may be very expensive to support. So you decided to reassign the teams. Players on one team required jerseys, which cost $1 per player. Players on the other team play without jerseys. You can choose to remove some players from the league. Removing a player costs the league $2 each because their entry fee has to be refunded. Okay. Despite your best efforts, it may be the case that last season's team assignment may have already been as cheap as possible. Um, so you just have to. I think it doesn't even you don't even care that about what last season's team assignment is. That's kind of a
Um,
red herring, I think.
I think it might be useful just to know that it is possible.
Ah, okay. So
Like,
that's a fancy way of saying that there is a valid
and it
assignment.
like tells you it. Although
In other words, this is a bipartite graph.
it is bipartite.
In other words, it's bipartite. I think you're right. I think that's the reason that they mentioned last season it did work.
Okay.
It is guaranteed that this. Oh, they actually give you the assignment. Oh wait, yeah, they actually give you the previous team assignment. Interesting.
Yeah.
But I'm not sure that that really matters.
Yeah, because you
Does
can
it?
just compute a bipartite match, bipartite coloring just by yourself.
Yeah. Because you don't use it for your own like it doesn't affect the cost of your solution.
Hmm.
And is there a tiebreaker? Let's see.
No, you just print the min cost.
You just print the cost. Okay, so no tiebreaker. Um,
And this feels like a bipartite assignment problem.
do
Although
you
it is
do you ever want to
or
remove do you ever want to remove a player from the league?
um
I guess
good question.
they might have a lot of edges with
No, I feel like it definitely should be possible. Like
suppose you have this graph.
yeah.
Then do you maybe want to remove these two players and then put all the rest on the same team?
No, because you can just have those two people on opposite teams on the same team, and then with a cost of two.
You're right.
But I'd say the issue is, oh, what if they have a edge between them?
Yeah, if they have an edge between them, I think that
Yeah,
then
then you
it's
want to
best
remove
to
either of
kill one of
them.
them. Yeah, okay. I mean, we say remove from the league, but we know that they're being taken out back
Hmm.
and shot. um, so that's interesting that you can that there are some situations in which that is actually better.
Hmm. Yeah,
Can you
this.
actually have an assignment where there are zero players on a team? I think you can, right?
Uh, yeah, it doesn't say anything about this.
It doesn't say anything, so I think it's perfectly legal to just put everybody on the no jersey team as long as there are no rivalries.
And theoretically,
Oh, actually, there's always at least one rivalry, so you can't.
oh yeah,
Well,
and it's often like so you could be like, oh, you delete all the people, and then now there's only one team left. But then you could just take any one person you deleted and put them on the other team, and that would be better.
so yeah, I think there's the optimal solution just never has an empty team.
Hmm.
Okay.
So yeah, I feel like
Um,
this feels like flow to me, but I don't see the exact reduction.
flow A. I mean, it's certainly got that bipartite nature,
Yeah.
and bipartite matching reduces to flow. So if we didn't have the removing people from the league,
Hmm.
um,
Then
this
just
is just bipartite matching, right?
and it's like not even anything, right? Because it's just like you for each component, you know which color, which side like you have two for each component. You have like the two bipartite colors. One of them must be the left team. One of them must be the right team. So just choose a smaller one to be the team that requires jerseys.
Right. Yeah. So there's not even a matching part. It's just finding the
Hmm.
components. Okay. So you have these all these bipartite components, and then you want to. So really, the only problem is find which players to remove to like break components up or something.
Hmm.
It's almost like you're trying to find bridges. Is that does that reduce to flow? Like finding,
And it doesn't necessarily have to be a bridge, right?
but it's like bridge-like things. Like yeah, they could be like two nodes or something. That hmm. I mean, I do agree with your intuition that this is probably flow somehow. I'm just not quite seeing. So like in this situation, you'd probably want to you'd want to do a cut here, right? You'd want to cut these two.
Um.
You're finding
Yeah.
some sort of min cut in a
Yes.
situation like this. which certainly sounds like flow.
Yeah, yeah.
um, hmm. Well, I'm not sure I know the reduction right away, but that's
Yeah,
interesting.
I'd certainly say definitely feels like some sort of flow problem, although
Yeah.
um yeah, coming with the exact reduction seems rather hard. And yeah, you said like yeah, if you just have like some like central graph and then like all of them have just like 10 edges from them, then yeah, it basically just becomes um like oh, what is it? Like you sort of want like max independent set on a bipartite graph, which like yeah, which basically requires flow.
Okay. Yeah.
Uh, but yeah, the exact reduction seems rather complicated.
Hmm. Yeah. If only it were $2 and $1 instead of $1 and $2, then then this problem would be easy.
Yes. Then yeah, and very easy. You just yeah, just want
You just
to
remove everybody. Yeah.
yes.
Okay. Anyway, tricky, and that's what the second place Rocky Mountain team is probably working on right now.
Yes.
Is that it for Rocky Mountain problems? Or no, there's one more, right?
I
There's
think there's two more. Let's
corporate retreat. I think that's the only one left.
oh really? Okay.
We could just we don't quite have time, but we could quickly cover corporate retreat just to get that one out of the way. I'll
Sure.
I'll just pull that up quickly, and then we could take a look at the final results. Okay.
Well, I don't think the board will still be frozen, right, for Rocky?
That's true, but we should look in 8 minutes. We should look at what the final
Yeah, yeah.
submissions look like.
The final freeze result.
Yeah, yeah. Okay, corporate retreat. You're going on a 1 day retreat to help your employees build new connections.
Oh, wait a second.
Can you
Okay,
not see it?
yes. Yeah, it should be on. Okay.
Okay. Some pairs of employees already work closely, and so you want to make sure that, so it's another graph problem. You want to make sure that no two employees that already work closely should be in the same activity. Um, and you have 3 activities. So, okay. Every employee is going to be assigned to one of 3 activities, and you have some edges connecting the employees such that they can't be in the same activity. All right, finally, some of your employees are executives. Due to company policy, every employee that is not an executive works closely with at least one executive. Okay. Is it possible to assign each employee to an activity so that no two employees that work closely are assigned to the same activity? Huh. So the executive thing is kind of weird, and that must be the key to this problem.
And yeah, we're just trying to three color a graph, right? We want to assign every vertex to one of three colors, such that no two employees who are adjacent to each other are assigned to the same color.
Is 3 coloring NP complete?
Yes, but there is this condition on the graph that you noted
Yeah, so
that
we have to use executives somehow.
um,
So there are at least, oh, sorry, there are at most 7 executives. That seems important. So there
mhm.
are 1,000 employees. There are at most 7 executives. So maybe what that means is you got like these not quite cliques, but you got like executive stars, right?
Mhm.
Each executive is like a star, and they're not quite exclusive because they could be shared, right? Like
Mhm.
it could be the same node, but somehow we have to look at these stars. I guess you could brute force which color gets assigned to each executive.
Uh, sure, you could do that, but then
What does that give
there's,
you?
yeah. It just means that for every other, um, okay, yeah, I think this works
It
because
reduces all other possibilities to two.
yeah, so
Most,
every other employee has two options,
yeah.
and then I think you can model this as a two sat problem where like
Okay.
so each person is either like they have two options. Like for each person we call them like left and right. We have a variable is like is this person assigned to left? If true, they're assigned to left. If it's false, they're assigned to right.
Right. So even though there are three possible colors, the fact that every vertex has only two possible choices makes this solvable.
Yeah, because it becomes a two sat problem, and
Okay.
yeah, so two sat is something that I hope every team has code for it in their book. Um, and yeah, you just reduce it to a two sat problem, and then uh, the idea is just like for every two colors they can be like some pairs will be like banned, so you just check those.
Okay.
You just like add a clause to your two sat that says not like either one of them is not the color or the other one's not the color. Uh, then you run this, you create this graph, you run it through your two sat book code, and uh, you hope it works out. Or
Yeah.
if it
Okay.
works out, then you output the answer. Otherwise, you say it's impossible.
Interesting. So that, yeah, that looked tricky, but I feel like with that one observation, then you're okay.
Mm-hmm.
Okay. We've just been told that NC froze,
Ah,
um,
okay. I don't know
froze
why it
early.
froze early, but oh, maybe did they have the n-1? I don't know. Let's look at the standings for
Yep.
it.
So North Central has gone into a freeze, and I guess that's because what you said about one team being one away from.
Is that actually what happened, or
I'm not sure. We
maybe they
can.
just started early?
Oh, it's hidden. Um,
Oh, it seems they froze it when one team full solved, which is
oh, really? Okay.
or I don't
That's
know. So one team has full solved, so
okay. That's a bit late. That's like closing the barn door after the cows have fled.
um.
So we
Oh, I
don't.
guess it's despite the fact. Okay, I guess 11 wrong submissions is unclear, but actually,
Okay, 11 wrong. What would that be? That would be a penalty of five. I think that's still lower. So if they get it right, I think they'll still win.
okay, very interesting. So despite the 11 wrong submissions,
Yeah.
uh, if their last submission is correct, they'll have uh, oh, even if they have it wrong right now, if they submit it minute 300 and get it correct, the last possible minute of the contest, that'll be a 520 penalty, and they'll still win.
Yeah.
So yeah,
Because there is just a massive penalty gap between number one and number two.
mm-hmm. So very very interesting situation going on. So yeah,
Yeah.
so I guess they froze it early just to, uh,
Just to enhance
yeah.
suspense. Interesting choice.
Um,
Well, at least these problems are getting solved. So C was breaking maze, and we were a little confused as to why teams were not solving it. So it's good to see that it's actually being
hmm.
solved.
And yeah, I guess let's also look at the mid central uh,
Actually,
scoreboard.
let's go to Rocky Mountain because it just finished.
Okay, yeah, let's look at that first.
So this is the final scoreboard and submissions for Rocky Mountain. So no suspense over who won, but Arizona never submitted B. U of Alberta still couldn't overtake number two. So, sorry,
Uh,
the third place team could not overtake number two, even if they got
and
it
yeah,
correct.
no one submitted enough
Yeah.
uh, to overtake for number three. But for third place university or number four on the scoreboard,
Yep.
uh, so Calgary was in that position before the freeze, submitted only on F. Uh, Colorado School of Mines Sapphire tied on problems before the freeze, submits twice to F and M. If both of them go through, they will be fourth place. Uh, and below that, yeah, it seemed no one submitted enough problems to get more than 8. A couple other teams was enough to submit to get exactly 8 if all of them are correct. BYU vocal pointers, 5 before the freeze, 3 submitted after the freeze.
So the fourth place race is going to be interesting, I think.
Yeah.
That's going to come down to the resolver.
Yeah. So and that fourth place team, as long as it's not from, yeah, I think none of the fourth place, all of the teams that could be in fourth place will be a unique university, and therefore will be guaranteed to qualify for the North America Championship.
Right. And then possibly the fifth,
Yeah.
the fourth place university and fifth place would
Yeah.
also.
They also have chances depending on how the wildcards get assigned.
Yeah. And the one weird thing about like the new North American Championship system is that it doesn't do you any good to win this regional.
Yeah.
All it gives you is a qualifying slot, and it gives you
Mm-hmm.
no other advantages. So
Yeah.
I think we've seen examples of teams winning their particular regional and then not making it to the finals.
Mm-hmm. Yeah. So yeah, it seems the top of the scoreboard, not much suspense there, but below that, for these final NAC qualifying spots,
Yeah,
seems like the resolver will need to be to see a resolution. All right.
exciting.
And let's check out Mid Central.
Yep.
So Mid Central has just gone into the freeze.
Okay, and that one's actually on time.
Yes, on time.
We're fighting over the. Sorry.
Oh yeah. Okay, we're both. Okay, it seems to be correct. Uh, so yeah, University of Illinois in Cello has 12 out of 13, all but one before the freeze.
Mm-hmm.
Um, Behind them, Chicago Pock 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 has solved all but B and M. Slower than Python 3, again tied on problems with 11, although they have gone one submission after the freeze on B.
Mm-hmm.
Then limit testing has had 10 before the freeze. UIUC-A had 9 before the freeze, although they've submitted after the freeze, and UIUC wrong team with 8 before the freeze, with 1 submit after the freeze. And then, so yeah, third place university is Vanderbilt. Vandy 1 and Vandy 2 both tied on 7 before the freeze, although Vandy 1 has had to submit after the freeze. So if that's correct, which we'll see if they resubmit or not, but if that's correct, they'll be ahead of Vandy 2 for that third place university.
Yeah, good.
So yeah, is there any problems? Should we do you want to look at the unsolved problem for M?
Yeah, we can see the problem that they're all scared of.
Yes, it's interactive, as I said before.
Yeah, yeah. Interactive problems can be quite fun.
I also got DM'd by one of the volunteers who is mad at the problem statement, so maybe we can discuss that.
Mad at M?
Yes.
Oh, okay. Because we were mad at a couple of the other problem statements.
Yeah.
Right. I think I'm just going to bring this up in a browser. All right. Sharing. Make sure we have audio. And okay, so it's an interactive problem. From a ridge outside the city, you observe a straight line of 2025 tall buildings. Some buildings have an enhanced security beacon on their roof. You can't identify individual beacons, but you can report an illumination coefficient for any contiguous frame of buildings that you choose. And the illumination coefficient is, what is this? The total.
It's okay. So yeah, the hidden information is a binary string of length 2025, and you can query.
Right. You query a substring LR,
Mhm.
and then
So of all sub intervals of that substring, it counts how many eyes are on.
okay. So I
And
guess
okay,
if you've got a substring of length 2, for instance,
mm-hmm.
it's going to count the left one twice and the right one twice. And if you've got a substring of length 3, it's going to count the left one 3 times, the middle one
Oh
four
yeah, left one.
times.
Yeah, 3 4 3. Okay, yeah.
It's going to be 3 4 3, and so on and so forth. So like the left and the right can't be distinguished, but like the middle ones are going to have a different coefficient
Mm-hmm.
than than the ones on the edge, right?
Yes. And so here, I'm not sure. Okay, you probably didn't see this because this is what someone has DM'd me about. But each test case is a uniformly random binary string.
Oh, yeah, okay. It's not adaptive.
And it's not like not even adaptive, but like it's not even like a hard test cases. Like
Yeah,
there's guaranteeing it's a uniformly random binary string.
which I guess you're going to have to use in your
Yeah, I'd
in your
assume
solution.
assume this will be used.
I mean, can you not just get can you not just do 405 queries, like almost random queries, and then
It seems kind
you
of
get a
complicated. Like,
you get a large system of linear equations?
but then like it's like a like the system of linear equations can't be solved uniquely. But the fact that it's an integer system of integer linear equations, maybe it can be solved uniquely, but then you have to have like a integer LP solver, which is uh,
Yeah,
not really fast.
yeah.
Okay, one thing I can see is like if you query a string of length 5, um, okay, I guess that's not enough, but like,
But actually, I disagree. I think you can solve it uniquely, given the fact that, well, okay, not as arbitrary integers, but the 405 queries are going to give you these integers, which are the sums of various coefficients, and I think
yes,
that can be solved uniquely
um,
because the variables are only 0 or 1.
yeah, it could be the case that there's a unique answer, but then like efficiently computing that answer would be hard.
Yes. So like even okay, so you've got 1/5 of the queries. Suppose you just queried for 5 buildings.
Mm-hmm. Yeah, so then the
You,
count,
you
so it's like it would be 5 times the first one, 6 times, 8 times the second, 9 times the middle, 8 times the fourth, 5 times the fifth.
5 8 9 8 5, really?
I believe so.
Because it's two times two
Like
times
five
four,
times one,
two
two
times
times.
four, and then 3 times 3. Yeah,
Yeah.
yeah, yeah. Okay, yeah, okay. Um,
So yeah, like I think this. Yeah, I don't see any way for two like different things to sum to the same value. But the issue is like if you get like if your sum is 5, you know that one of the fives is on, but you don't know which 5 is on.
Yeah, the issue is you're going to have to use another query to determine that left one from the right one. Yeah.
But yeah, because of the uniform random condition, you'd only need to do this so half the time for the 5s and half the times for the 8s. But still, that is too much.
But if you, okay, suppose you just determine the first 5 values just by querying.
Mm-hmm.
You just use burn 5 queries for the first 5 values, and then you query for the first 10 values.
Mm-hmm.
You already know what the first 5 are. So now you've got 5 different coefficients for the next 5.
Yes, but it's not. Okay, like, what are those coefficients? There are 10, 10, 18,
3 times 8 is
3 times 8
24.
is 24.
Yeah.
4 times 7 is 28. Then 5 times 6 is 30.
So the question is, how likely is that to be unique?
Um, I think it
I
might
think it's
always be
usually
unique. Oh, like,
always. Oh,
oh,
you
like I
think
cannot. Okay, maybe I'm just like not looking close enough. But I don't see any two pairs that sum any two subsets that sum to the same value. Ah,
so?
okay, 10 and 18 and 28.
Okay, but it's unlikely.
Yes.
So maybe that's just you have to pick a particular value to keep adding on to keep on. I think you have to just pick a particular constant. Like we chose 5,
Mm-hmm.
but that was a bit arbitrary. You could choose 6, or you could choose something else. I
And
think you just have to,
five makes like if it was unique for 5, that would exactly just give us the answer, right? Because the number of the query limit is exactly n over 5.
except that we have to burn some queries
Yeah,
at the
but
start,
yeah, we have to burn queries at the start and also.
and also occasionally we're going to get unlucky.
Mm-hmm. But
So so I think maybe you pick 6 or 7 or something like that,
yeah.
and then sometimes you'll get unlucky and you'll have to do another query to disambiguate 2 possibilities.
Mm-hmm.
But maybe that just works for random cases.
Yeah, and this is a type of problem you like, uh, because it's random cases, you can just test it locally and
Yes.
see if it works.
Yes. You're going to know if it's wrong. Yeah.
Yeah, I mean, like, you could have a solution that works on like I don't know 99% of random cases, and it guarantees there will be exactly 100 test cases. So then if it runs correctly 99% of the time on a random test case, then it will work. Like the probability it'll pass is about I don't know, it's around 50-50. I think around 37%. So then I don't know, you might just submit that, or you might just try to make slight improvements, like maybe move it from 99 to like 99.5, and then submit that.
I think your chance is actually 1 minus 1 over E.
Yeah. Oh, 1 minus. Okay, I don't know. So yeah, 60.
You're more because they cluster, right? So you're more likely to get a sequence of 100 corrects than you would otherwise expect.
Uh,
That's how I'm thinking about
I
it.
think it's 1 over E chance.
Is it 1 over E? It's either 1 over E or 1 minus 1 over E.
And it's 99 over 100 to the 100. Could probably you get them all right, which should be
Yes.
1 minus 1 over E. Or which should be 1 over E.
Okay.
But yeah, and the point is, if you're at exactly 99% with like 45 minutes in the contest remaining, just try to like I don't know, change your constants a little bit so that you probably improve slightly, and then you should be able to win.
So I don't know. It doesn't seem that scary a problem to me. Like it seems like you just have to pick a heuristic.
I mean, okay, I was told the string was uniformly random. If not for that, I don't know if I would have noticed, which is pretty bad.
Well, you're saying because it was buried in the specification.
Yeah, because it's not on the first page. Oh yeah, like on the printed copy, it's not on the first page. That's another thing.
Right.
But yeah, still 0 submits as far as I can tell.
Yeah, I wonder why people are scared of it. I mean, interactive problems are always scary. We've noticed that in the finals too. Even the easier ones, people tend to stay away from.
I mean, and there haven't been that many finals problems that are interactive, right? There's like
Very few, yeah.
And then one of them was very easy. So in 2022, which is one of the years I competed in.
The Sphinx one,
Yeah,
right? Yeah,
I
that one
first
was
solved the
almost trivial.
problem.
Yay!
But yeah,
But yeah, that one was almost trivial. So
yeah.
people were not scared of that. But like I think a couple of the others we've had zero submits at the finals. So
Hmm. Okay, so yeah, currently a bunch of teams have submitted B on Mid Central.
mhm.
Yeah, top teams, as far as we know, top. So one team has solved all but M. Next two teams have solved all but B and M, but have submitted B after the freeze. And then,
Mhm.
so they could be on 12 as well. And then the teams below that, who knows? Like, all of them have one submit up to Vandy 2. Or, okay, I guess they've submitted to one problem, but many of them have multiple submits on that problem, which is not a good sign.
Yes. Although if they're submitting like one a minute and then they stop, sometimes that is a good sign.
Yeah, but I don't. Yeah, all I know is the number of submits, so it's hard
Yeah,
to tell.
hard to tell. Yeah, so it's fairly exciting. Mid Central is fairly exciting.
Yeah,
Well, I mean, especially if you're Urbana Champaign.
yeah, it's a very close race. A bunch of teams have yet to solve. Yeah, uh, Cascade Centrality seems to be the blocking point for a lot of these, and then yeah,
Yeah,
the rest
yeah.
of them a little mixed, but yeah. So
Well, I was a bit stumped by Cascade Centrality, so
and yeah,
I,
we should like given that so many teams are solving it. I think your solution will just work.
hopefully,
Um, yeah, we shall see.
yeah. And then North Central is still frozen, but
Oh,
what are
yeah, let's
they?
just take a look at that.
What are they up to?
So uh, UW Madison Ishikawa has more wrong submits. So they
Are they
had
getting close to the threshold where they might not be able to win? 15 times, so they're at so it would be 600. They would still win even if they got it
even
after
if they got it at the
15.
end of the contest, they'd still win. With
Yeah.
so I believe they had 10 wrong submissions before the freeze, and now they have 3 after the freeze.
Yeah.
Uh, and there's also a possibility, and it's like probably not that likely, but teams have been known to after they get that last AC just to submit again. It shows
Really?
up on the scoreboard, but does not impact the penalty.
Oh, that's tricky. I didn't know
Uh,
I didn't know you could do that actually.
or it depends on the scoreboard software. So
Yeah.
on like um yeah, it depends on how exactly the scoreboard. I think on Caddis it would show up. So Caddis is the what the site the contests are currently being hosted on,
Okay.
and uh,
So
yeah,
it's still theoretically possible for U of Minnesota to win as well, right?
U Minnesota had so they submitted
I think
at
it is.
240. Oh yeah, they could easily still win because yeah,
Yeah.
they have 2 wrong submit. They have at least 1 wrong submit on C, 3 wrong submits on J before the freeze. But even with that, if they solved if they solved the last problem even at 300, and they've already solved C, which we don't know if they have, then they would still be ahead on penalty of B tree.
Yep. It's an interesting situation in which, there's one team that is leading on problems but has a really large penalty.
Yeah. Uh, have we looked at problem J on North Central?
I don't think we have yet.
Yeah.
All right, North Central.
So, yeah. The team that solved it before the freeze had 6 wrong submissions, and oh wait, and although Carleton College also started before the freeze in their first try.
Okay, so this is a
Oh
problem
no,
that
this is not Carleton
some teams are
College.
racking up a lot of wrong submissions on. It's called shredded bowling. Okay. Sharing. You found a bowling score sheet that has been ripped. Is that just an unnoticed typo, or is that a joke? Oh well. It has been ripped apart like confetti. Maybe the player was not happy with the game. So uh, there's exactly one frame per piece of confetti, but only the number of pins knocked down on each roll is recorded. And they're not defining this, but a frame is one of these things, I believe. So there are 10 frames in the game, I think. Um, only the number of pins knocked down on each roll of the ball. There's no cumulative scores for the frames themselves, which are the numbers on the bottom here. You see, like these are obviously not included because that would be a lot more information. So instead, what you see is these, I believe. Okay. The total for a completed game is eventually found on a separate piece of confetti. But you have to make sure that there is some way of reassembling these frames so that the final score matches the score on the piece of confetti. All right. And then it's describing the rules of bowling. So if you get a strike, then the next two rolls count towards that score. If you get a spare, then the next roll counts. And of course, the final 10th frame is a special case because if you run out of rolls and you still have like a strike or a spare to count, then you get a couple of bonus rolls. And as you can see in this example, in fact, in the 10th frame, they got 3 strikes in a row, which counts as 45. Wait, sorry, which counts as 30.
Mm-hmm.
So yeah, this is 10 pin, not 15 pin. Or not, sorry, not 10 pin, not 5 pin, which has a total score of 15, I believe. Okay. And okay, so they're sort of describing the rules of bowling, and you're given 10 frames, you have to reassemble them, you're given the final score.
So yeah, uh, so but yeah, basically like we're given these like we have 10 frames and then the final score, as well as
You're actually given one more piece of data. You're given the number of pins knocked down on the third roll of the 10th frame.
yes. So it's like yeah. So how it works is like if you get a strike or a spare in the first 2 rolls of the 10th frame, then basically to round out because like a strike gives you the score for your next 2 rolls. So if you have a strike on your first roll of the 10th frame, then you still need 2 more rolls. Uh,
I don't understand this thing though. It says or just 0 if there was no third roll. How can there be no third roll?
because if you do not get a strike on your 10th frame or a spare, then there will be no third roll.
Sorry, I'm so used to 5 pin bowling.
Oh, okay.
I keep forgetting. Yeah, 10 pin bowling is different. Okay, yeah. So there are two bowls per frame.
Mm-hmm.
Yeah. Sorry. Okay, got it. So 0, in other words, if you do not get a strike or a spare, then that number will be a 0.
Yes.
Okay.
So, so basically, and it depends. Like you have to think a lot about the rules of bowling, but basically the only there's like 2 things that matter. It's like, basically we're going to try to do a DP. Okay, so I guess the first thing you could try is, uh, you can just try all 10 factorial permutations uh, of the frames.
Is there a reason that wouldn't work?
Oh, actually, okay. I think this would work. I was going to describe a slightly better exponential solution using bitmask DP or using some DP, but I think just doing 10 factorial permutation should work.
I think the difficulty of the problem is just in getting all the mechanics right.
Yeah.
Your idea is compressing some state so that you can
Yeah.
memorize basically,
Because yeah,
right?
because the only state you care about is like which rolls have been done as well as what the last two rolls were. Because
Right, right.
if like the roll two ago is a strike, then like your score from this roll gets added on. Otherwise, if it's not a strike, if it's a spare or just a normal roll, then your score from this roll will not be added on.
Now you still have to store the bit mask of which frames you've used, but so
Yes,
it's still exponential,
it's
but
still
it's
exponential, but
less exponential.
well, like a factorial is not exponential, right? It's worse.
Yeah, you're right.
So
Sorry.
yeah,
Yeah. So it goes from O of n factorial to
O of
d,
2 to the
d
n
equals
times some polynomial factors.
yeah times poly. Yeah, sure.
But in this
Um,
case, yeah, it seems that yeah, just uh, you have these 10 factorial configurations. First of all, you have to see if they're even valid, right? Because uh, if
so how could they be invalid?
so, if you the pair of numbers in your 10th roll does not include a strike or a spare, then the last number must be zero.
Yep.
Also, like for any of these situations where like the 10-10, that one must be last.
Anything that is 10 followed by a number has
Yes.
to be last. In all other cases, the two numbers have to sum to 10 or less.
I guess one thing, like if the input is like 8-8, which that is never valid in 10-pin bowling.
Yes.
Um,
And they actually don't eliminate that from the possibility, right?
as far as I haven't read it closely, but I don't see anything saying that's impossible.
Actually, they just give you numbers. They don't even tell you what the like they could be floating point numbers for all the input says.
Yeah, I just okay. Yeah, it's very. And it says it represents the number of pins knocked down, but like, so it should be a number from 0 to 10, but uh,
Yeah, that's a little bit sloppy, but I'm assuming that they're all integers from 0 to 10.
mhm.
Okay.
So yeah, but yeah, it seems like it's mostly a case of getting the details right rather than any complex algorithmic.
Yeah, I
Uh,
think so.
and yeah, the two samples are basically exactly the same. One the correct order and one in sorted order. So yeah, it seems that they're intentionally given rather weak samples.
They don't even give a sample with a no answer.
Yeah.
So I think there are a lot of cases where there is a no answer because just something is completely invalid, and you might have that bug and you wouldn't notice.
And yeah, it's unclear if that's a valid input, but if it is, then yeah, you have to make sure to output no.
Yeah.
Although it does say you have to display. So if it's no, you have to display the highest possible score that you can get.
Interesting. Which implies that there has to be at least one game that is
Yes,
valid.
or the highest score less than the score if it exists. And
Highest possible score less than that. Oh, geez. And they don't even show this in the sample output.
yeah,
That's really bad. They're not showing. They've got this separate format of output for no, and they don't give you an example of the no output.
and wait, yeah, you don't even say no. You say okay,
Right.
whatever.
Okay. That's I don't like that. But anyway, uh, so yeah, I mean this they don't tell you what to do if there's no game that matches. So there must be a game that matches, right?
Hopefully.
Hopefully. It's the unspecified third possibility, which is you have to output this game does not work.
Hmm. Yeah, the only thing is that I'd assume like um I don't know. I assume technically you would output nothing, and I guess that is valid, right? Like it says if it exists and if it exists, So then,
Uh,
if neither of them exist, you just output nothing.
oh my goodness.
But I don't know.
And do you output a space before the lowest possible score? I mean, white space doesn't tend to matter in the judge output, but like, if there's no matching, if the first one doesn't exist but the second one does, are you supposed to put out a space before it? It's I'm not a big fan of this.
Yeah, it's rather confusing.
All right. Well, anyway, so that's the problem. There are a lot of details to get right, and also some output ambiguities.
Mm-hmm.
So, uh, but yeah, I think it's just there's no algorithm to it. You just try all the possibilities.
Yeah.
Okay, let's move on.
So yeah. Uh,
30 minutes remaining.
Ishikawa Zenith now up to 5 submissions after the freeze, in addition to the 10 before the freeze.
Wow.
Uh, I believe.
I mean, after having looked at the problem, I'm not sure I blame them.
Yeah. Yeah. So even with these 15 wrong submissions, if they get it right from now with no extra penalty at minute 300, they're still first place.
Right. But they're getting close. They're getting closer.
I know, are they? Maybe they're getting further away.
What I mean is, another few wrong submissions.
Oh,
and
they're
they
getting
actually,
closer to. Okay, yeah.
yeah, they're getting closer to the threshold where they can no longer win.
Yes. Or they could be trolling.
I would be pretty annoyed if that was the case. But
I mean, I don't
that
know.
is
Like,
possible.
what else do they have to do if they've solved it? What else do they have to do other than troll?
Fair enough. It's not grounds for disqualification. So, all right, let's look back at Mid Central. So what haven't we discussed in Mid Central? Oh, I think we discussed everything in Mid Central.
Really?
Oh no, not okay. Array shifting. So problem B is the problem that a lot of teams are having trouble with, I think. I'll bring up problem B, array shifting from Mid Central.
Mm-hmm.
All right. Alice had an array A of n integers, each between 0 and 2, presumably inclusive, written at the top of her page. Then k times she performed the operation of shifting the array one position to the left, i.e. deleting leftmost element, putting a 0 at the end, and then writing that array below the previous one. And finally, in each column, she multiplied the numbers to get a new array B of length n, and then memorized it. Wait, so why aren't the answers always 0?
Only one position will be 0, right?
No, because she's multiplying numbers in each column. But I guess you don't do n operations. Okay,
Yeah,
so
yeah.
you have
Oh,
n,
right.
you have n, an array of length n and k operations.
Mm-hmm.
So the rightmost k elements of B are always going to be 0. Or yeah, they'll always be 0.
Yes.
Okay, but you're not. Wait, you're given B and you want to reconstruct A.
Yes.
Okay. Interesting.
Basically, every element of B is a product of k consecutive elements of A.
Yes.
And in particular, because so it'll either be 0, which means one of those elements had a 0 in it, or we're outside the end of the array. So yeah, 0 means at least number was one number is a 0, and then otherwise the answer, each number will be a power of 2, which tells us how many 2's were in that subarray.
And I think, I mean, I don't know this. I suspect 2 has a high, what's the term for
Order.
order? I suspect 2 has a high order modulo 10 to the 9 plus 7. So you probably do have a unique answer. You know exactly how many powers of 2 went into it.
Yes.
Right?
I'm
That's my
relatively
guess.
confident of that fact. I
Yeah.
can just search it up in Wolfram Alpha. Of course, the contestants can
Yeah.
do this, but they could also just write a Python program.
They could just try it on their computer.
Yeah.
I
Order
mean,
of 2 mod 10 to the 9 plus 7. And yeah, it's p minus 1 over 2. So yeah, 500 million.
Okay. I think there's some theorem that like half of the numbers have to have that order or something like
Yeah,
that.
it's a very high proportion.
Yeah. So, okay. So, in other words, you know exactly how many 2's are in the subarray. Like, that's basically what the information is telling you. It's how many 2's are in this element and the next k minus 1 element.
As long as
As long as there's no
or you get told there is a 0.
But if there are a bunch of zeros, that's easy enough because you can be free with whatever else you do, right?
Oh yeah, like
because you just have to recover some array. You don't have to.
yes.
You don't have to recover like the lexicographically minimal one or anything like that. So zeros are just like big don't cares almost.
Sure.
Like okay, as soon as suppose that there is a 0 at some position that's less than k from the end of the array. Um, you know that position plus k minus 1 is a 0, right?
As long as there's no 0 to the left of that, right? Or if there's no 0 directly to the left of it.
To the right of it.
To the right? Sure.
That's what I'm saying. So
yeah.
Okay. I mean, the last k elements are all zeros, obviously. So you just ignore those. Then you start looking for zeros.
Yes.
As soon as you find one, that places a 0 at a particular location. And then obviously the next k minus 1 are just all going to be 0.
Yes.
So in some sense, you've broken it up into subproblems between the zeros.
Sure.
And
I
then
think there's some extra cases if there's like a long run of zeros. Like there's many ways to fill it in, but it's always possible to fill it in with a bunch of zeros.
Yeah.
So we've just reduced it to subproblems where each value is either 1 or 2.
No, it's a power of 2.
Or like each value in A is a 1 or 2, and because of that, every value in B is a power of 2. Yes.
Correct. So yeah, what this is telling you is that this is a 0. These are all non-zero. Like this is a 0. So this is B. This is A. And these are all non-zero. Okay. And then how do you solve the non-zero case? So it's
basically, we have a count of, for every interval of length k, exactly how many numbers in this interval have a value of 2.
So using the difference between one element and the elements to its left.
Oh, so yeah. So we have the sum for every interval of length k. We have how many 2's are in the interval. So if you compare two adjacent intervals, one will be missing and one new element will be added from A. Sorry.
Yes.
So if they're different, then we know if it goes down, the power 2 goes down, then we know.
We know where a 2 was.
Yeah, we know there's a 2 on the left and there's a 1 on the right. And then if it goes up, then there's a 1 on the left, 2 on the right. Otherwise, all we know is that they're equal and they could have any value. Where any value is 1 or 2. And
not any value, because there's also a total that we need to get right.
Yeah, but basically just this difference only tells us this value.
like basically what we're going to end up with is we're going to have some twos placed, and then we're going to have this interval, and we're going to know how many twos are in that interval, but we're free to place them anywhere,
Hmm. And
I
yeah,
think.
I think also an important observation is like, so all of these adjacent intervals only tell us like they compare numbers that are exactly k apart.
Okay.
And basically like for every like for every like run of length for every run with difference k, we either get told the exact values, one or two, or we get told they're all equal, but we don't know whether they're all equal at one or they're all equal at two.
Um, yeah, I see what you're saying. Okay. I mean, seems like I would probably get this wrong while implementing, but uh, I think I understand the broad strokes of the solution at least.
Mm-hmm.
Just a lot of details to get right, I think.
Yeah.
Cool. So that was the last one in Mid Central that we
Uh,
had to discuss.
yes. And yeah, let's just like take a so it's 18 minutes left in the contest.
Yep.
I guess we can take a look at where all the contestants are at. I think we still have zero submissions for M on Mid Central.
That does surprise me a little. I do wonder if I'm missing something, but eh. Or maybe they're just all missing the fact that it's a randomly generated string.
Yeah, that's very possible.
Although one of the first things I would do is check whether it's adversarial. And the fact that it's randomly generated is right next to the message that says that it's adversarial. It's not adversarial. So
Mm-hmm.
I don't know. I don't understand. I would have expected some submissions, but I have a long track record of completely bad predictions about the finals. So
And the
I'm
thing is,
not good.
like, usually, okay, I don't know, like, usually you just try to find, like, unless you're trying to do something randomized, the fact that it's adversarial shouldn't matter.
Um, really?
Uh, like, because if your solution should deterministically work, then, and it's like, I don't know, like, there's many different strategies you can do, but, like, if your solution is supposed to deterministically work, then it shouldn't matter what the adversary is doing, or what
Like
the
you
interaction is
can do
doing.
solutions that randomize. Like for instance, the quick select thing. Like you can do things
Yeah,
that
but that's what I'm saying. Like, if your solution is deterministic, then you usually don't do
sure,
that.
but you
And
could get away with a randomized
yeah,
solution.
yeah.
Maybe
So
there's a
yeah,
randomized solution.
and you
So
really only check like only if you're trying a randomized solution would you
yeah,
actually check if it's adversarial,
yeah.
and then you would find it out.
Okay, I see what you're saying.
But yeah, still no submissions in M. Uh, yeah, seems like not many submissions. Uh,
Oh, we've covered everything in North America, or sorry, North Central as well. So we've covered all the
which
problems.
we've covered all the problems.
Go us.
Oh, I think
We
there's
haven't
one problem. Okay, Rocky
we
Mountain's
didn't manage
over,
to
but
solve them all, but
yeah, there's one problem in Rocky Mountain that did not we did not go over.
oh, what really?
It was like energy something.
Oh, energy usage. You're right. Sorry. Okay. Yeah, just to get the full set,
Sure,
let's try.
yeah.
Okay, this is problem F, energy usage from Rocky Mountain, which ended 45 minutes ago. All right, the
It's
price of
covered anyway.
yeah, the price of electricity energy fluctuates depending on supply and demand. Homer wants to minimize the energy cost of operating a factory. He has no ability to control the price, nor can he change the amount of energy required to produce widgets. But he does have solar panels, which convert sunlight into energy. Uh, okay, so I guess the solar panels only work at a particular time, and so he wants to he can purchase a battery which will store energy for use later. So Homer is predicting the following information for the next n hours. N is up to 1,000. Um, He knows the price of energy for that hour. He knows the amount of energy he'll need for that hour, and he knows the amount generated by solar panels for that hour. And those numbers are going to vary from hour to hour. And the battery is initially empty. Okay. And he can do, in each hour, he can do one or more of the following actions. Use some solar energy, use some battery energy, or purchase energy from the power company. And then after he fulfills the energy requirements, he can then also store excess energy from the solar energy. Well, I mean, I guess he could purchase the energy too, although that doesn't seem useful. But he could store excess energy from the solar panels, and then he can also sell the excess energy.
Mhm.
He
And you
can
can store the
sell.
battery, like, because the price can vary, right, over time. So it might be useful to store energy now. You
Oh, it might
buy,
actually be useful to purchase energy and then
yes,
store it. Yeah,
yes.
okay, you're right. Okay, so and then he can sell some of the excess energy, and there's a buyback plan. He can choose one out of M possible
Hmm.
buyback plans for that hour,
Yes.
which means that he sells a particular amount of energy for a particular value.
Hmm.
And he can't do like, a portion of that. It has to be the full thing.
Yeah.
And he can, of course, waste some excess energy. Okay, so there are a lot of things he can do.
But yeah, it seems to just be a straightforward dynamic programming problem of uh, given given the time and how much energy you have in the battery at the time, what is the minimum amount of money you need to spend to reach that state.
Yeah, and you always every hour the widget or like the requirements must always be met. You can never choose to not meet the requirements. So
Hmm.
yes, I think I agree that that's the full state.
So
And
yeah, it's like
you just have a lot of different transitions.
yeah,
You have to
yeah,
handle all these different transitions.
yeah. But like it's like yeah, there's like a bunch of different transitions. Just make sure you handle all of them correctly.
Yeah.
Bunch of details, but yeah. In terms of time complexity, nothing too complicated. N times B states, like O of M transitions out of the state. Uh, but yeah, it's just a very complicated.
It's more than that though, because you could purchase some power.
Like basically um,
You could purchase some power, store some power, and then use a particular plan. So
like
you have to choose both the buyback plan or no plan, and you have to choose how much energy you're going to store, or you're going to choose the delta to the battery
mhm.
plus or minus 1,000, and you're going to choose which of the buyback plans you use. And I think everything else is fixed then, because you'll use as much solar energy as you can get, and then the rest will be purchased. Does that make sense?
Yes.
So you've got N up to 1,000, B is so you've got 20,000 states, which is not too
Mhm.
bad. You get 20,000 states, you've got like 10,000 transitions from each state. I guess that's kind of large.
Or like you don't need to consider like you can have like intermediate states, which is like like you have a state like okay, here's how much is being stored in the battery, and it's uh like after purchasing the energy, like you'll have somewhere between 0 and 30 units of electricity.
Okay.
Uh, Actually, can you purchase energy and then sell it immediately, and then like without storing it in the battery?
I think so.
Okay, yeah. So then so like so like midday, you'll have gained energy from the solar panels. You'll have purchased some energy, and then like your total amount of energy will be at most like 30, and then or at most like 40.
But then you have to store how much energy you got left.
Um.
You need to store the energy that you've got available for the buyback plans.
Oh yeah, yeah. So for the Bible, so you want at most 120 units of electricity. So you've gained some. Okay, you have like so there's like 120 states from just gaining, and then
Yep.
for those 120 states, okay, you could have an edge between every pair of them to be like okay, I could buy this amount of energy, but you can also just have it the edges just be between I and I plus one, And then the way, if you want to buy 2 units of energy, you buy energy to go from I to I plus 1, and then from I plus 1 to I plus 2. So you don't need all pairs of edges. You only need edges between adjacent values.
I think I roughly understand what you're saying.
Yeah.
Okay.
So it's like, yeah, it takes it from like 1e8, which is like it was like 4e8, which is very borderline with 3 seconds, to like 4e6, which should easily pass. Do you agree with that assessment?
Yeah, I actually think it'll pass anyway, but I agree.
Yeah, it's like goes from borderline probably passing if you write an efficient implementation to definitely passing. But yeah, it should also be possible without that optimization.
Okay. Cool. That's the last problem.
Yeah. So I guess
nothing left to do but watch the scoreboards, I suppose.
Yes.
So we have less than 10 minutes left on North Central and Mid Central.
Okay, so Mid Central seems so Ishikawa Zenith up to 10 plus 13 in North Central. So if those are all legitimate solutions, I do not think they can still win.
Okay, they've managed to get enough wrong submissions that they can no longer win.
Assuming they're all okay. Let's actually calculate this out. So that's 22 wrong submissions, 440 penalty, plus 300. Yeah, it's like 730 penalty. That is
which would lose.
Would lose. However, Mad Isan from University of Minnesota has submitted to every problem. 7 submits on C, and 3 submits on J before the freeze and 1 after.
So assuming that it's 300 and 300, that would put them at 1180, and I think they're still, they would win.
They would win. So if they have all correct submissions, then they would be winning.
Exciting.
Yeah. So I think you'll be at the that's. Oh wait, no, you were at Rocky Mountain. Okay.
I'm at Rocky Mountain. Yeah.
Yes. And so Mid Central, which is my regional, University of Illinois. We'll look at those standings. So cello, first place before the freeze from University of Illinois. Still no submissions on M. Pock submitted on B early, did not resubmit, and are now submitting M. If one of their 3 submissions is correct, they will be in the lead. Or even if all 3 of them are wrong, but they still got B, they would also be in the lead because they had a much lower penalty than cello.
I'm glad to see they at least tried M.
Yes. Then slower than Python 3 in limit testing. Before they had 0 plus 1 and 1 plus 1, but since both of them have resubmitted on B. So maybe they're correct now, but both of them. Yeah, I think both of them look to be in bad position because they've just resubmitted B. Slower than Python 3 would need to solve M because they're guaranteed to be worse on penalty than cello. And limit testing would need to solve both F and M and already have a correct submission on B in the last 5 minutes, which is rather unlikely.
Yeah, like multiple wrong submissions in the last 10 minutes of the contest is usually a bad sign, except the most recent finals,
yes.
where the winning team won in the last minute, which was ridiculous.
So for those lower places, so Vandy won 4 wrong submissions on B before the freeze, 1 after, and then 4 wrong submits on L, or 4 total submits on L after the freeze, as well as 4 submits after the freeze on G. Okay. So they have at most 10 problems solved, but at least 7. And then Vandy 2, no submits after the freeze. Western University St. Louis, 6 before the freeze, and 2 submits on C and I after the freeze. So if both of their submits are correct and all of Andy's are wrong, Western University will be that third place university, guaranteed to qualify to North America Championship. Otherwise, it looks pretty confident for Randy 1 that they will have at least one problem solved, and therefore will be ahead.
Cool.
So yeah, 4 minutes left. We shall see what happens.
So is your regional mid-central split up into multiple sites?
Yes. So I know Chicago is here. Vanderbilt is not here. I believe they're at Tennessee. Oh yeah, they're at Tennessee the site at Tennessee Technological University.
Okay.
Yeah, so our site had a very interesting drama. So originally we had a computer lab that could hold up to 25 teams. But so we set the limit at 25, but we did not click enforce site limit. So that means more than 25 teams could sign up, and they did. So we had to get an extra computer lab. And this was very good, because if we had not done that, in the main computer lab that we used last year, there's like 2 rooms, but they removed all the computers from one of the rooms like less than a week ago. So if we did not have that extra room, then we would not have had enough computers. But because we'd only booked that extra room, then we were fine.
Okay.
So yeah, so some coincidences resulting in things going well for us.
At least it's easier to organize part of a regional than an entire regional.
Yeah. So in Mid Central, so there's been a few submissions. Chalo and Limit Testing both have submitted M. Which team is this? Oh, Chalo seems to be repeatedly submitting on M. Probably they have a randomized solution that is rather close to passing, and they're just submitting a bunch of times in the hope that one of their random run passes.
That is what we discussed.
Yes. I think Kaz has a submission limit of I think it's 5 or 10 per 10 minutes or something. I don't remember exactly how it works.
If you need to know what the submission limit of Caddis is, you're probably doing something wrong.
I mean, it's a reasonable strategy for M, right? This randomized solution on a uniformly random test cases.
We'll see.
Yeah, we shall see. Limit testing also submits on F. I would predict that this is just to keep the suspense for the resolver.
Yeah.
But maybe they're just working on all 3 problems at the same time. It's always possible.
You never know. We definitely do see some troll submissions at the finals.
Yeah.
In the last hour, especially.
Yeah, at the NAC last year, my team submitted a compile error to one of the problems after the freeze. So this shows up as a submission in the scoreboard.
Does it?
But it is not penalty. Okay, it showed up on some of the scoreboards. It showed up
because it shouldn't. It shouldn't count as a wrong submission, right?
It does not count as a wrong submission, but it just shows up as a submission. So in contest,
Okay.
and I think on the live stream,
Wow.
it showed up as a wrong submission, but it did not show up in the resolver.
Well, that seems like a bad edge case.
But yeah.
Maybe we should start penalizing people for compiler errors.
I mean, there's no reason to do this unless, and you can punish teams for trolling, I guess. But
well, especially at the finals, you have exactly the same environment as the judge computer, so there is no excuse for a compiler error.
Okay, that is quite true.
It makes more sense in other regionals where you could have different environments. You could have different C++ versions or something like that.
I believe the contest ended. Yes.
Okay.
So yeah.
Cool.
So Cello went from last we discussed that 5 wrong submissions on M up to 7 or potential submissions. Limit testing submitted a few extra times to F. not looking very probable for that, but we shall see. And yeah, lower down, Western University St. Louis. I think only had 2 submissions. Now have 3. Vandy 2, an extra submission on E, and yeah, those look like the extra submissions at the end.
So a whole lot is going to come down to B and M, whether they're actually solvable.
Yeah, B and M for the top teams. Well, really only for the winner from University of Illinois. Really, the only team which has a chance of winning, other than Cello, currently in first, is limit testing, because every team needs to solve all problems, and they're the only Illinois team with enough to with who have submitted to every problems. For first
Right.
place in the regional, yeah, Cello versus Puck Puck Puck, both teams could win it, and then for the third qualifying slot to NAC for the third university, it's between Vandy 1 and Western University St. Louis. And yeah, I think there's nothing else for us to discuss until we see the resolver.
Yeah,
So
I think
that's the end of the live stream.
yeah, I think we're good. Thanks for broadcasting with me,
Yep.
and
Yeah.
that was
Thanks.
fun. This was my first time live streaming, so
Yeah, with all of this, all of these different sets, there's so many different problems to look at,
yeah,
and we solved all but a couple of them. The
yeah,
flow
we had some
problem
good
and
ideas.
we're not sure if we solved Cascade Centrality, but
Yes,
yeah.
but that was good. We put in some good analysis time into each of the
Yes.
problems. So
All
yeah,
right.
thank you. Um, and I guess we'll just stop the stream.
Yep,
So
and hopefully there's some way for people to see the resolvers. Yeah, I assume the results will be on Caddis after the resolver has been read for all three regionals.
good job
And
to all the competitors,
yep,
and good luck in the resolver. And bye.
yeah, bye.
these competitions help to create and empower a new wave of talents and leaders in digital technology, and they help to grow a new generation of future programmers.
Mhm. Hello, everyone. Sorry for the delay. We were trying to figure out how to show both the resolver as well as use the Zoom at the same time. So we are running on two different computers. So we are ready to go, right? And can you hear us? Oh, wait.
Go, 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 go.
Okay. And you can hear us, right? Yeah. Okay. So first of all, thank you to everyone who has been waiting for a while, and I'm sure that you are looking forward to go ahead and see what has been changed since the freeze happened. So there was a freeze of 1 hour and 14 minutes. Now, my friend Ashwin will start to show you the current ranking before the freeze, and after that we'll go one by one to see what changes happened after you had solved different problems, attempted different solutions for other remaining questions. We already have one team which solved 11 questions before the freeze. So we'll see what changes happened since then. You will see a lot of people going up and down in the team ranking. So now once we press the button for changes after freeze, you will see that some of the teams are going to update in ranking. Uh, Please bear with us. It's a bit slow and there might be a bit of a lag because of Zoom. On our end, we can see the changes as you saw here as well that code sings from University of Winnipeg moved up a bit. They solved a couple of questions. And same with the USDA. So these are sort of like um, live changes summarized into few seconds. So we have few teams which solve 3 questions in the time. And soon we might be reaching out to one of our major site winners. And these rankings are tentative. Though we had taken into account some of the changes or requests you had made for questions, if there is any change in the ranking, we'll notify you. But as of now, these are tentative ranking. It might hold true, but be aware of any updates you receive in the coming days. So you can see a lot of changes happening here from the University of Dakota, and now we have reached to UW1, which is University of Winnipeg, and they are the University of Winnipeg champions. Uh, we should clap for them for their achievement. And after this, we will move to the next teams. And now we have Super Malware Bros from Minnesota State University, and they are the champions from the North Dakota State University side. Big round of applause for them. Oh yeah. So here you might be wondering like why we only have few sites which have champions. So we considered a criteria like only sites which have 5 or more teams will be considered for the top like champion. And the next one is ON reading time, typing time, snack time from Dart College. And the other champion from University of South Dakota. And then a lot of changes in these mid rankings. We're going closer to the top 10 now. And now we have traced back from Dakota State University, and they were the first to solve not only A but question D as well. A big round of applause for them. Wow, this is a big leap. Team number 18 went from 18 to 7th. And Robin from Carleton College are the champions from McAllister College site. And Gophers from University of Minnesota were the first to solve problem G. MTU Purple from Michigan Technology University are the champions at the Michigan Technology University side, and they are tentatively advancing to the NSE. So, big round of applause for our first team out of the four, which might be advancing to NSE. And now we are in the top 10. So, we'll be going one team at a time. You will see in real time how solving questions moved up and down the order. And the control all control all defeat from Drake University are the champions at the Iowa State University side. A big round of applause to them, as well as they're also tentatively advancing to NSE. And now we see there's a lot of back and forth between Minnesota and Madison. And Minnesota from University of Wisconsin Madison were the first to solve problem C and H. Big round of applause to them. Yeah, and they are not advancing because from the same side you can only have one team advancing to NSE. And Madison were able to defeat the Minnesota team, and they are not only the champions at University of Minnesota Twin Cities side, but are also tentatively advancing to NSE. A big round of applause to them again. And Ichikawa Zenith, University of Wisconsin Madison, were the first to solve problem B, E, I, and K. And before, like for the most of the tournament, they were leading. So big round of applause to them for all the hard work they had done. And now we are going to the team which are the champions of the NCNA region. So big B3 team from University of Wisconsin Madison are not only the champions from the Epic system side, they're also tentatively advancing to NC. No, they're also the tentative winner of the 2025 NCNA championship. They were first to solve problem F and J, and also tentatively advancing to NAC. A big round of applause to them and congratulations.
Because of the Michiwa is not influencing.
Yeah, and Ichikawa Zenith is not advancing because they are at the same side and same university as well. Otherwise, yeah, big round of applause to all the teams who were in the top 10 and overall who took part. And back to our team of Dr. Mitra and Dr. Chuck.
All right. Hey, Anugrah, can you stop sharing?
Yes.
All right. Thank you, everyone. This was great. I just want to let you know that this was a super contest. So many participants, so much ups and downs. I do want to mention, though, that we are still looking at the results, and some of the results will have to be reevaluated. So we don't really know who are the final winners. We'll let you know soon. But for those of you who have come from far, safe journey. I know it's snowing and everything. Thanks. I don't want to keep you. Good luck, and see you all next time for sure, okay?
Yeah, and I just add my congratulations. It's so much fun creating these problems. If any of you have any contacts, interest yourself, can't compete anymore, get in contact. I'll show you how to actually create problems to give to the next teams. I've been at it for dozens of years. You can see my hair's gotten gray because of it. But hey, congratulations. Wisconsin, Minnesota, and all the teams that participated today. Be safe going home. Be careful of the snow.